Hey, Buster, are you there? Have you got your guitar?
Yeah, I've got it right here. I've just been working on something new. It's a song about looking for the truth. Play it for you guys.
What are you doing? I want your shelf level or not? And if I say yes, you're gonna provide that for me with that? Yes? See the bubble? I'm familiar with the bubble, Morty. I also dabble in precision, and if you think you can even approach it with your sad, naked caveman eyeball and a bubble of air, you're the reason this species is a failure, and it makes me angry. You want to experience true level? Do you?
Oh, that's in the mind for all to face.
And it makes me angry.
Choices will be made.
You want to experience true level? Do you?
You can choose to let your mind be free.
Wow, it's so... Oh my God. Oh, Christ. Yeah, true level, bitch.
And I think that you're right.
Exactly, it's level.
Everybody knows that you're wrong.
And it makes me angry.
There are things
Wow,
in this
it's so...
world that are
my God.
objectively
Oh,
true.
Christ. Yeah, true level, bitch.
In the end, you find we're all looking for the truth.
Save it for YouTube. I'll keep looking for clues. Wow, it's so... Oh my God. Oh, Christ. Yeah, true level, bitch.
And that's my midpoint, 981.
We will watch it all come tumbling down.
But look what I did here.
Tired of the lies,
And bam, there's the radius of the Earth
tired of the obfuscation now.
Everything's crooked. Reality is poison. I want to go back. I hate this.
using this bridge,
Morty. Go to school,
computing
Summer.
the
Go on, Morty.
radius of the Earth,
And I think that you're right.
3 coplanar points
Everybody knows that you're wrong.
in 3D would describe a circle.
There are things in this world
You want to experience true level?
that
Do
are
you?
objectively true.
True level, bitch.
In the end, you find we're all looking for the
I'll keep looking for clues.
That's the thing, your vision is already being obfuscated by the spherical cap.
One of the humps
light.
True level, bitch.
We will not let these shadows
Summer. Go on, Morty's memory into a little.
radius of the Earth.
Lamp to the cosmic slaughter! Well, you seem to be in charge of what I get to remember. Why? Good question.
We will watch it burn.
And bam, there's the radius of the Earth.
Ground in pieces. From the ashes come
Yeah. True level,
something
bitch.
that is pure for all to see.
You know, we have our
It has been directly measured.
Do you?
Everybody knows that
Yes.
you're wrong.
By Jesse Kozlowski.
There are things in this world
you know, I got the idea from Belu. I'm not
that
kidding.
are objectively true.
Yeah. True level, bitch.
Fine, we're all looking for the truth.
I'll keep looking for clues. Yeah. True level, bitch. Yeah. True level, bitch. Oh my God. Oh, Christ. Yeah. True level, bitch. True level, bitch.
Let's just keep it simple. It's a
We are live. Welcome everyone. It's Free for All Friday. Sorry I didn't want to interrupt really, but carry on. Carry on.
yeah, okay, right. Sorry, yeah. So let's just say you've got a 3 foot level, and there's a bubble in the middle. Generally, there's a bubble in the middle, and you've got one at each end or at least one end for a vertical. But we're just going to use the horizontal with the bubble level. It's just a bubble in a sealed capsule, and if you lift one end, it goes, and it'll tilt to one side, and if you lift the other, it'll tilt to the other. Once you got it in the middle, once it's in a horizontal position, the spirit level, this is, it will, that's straight. You could draw a line under that with a pencil on the wall, and that will give you a horizontal. That's the spirit level. And the reason they call it spirit level is because inside of that, where the bubble is in that little capsule, is not water but a spirit, so that it doesn't freeze when we're working like low temperatures. Otherwise, it would just freeze and it wouldn't work. Yeah, but the water level device that I'm talking about is a tube, a clear tube. And we've just went through that, and it's just you've just got two ends. I mean, you've got one tube with two ends. You lift them up, you fill up with water. Try to do it. You don't. I would advise not putting it in with a tap, straight in, because what happens is you create like air bubbles inside. So it's best just to use like have you ever siphoned anything? Say if you suck on it like a straw, you can draw it through, and therefore you don't get any air bubbles in it, and it's accurate. Without the air bubbles, it's really accurate. So they're the two levels that are used I've used in construction, and I've proved to myself that they are they are true. And that's what they give that reading every single time. You'll know if your spirit level is out. You start recognise it on your brickwork, for instance. You're like, oh shit, and someone come along and say, oh. So then you can check your spirit level on top of someone else's, and if one of them's out, you're like, oh, whose is out? Is it my one, your one? You get a third one, the fourth, and you can check them to see you don't get a brand new one. That's what I do, and then you check if your old one's in or out. And you can see if sometimes the bubble does go out, even a Stabila one, which is a German manufacturer. I do tend to buy the Stabila because they last the longest, and they're robust.
German engineering.
It's all about the rigidity of the metal rod that you're talking about, not the capsule. The capsule is the indicator.
Well, yeah, that needs to obviously, that's very important, right? But they're both as important as each other. This is the calibration when these things are set up is, really, really accurate. So, but those are the two things that I was talking about. Some people get confused. If I say, we've talked about levels before, for 5-10 minutes, and someone, I'm talking about the tube, the water level device, and the person that I'm talking to turns around and says, I've used one on leveling up a shelf with my granddad or something, and you're like, so they can be confused. They can, because people think of a water level as a spirit level, basically. So there is a difference, and that is the difference. One's a tube filled with water that establishes a horizontal. The other one is a straight edge with a bubble, usually placed on the top, and then you can use that straight edge calibrated to this bubble so that it creates the horizontal. One gives you the line, and the other that gives you the line of spirit level, because you literally draw the line with a pencil, whereas the water level only gives you 2 points, in which then you can use a straight edge to join. You could use a level to join them points if you want, if it's in close proximity to check. I've done that. I've checked, and the water level is very accurate. And this is why, if you typed it in, say on Wikipedia, for instance, not that I generally use that, but it does say that the water level is the most accurate over longer distances out of all leveling devices. I'll go with that. So sorry about how long that was, but hopefully
No, it's good. I understand now. So we've got three. So three. What do you want to do? 3 mile long spirit level.
Well, like I said, it's up to you.
With multiple capsules of like the indicator thing, right, along it at intervals.
Well, say if you had one that was 3 miles. I mean, this is conceptual, obviously. It's not going to be something you're probably going to do, but let's just say there was back-to-back bubbles. How about that? Let's just say there was a bubble right next to the next bubble that's next to the next bubble, right, all the way along. Now, I'd say that was a complete waste of time, and that you only need one bubble. But if you've got plenty of money, you only need one bubble.
Yeah, I'm with you.
Mm-hmm. Yeah. So that's I don't know where you're going with it.
The bubble would be, so the capsule has got like an indicator in the middle of it to indicate where the level is.
Lines.
Right?
It's got lines that
Yeah, and it fits in between the right. Yeah,
and the bubble literally does. The bubble's made to fit inside of that, and it's perfect. And sometimes that bubble does get bigger on some of the cheaper levels, and that's why you lose this accuracy, because sort of near the line, that's time to chuck the level away.
Right. So this is the hypothesis or whatever. So we got this 3 mile long spirit level with multiple bubbles like one after another at one end. So I've got a second observer. We've got a second observer. I'm the main observer in the center. my bubble's central and level, so I can claim
Right.
where I'm standing is level, or what I'm
No, 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 no,
like
no, 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 no,
measuring
no,
it
no.
against.
This is the problem. This is the problem. Where you're standing is level. See, the way you said that means you're talking about what you stood
Oh,
on. Like, see what I'm saying?
yeah, no, I'm with you. I'm with you.
So
It's a tangent.
is
Yeah, I'm
the,
with
all
you.
you got to say
I'm
is
at
the
the Sagittarius.
bubble that you're looking at in the middle? Is the bubble? Is it level? Is the actual level level? That's what you're concerned with. Not the land, not the earth, not the water. Just
No, right.
the actual spirit level.
It's just clicked. Yeah, I'm with you.
I
Got
don't
it?
think he's ever
Then
watched
all
the My Model Dictates, the first one ever.
I don't watch videos, man.
We did it years ago. It's one of the ones that like Buster heard us talking. It was over at Science versus Pseudoscience talking to Zanuck. One of the very first videos we ever did. Where they literally, you've never heard anybody explain the model afflicted, what happens to a spirit level on LIGO. Because LIGO's a big straight line, isn't it? That's what we were talking about. You put,
Yeah. Sorry,
you put the bubble level on the LIGO.
Yeah.
And LIGO's
Don't give anyone any ideas, though, Bev.
Yeah.
Don't give anyone any ideas.
Yeah, no, I'm just telling you, that's what you have to think of. Like, well, what happens?
Dude, you know they made it a straight line on purpose.
Hold on, Peter.
Nobody says there are no straight lines that you can create on Earth. Nobody
said that.
Nobody's saying that, Peter. What are you on about?
Yeah. You all right, Peter?
Let me reword what. Can I reword what I said? So where the observer is not level. It's creating a horizontal plane from that point, right?
Well,
is that more
from
accurate?
let's just. But why don't we make it easy and just say you got point A, B, and C, which is A at one end, C at the other, and B in the middle. You got one straight line, one level, that's 3 miles long with 3 bubbles. I mean, I don't even know if. I mean, I don't even think that it's worth considering that it wouldn't be. But I mean, let's just. I mean,
I don't think gravity is involved.
It is
right?
not in the generic case.
Hold on, Peter. I haven't asked the question yet. So what I was trying to say is, if you're looking at that bubble from point A, it'd be in the middle, right?
Yes. No,
Right.
well, the thing
Hold
is.
on. Yeah, go on. Yeah.
Because it's like local based and gravity is kind of involved. But I don't think it is. I think it's pressure mediation, and it just goes in the middle of the extremities, the bubble, right? So what this capsule, the bubble's always going to be in the middle if that point is level. But I get what you're saying. The further on point it's A and C, if there was an observer there witnessing it.
Well, there is, not if. There's an observer at A, B, and C. They're looking at the bubble on the level that's a straight edge. It's an impossibility that it's anything other than not in the middle.
Can I present a possibility? Can I present one?
Good thought experiment. It's exactly what he's drawing on. Go on,
Imagine you take that point on the edges and you move it so far out that the gravitational field is much weaker. What do you think happens?
Right, what do you explain to me? Explain how you got there, Peter? Because we're just stood there, and the level's a meter off.
Okay.
Where I'm stood at one end, and it's a meter off the other end, and it's a meter off the middle.
When you calm down, I'll explain. Yeah. So when you look at point B,
don't need calming down, Peter.
Are you ready now?
It's just the way I talk. You're the one who's swearing generally.
Okay, I'll wait until you're ready.
Yeah, you're the one who needs to calm down. Yeah.
I think it's now. So when you look at point B, the gravity vector is perpendicular to that level device, correct? I'm talking to the dragon, yeah. Now, if you imagine the level being super long to the left, even in this picture, which is obviously not to scale, right? The gravity vector is no longer perpendicular to the level, correct?
Right. Yeah.
So it's going to pull the bubble at an angle.
Well,
like it's not a normal vector to the bubble. It is at an angle, right?
I'm just unsure that
this is called tidal forces. They're different.
Is
Nothing to do
is
with
gravity
ocean
doing
tides.
that though? Is gravity
Yes, of
making that
course.
bubble appear in the middle?
Of course.
But
In
isn't
reality, yes.
it? Yeah.
In reality,
Okay,
not
carry
in,
on.
in some dreamt up world where like things fall because they have relative buoyancy density bullshit, but
No,
in
it's just super
reality,
theoretical right now. I'm with you.
yes.
I'm with you.
In reality, this is called tidal forces. It's not to do with oceans. It's just we use the same word because the vector of gravity is changes as you move away. Like it's not at a normal angle to you. It's not pointing down, so to speak, in that sense. So as you move out, you're getting pulled in at an angle, right? Not straight down, but at an angle.
Get it?
So that's why the level would
Is
experience.
this making sense? Is this making sense to anyone?
Of course it does.
No.
Apart from you,
It's not about
Peter.
the divergence.
Total
It's talking
bullshit.
about the divergence.
There's a
I get
different
it.
force acting on the thing at B than
Hey,
there is at
Peter.
A. This is also
Peter,
why
is
you
the
die
ball in the
when you
middle?
fall into
How
a
can
black
you
hole, by
prove
the way.
that there's a
Peter.
different force?
He's using the law of
Yes.
imperceptibility.
Peter, is the bubble in the middle?
At B, yes.
Is it in the middle at A?
In the middle at are these two different levels? What is
Where
This
is
is
the
one level,
bubble
Peter. Are you
at
sticking with
A,
us?
No.
Peter?
I'm drawing
3
it, and
miles
it should
long.
explain
So,
everything.
can you explain
is-
it to him, please, Dragon?
No, don't
I'm
draw
going to
it.
draw
same
it. I'm
level.
going to draw it.
Don't.
No. I mean the level. I'm just saying he's got a 3 mile long level
He
with 3 bubbles.
knows.
Point A, B,
Spot on.
and C.
Spot on. Peter
You're
knows
showing two
what
different
he's
levels
doing.
in the picture. You're
Oh,
showing two different levels in the picture. So what do you mean is it in the middle?
I'm not showing any pictures.
No, I'm going to do it in a minute.
Don't worry about the pictures. Don't worry about any of it, Peter. You just come up with some weird shit.
Have you heard
I
of
It's a
posted
cool
a picture
experiment,
for
man.
you
Can
earlier.
we just give
You
you a
ignored
quick
it.
example that everybody can get an understanding of, right? LIGO. Yeah? Have you heard of it, Peter?
It's in my state. I could drive there in 2 hours. I could be there in 2 hours at
Right,
LIGO.
okay, so
yeah.
you're not far away from which one? Which one is it?
The one in Washington
Livingston.
State, you
No,
dummy.
not Livingston then.
No, not Livingston.
Okay. So
Dummy.
that's a shame. But dummy. Okay.
How many times
Wait,
did I
so
tell you I
it's
live
a
in Washington
big
State?
it's a big straight line, right, Peter?
A part of it, yeah.
Right, now you've got a bubble level.
Part of it.
You've got a bubble level.
The floor is not level.
Peter,
The laser
Peter.
path is.
Peter, you've got a bubble level. You're going to go to the apex with the bubble level. You're going to put it on LIGO. What's it do? Where's the bubble?
If you're able to measure that tiny difference in gravitational field, it is not level.
The bubble isn't in the middle at the apex.
Look at the picture that I shared. This is what we mean.
Yeah, Peter,
Gravity
at LIGO,
is not always
at LIGO,
perpendicular.
if we put the bubble level on LIGO at the apex, where's the bubble?
Is it the bubble?
Where is the bubble?
Answer the question, Peter. Stop taking
Draw
the piss.
this. What's the apex?
Apex of two lines, like angle.
Where
Vertex.
the two lines meet.
Yeah.
LIGO.
Which two
Peter.
lines? Which two lines?
Do you know how LIGO works, Peter?
Yes.
Right. Do you know that there's two arms of LIGO
Yes, I do.
that are perpendicular to each other, right, Peter?
Yes.
Right. Do you know where the apex of those two arms is?
I don't know what apex means in this context. Do you mean the
Where the two
intersection?
lines meet. It's
Where
where the
they
control
meet.
box is.
So
Yeah, where it all goes
intersection.
on.
Intersection.
Yes, where they
Yeah, that's
intersect,
it.
yes.
So why do you say apex? Because it's cool to say
well,
that?
I thought you might understand it, but don't worry about it.
Intersection of two lines.
Okay,
Don't
the
worry about it,
intersection,
yeah.
right, there we go. If that's better for you.
Yes.
Right. Where's the bubble?
Where is the bubble?
Yes.
Let me think. It depends on whether they took the two, where the 2 points, where were the tangents? Was the tangent at the intersection or at the 2 points?
I don't know. Aren't they both tangents? They're both
Well, the
straight
answer
lines,
depends
right?
on that. No, not on the globe.
They are both straight lines, right? The two
They're
arms
straight lines.
of LIGO, they are straight
Yeah.
lines, yes.
Yeah, absolutely, yes.
So where is the bubble?
I could draw this for you. On a 3D model.
You could draw LIGO. It's already been done many times.
I could draw LIGO for you, yes,
okay,
to
and then
prove the point.
you put the bubble right on the intersection and then put it at the other ends of the arms. Like, tell us where the bubble is in relation to the spirit level when you place it in those positions.
It depends on whether they
B and C.
Yes.
That's what you could do. You
Yes,
can mark
I
those 3
understand.
points, A, B, and C, and show us
I
what the bubble looks like when it's placed upon those positions on LIGO.
I understand. So if they chose
Oh, wait a minute. I might be able
the
to show you where the
intersection
tangents are. There
to
you
be
go. The tangents there. There's one at one end, and there's one in the intersection. Apparently, FE dogma.
right.
Check
So
him out.
which one? Which did
So
they
the
choose?
tangents
The
at the end of one.
motherfucker's
That
gonna
may be
talk over
LIGO.
me
I
all
don't
the
think
time.
that's what Washington though.
Ja pierdolę, co za typ, kurwa.
We don't know where. We don't know where Washington is.
Napierdala non-stop.
No
Non-stop
swearing,
będzie
please.
napierdalał. You're gonna just like diarrhea all over me with your words, aren't you? You cannot do a back and forth where you tell me something, I tell you something. You just gotta keep going and going and going. Tell me this. I've been trying to ask you this question. Is the section point what they chose to be? Mother.
Yeah. Nathan Oakley sounded like that today. Did you hear him?
If I had you at arm's length, I would talk some sense into
So you cannot answer simple question.
He can't.
No, he
You
cannot.
are really
He's
dumb.
unable.
You are dumb.
He's unable to answer a simple
You
question.
you are yes. Where are bubbles?
Iди nachuj.
Draw us a picture. Show us
In which
we've had a
language
few-
you are speaking?
I asked you a
people doing
question, Bev. I asked. This is the last time I'm going
Was
to
that
ask
in
you the same
English?
question.
No,
That
ask.
foreign language that
Yes,
you're
it was.
talking
I
about.
just misspoke.
Question
It
was
was
for
my
you.
accent.
You didn't answer. Where
I am
is
asking
the
you a
bubble?
question, Bev.
No,
When they were
don't
constructing LIGO, which point did they choose to be level? The intersection or the other 2 points?
The arms of LIGO are level, aren't they, Peter?
The arms are straight lines.
All 4 of them, Peter.
The lines are. I'm pretty sure these tubes or whatever tunnels, whatever you want to call them, are straight lines, not
Yes.
curved. Yes.
Horizontal,
Yes.
let's say.
Yes, and I'm going to tell you this.
So they're the level,
Points-
right? Remember earlier when you said level
Yes, yes.
is horizontal? Well, if
I'm
they're
giving you the answer now.
horizontal, then
Are
they're
you
level,
ready
aren't
to
they,
receive
Peter?
the answer? Are you ready to receive the answer?
I've already given it. You've already told
Okay.
me.
The elevation of the intersection is different than the elevation of the ends of the arms. Thank you very much.
What they're horizontal?
Yeah, I've got a
straight lines, right?
presentation. Can I have streaming privs, please, Bev? I just want to show this.
I don't know. You'd have to get one.
I think
of the mods
this
to
will
do that.
solve it.
So you're saying that they're sloping, Peter? Are they?
No.
What they've? Didn't you say that they have
Just me.
different elevations, Peter?
Yes.
But
So
you said they were horizontal.
They're horizontal.
They have different elevations. He's right.
With no slope.
Yeah.
Says Peter.
This is what I'm getting at. Can we fast track this mod giving thing, please? I just want to present this.
Well, we
We
know
know what a
problems in the
slope
past,
line
mate.
looks like.
Yeah.
But Peter, we want Peter to be showing us. Like, show us this horizontal line.
That's
with
what
a
I'm doing.
change of elevation and no
That's what
slope.
I'm doing, brother. This is exactly what I'm doing.
You're drawing it,
Yep.
Or are you doing it
or
live?
are you drawing it by
this
hand or on a computer?
By the computer.
Well, that's not drawing it then, is it?
Well, wow, you're so smart, man.
Well, I'm just saying, that's you're not drawing it. So what's the point in saying you're drawing it? Anyway, carry on.
He's
So
drawing
you're doing
a
something. on the
You're
computer.
amazing. You should do more of that.
triangle.
More
He's
of
doing
that.
a 540 degree triangle.
I need to leave and come back in 1 second.
Is this LIGO, Peter?
Yes, this is going to be a LIGO.
Is it perpendicular?
Why have you done a ball?
That's the Earth.
He's doing the 3D.
I thought you were doing LIGO.
You're meant to be doing LIGO, Peter.
LIGO, not the ball.
Wait, you'll see it.
I think his idea is it's got multiple arms, and he's going to put them in like an X, right?
Exactly. I'm going to show you the model
of the thing, but he's drawing a ball for some reason.
I've got the roll, but I can't stream still. I don't know if that's something up. I don't know if I got the right roll or not. Maybe it's the rank I've got can't stream or something. Oh, thank you. That's the one.
You're very polite, Dragon, I must say. You sound.
I'm trying to be the mediator of this, man. I don't want to get it. I don't want to let it get crazy, man.
Is that a Christmas bauble for the tree?
I like your style. I can't even see it. Can someone explain it to me? Because I literally can't see it. I like.
Everyone's just drawing circles. We said LIGO, guys. What the fuck's going on? You're mad. Do you know LIGO's like 2 straight lines? Doesn't require you to do circles at all.
Don't freak out.
Is this being shown to the live stream directly?
Which one?
I don't want mine to overlap.
Everybody's just decided they want live streaming roles and they want the picture going to YouTube or something.
No, let Peter do his presentation. I just want because I'm showing something.
Peter's lost in Aporia.
Should I show mine then? And then Peter can try and improve on it.
Well, yours is a circle as well, isn't it?
Yeah, but watch. Right. So
who are we meant to be watching here? Peter or yourself?
What's going on?
I think he's resigned.
Turquoise has got a circle going.
Right. So we've got mine. This is the Earth. Right. We have a line. Yeah, it's a
Yeah, it's not the Earth. It's a circle.
Side view, and there's my spirit level, right? With the
still
bubbles.
A circle. It's not the Earth.
Oh, so
No, I'm
a Brazilian spirit level?
This is to make this is the gravity variable we're trying to introduce, and the fact that the angle is going to be different the further we go out, right? The further we go out on this spirit level.
What angle?
You must be.
No, you'll see the angle in a second, right? So you see the spirit. No, the bubble. See the spirit level.
Brazil.
The spirit level.
Yes, Brazil.
They have a bubble, right? This one here, it has a bubble in the middle, right? And if it's level, it's going to be between those.
It's got a circle
between those two.
I don't think you.
Yeah, that's.
Hey, I'll tell you what you got there, mate. It looks like you've just measured a hump. You've measured a hump there, mate. To be honest, that's 3 miles long. Then you got a hump.
No, this is like a fucking 8,000 mile fucking spirit level. I'm just trying to exacerbate.
We were talking about LIGO a minute ago, mate. We were talking about LIGO, though, aren't we? LIGO's only what is it, 4 kilometers?
What's going on with the imaginometry here? I mean, guys, you realise what we're talking about?
This is like the diameter of the Earth. Diameter of the circle.
It's like 8,000 mile fucking spirit level, okay, right? This is a hypothetical, right? So, right, the observer is here, right? I'm holding the spirit level somehow in the middle. This is locally level, right? The bubble is in the middle of these markings. Can you let me? So the bubble is showing level for this observer in the middle, right? It's between those two markings, like you said, on the capsule thing, on the spirit level, and the bubble is residing in between that, indicating this is level here for me. As we go like 5,000 miles this way, this bubble, would it be between those two lines? Is that the theory, or is the gravity changing the middle? That's what we're asking, right?
Look, mate,
the middle.
Like I said, what I'm saying is, if you had one at each end, yeah, You have one at one end and one at the other. A bubble at one end, and ditch all the other bubbles and have two. You got one end and the other. Don't worry about the middle bubble. You just got one at each end. If both of them are in the middle and it's a straight line, the level straight, then that's it. Nothing more. Nothing less.
So if this
guy looking at it.
You've put a level on a circle. Right? In reality, right? In reality, you've got a level and you've put it on a circle. Now, are you going to imagine that those bubbles are any different over there?
Yeah, this is the next bit, right? So we've got this bubble here, right? Transparent view, right? Oh, no, not that one. Transparent selection. So what's the theory? Oh, fucking hell. Transparent. So is the bubble... Where is the bubble going to go? Is it going to conform with the center of the Earth on the extremities, or is it going to be in the middle?
The bubble is in the middle.
I just explained LIGO.
Hold on, let's finish with this first. But
so what's the theory then?
Dragon, what I'm saying, you want to hear my theory?
There's no theory about a level. Will you stop acting like there's some sort of theory? This is a practical tool.
Yeah, Bev, but it's only measured. It's only for. It's local, right? This is what I'm trying to show.
No,
it doesn't work.
Whoa! The definition he gave before that said local was for a water level. Right now, what the water level means is that there are 2 points. Right? One at each end. That's the locality of the water level, where the water is. It cannot be used for any other purposes outside of the locality of where the water is in the water level. Do we understand what the locality of that means now, right? Because
so
you're talking about a bubble level.
A bubble.
Not a water level.
And if the bubble is in the level, and the level is straight, and if one bubble is saying it's in the middle, the whole thing is level.
Yeah, that's what I was pointing out about LIGO, right? LIGO is a straight. Now, you can extend the length of your spirit level by putting it on a straight edge. The straight edge example was LIGO. So a little 6-inch bubble level will suffice. Now, where are you going to put the bubble on your little 6-inch level on LIGO? And would the bubble move wherever you placed it? That's just a question Spot On was saying.
And here's the answer. The answer is on your screen.
The answer's not on my screen because I'm on a different screen.
Because you're ignoring the answer. That's your right.
On your screen then.
Yeah,
well, I will
it
move
is on the stream on your
then,
screen.
And
yes,
everybody can see
yes,
that
yes.
It's not
my screen
on my
is
screen.
On your screen. Yes.
Right, okay. Right now, so this
You're
is
Peter
the Globe Prover, and
explaining LIGO to Beviites.
Okay, go on.
This is LIGO.
Frantic bunny ears.
Now watch the crazy come up now. So
hold on, Peter. Let's just clarify one thing. Have they built LIGO on a fucking hill? Because if that's 4 kilometers, that line, then it's just on a hill.
No, ignore
it's
the
obviously
circle.
not the scale.
Ignore the circle. It's got nothing to do
Ignore
with
the
scale.
LIGO.
He's describing LIGO on a hill.
This is they built LIGO in reality, and in reality, the Earth is curved.
Yeah, and LIGO's not on a fucking hill, is it?
No, this is not a hill. This is a surface of the
why
Earth.
is it on a hill then?
It's the Earth.
It's just got
How
it on
big was the
circle.
wedge at the end?
This is not LIGO.
This is LIGO.
No.
There's nothing like LIGO.
Perfect LIGO. Perfect.
Nothing like LIGO.
It's identical to LIGO.
Toothpick tangents, do you reckon? Anyone? Peter?
Beautiful LIGO.
Yeah. Where is Wally?
Yeah. Yeah, you're not the first person to do this, Peter, but yeah, go on.
LIGO.
Are those arms, Peter, are they horizontal?
Absolutely.
Okay.
You can see, right?
So,
Perfectly horizontal. Yep, perfect.
Okay.
So what
Perfecto.
did they put a big wedge under the end there on your model?
No, they just built them a little bit higher elevation.
On
In reality,
legs
it's a very
Peter.
small difference.
Peter, you said it's horizontal. Are you saying
higher
there's
elevation.
a change in elevation?
Absolutely, because
Of the
like
horizontal?
yes, as we know, in reality,
Everybody knows that
2 points of
horizontals
equal
don't change
elevation
in
are
elevation.
not on the same horizontal plane. Everybody knows that.
No, everybody knows that there's no slope to a horizontal.
Everybody knows that.
And you said earlier that level is horizontal, didn't you? Definitely.
Level is horizontal.
Absolutely.
I said that.
So is it curving?
No, the
curve,
arms.
yes.
The arms are
Oh, the arms
horizontal.
curving.
Level is horizontal, so therefore the arms must be level.
So on this model, then did it have legs under the end? What supported the end from at the ends there on the?
It's only on his model. It's not to scale.
Yeah, on that model. Yeah,
This
but,
is
you know,
the
there must have
problem. They
been
always
something
come up with
underneath.
these not to scale models. There's
He
never
has to
one
draw
to
the
scale
circle.
ever.
Have you got the plan there of LIGO? Can we see, you know, how they packed it underneath? Apparently, then.
Doesn't matter about the Earth underneath anyway. We're talking about the straight line. Not to you. That's not directly at you, Bird. That's Let's
No,
get
I'm just
to
trying to
this.
understand his model because he had models the other
What
day.
you're
we were trying to
doing,
understand.
what you have to learn through all of this is ignore the pictures. Right, because they'll just confuse you. It's like a magic trick. It doesn't concern you. We're all only bothered about these arms because, like, you can build all of that sort of stuff up.
But logically, you'd have to do that.
In the photo, the difference would be like inches. Okay, obviously mine is exaggerated on purpose.
Inches.
In
It's
reality,
always exaggerated.
How far?
I
long
thought
are the arms?
How long
I thought
are they?
I thought he said it was exactly LIGO.
It is exactly the geometry. Yes, the
It's
scale.
exactly LIGO, you said, but now it's a little
because I'm trolling you because
little
you
different.
haven't done geometry.
Oh, you're trolling. You're
Of
trolling.
course.
Okay,
Of course.
all right. Thank you for clarifying
So
that.
Well, you
Good.
can embarrass
From the
yourself
beginning,
by
yes.
saying,
From-
I don't think picture
you're
to scale. Oh my god, my hair's blowing up.
In a picture like that, then yeah, we know you're trolling.
I could make it to scale, but I'm trolling you with not to scale diagram on purpose.
No, you're trolling us with the whole thing. Go on.
No,
Where are you going with it?
You just live. I mean, it's hilarious to listen to you lose your shit over.
This is the ultimate globe prover. This is great.
Says the guy that
Peter's
the guy that thinks the middle of the water level is different than the outsides. Nice one, Peter.
Dude, you do realize
Thanks
you're
for
like
being here,
1
Peter.
percentile of globe's population retarded, yes?
So
say that again.
Do you realize that you're in a 1 percentile of globe's population of people who don't recognize that the Earth is curved?
Look, I go out, I see
ridicule me.
I work on a building site.
Let's not lose our composure, guys. Let's not lose our composure.
No, I'm not.
But Peter,
no, but I just want to say,
I want to say, Peter, we can see that the Earth curves, right? We can see mountains.
I
and
come
valleys.
here for the delusion.
All of
I come
us
here
here,
for your delusion.
Peter,
That's my
can
enjoyment.
see that.
Exactly.
Otherwise, it's a waste of time.
We can all see that, Peter. So stop calling people retarded, Peter. Please.
They're just retards.
He has to, because this is his proof. This is his ultimate globe proof.
He thinks people can't see curves.
Yeah.
Like, what's up with him?
I don't know.
I was going to say, the customer, if they want to say, oh, I want like a hill over there, can you create a hill with some soil? Yeah, I'll do it. That means that I created a curve. I can see a curve. It's not a problem, Peter.
Peter thinks people can't see the curve.
Ah, it's weird.
Yeah, he might have been listening to people who think it's flat. Is that right, Peter?
Yeah,
You think
possibly.
everybody thinks that it's 2D? They can't see the curve.
Yeah, he goes quiet.
Yeah.
Okay, so
Sometimes.
what about these bubbles and levels? Because that was the question, not answered yet.
Well, sadly, go on. Sorry, mate.
No, I'm waiting for answer. What about bubbles with that LIGO? So on that model, where?
Oh yeah,
would
let's
you
go back
put-
there. Yeah.
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 How
Where are
would
you gonna
they
put it?
behave? In the middle, in 3 points, or differently? Just to answer this question. According to the model, how would they behave? Or according to reality, how would they behave? We are waiting.
He's doing some.
Was
Blue
that a
Marble
question to
stuff.
me? I was not listening. I was focusing on something. Was
Yes,
that
we
to
are
me?
not listening
Well,
to.
Oh,
It was
okay.
a question
Actually, won't listen to you for 20 minutes.
like
Doing his
10
colouring.
minutes ago. How would these bubbles behave in, let's say, Carpenter's level? That was our original question. Bev
Yes,
asked.
Carpenter's level points to the vertical, allows you to establish the horizontal line at the point that you're standing at. Yes.
Yes, so if they are perpendicular,
Horizontal
and
points, did you say?
At the point where you are, it allows you to establish the horizontal and therefore also the vertical.
Okay, so the question is, if you have 3 bubble levels at point A, where is intersection, point B and C, 3 levels.
Beautiful.
So, and they are on straight lines, on the same plane. So
yes,
what would they show?
One would show level, the other two would not in this diagram.
Strange.
Only 1 point.
I knew he was gonna
Reality.
say that.
We're talking about reality. So let me address your question, mister. This is the plane that these points share, right? The blue plane on the screen right now is the plane that they exist on,
Are
correct?
you sure, Peter? We've got Blue Marble
I'm absolutely
Science.
sure.
I've got an elevation thing of all of the points. It says there. It says the orange
But
line.
you're talking to me.
Yeah.
Now you have the honor of speaking to me.
Okay, in the live chat.
The privilege.
In the live chat, because we've had a few people. Hamford, is that your one?
Oh,
absolutely.
Okay, right. So it says the orange line is the straight line connecting the start and the end of the LIGO northwest pad at Hanford. Right, that's the start and the end. The orange line. The blue lines are the actual elevations. Welcome to the globe. But you've got them all on one plane. How can you have them on one plane? Because the orange line is the straight line. No, look. The orange line is the straight line. The blue line are the actual elevations. Now, they're not on the same plane because the orange line's a straight line.
What are you talking about? What are you showing?
The elevation, the LIGO, Hanford, Northwest Arm elevation points from Blue Marble Science.
What's that?
This is
in
genius.
the live chat. Blue Marble Science.
Well, isn't that what I'm showing on my screen?
Don't run away, Peter.
Yeah, no, it's in the live chat. Everybody in the YouTube can see it.
Yeah.
The northwest arm.
Yep.
So the arm
LIGO
pointing northwest.
Yep.
Yeah.
And it says
is over
the
different
orange
elevation.
line is the straight line connecting the start and the end of LIGO northwest pad. Right. So the orange one. But the blue line are the actual elevations of the pad.
Okay.
So that's
exactly.
is that
so
what you're marking? The actual elevations?
let's
Because you've got
think
them on the
through
same
it.
plane, haven't you?
Peter's gonna do a mulligan here, guys.
No.
Yeah,
No,
yeah, you have to do a mulligan. You have to take a mulligan.
The level of
committed.
crazy here. So there is a straight line A to B, correct? Is A to B a straight line?
I think the arms of LIGO are straight lines, yes.
Absolutely.
I would say they are.
So absolutely. So let's walk through it. A and B are on a straight line, right?
And they're at the end points, right, of this.
Don't say too much. Just answer my
Start
questions.
and end, A and B.
Tell me.
Yeah.
The point is for you to find a place where you will disagree with me. So just answer my questions until you disagree, okay? Points A and B are on a straight line.
At
yes
the
or
end points, yes.
Don't fucking say anything else but yes or no. Points A and B
Watch
are
the
on a straight
language.
line.
We're live on YouTube, Peter. Watch the
Oh,
language,
that sucks.
please.
Don't piss me off then, Bev.
Watch the language, Peter, or you're going away. I'm the head mod here. Watch the
Head
language.
honcho. Bev, yes or no
Just
answers
pay
only.
attention,
A
audience.
to B.
You're about to get timed out, Peter.
Don't give him an
You're not
excuse.
doing yourself any favors, Peter.
Hey, Bev. Are points A and B on a straight line? Yes or no,
Does
please?
this sound like a
I don't
kind
know,
of educated
Peter.
man?
What does it look
Points
like to you? How
A
can I
and
help you?
B at the ends of the straight lines, Peter.
Are points A and B on a straight line, Bev?
Have you got them marked, Peter?
Are points A and B on a straight line
Are they
in
on
the
the
picture that I'm
Peter?
showing? Yes.
I can't see the points.
Then I cannot be
The
debating it.
tiny
with you, can I?
little letters, Peter.
Are points A and B
Still
on
can't
a
see,
straight line?
Peter. I can't see them. I don't know. It could be 1 and 2, but as far as I know. Everybody else can see that. Like, we can't tell if A and B are
dead
on a
on now.
fucking straight line or not.
Do we have to follow that orange box, that red box? Is that what it is?
Are A and B, points A and B on a straight
Where's
line?
A? Where's B?
Why don't you make A and B a little bit bigger so we can all see it?
Yeah. Have you got the font bit? You see where the fonts?
You can make
You
shapes, but you
change the
can't write
size of
letters.
the fonts, Peter. It's a bit. Have you used a computer before?
He can make fucking what he thinks is a circle on there.
I think you did study computer stuff, didn't you? And you were a teacher, so
Just a
it's
little
very
bit.
invaluable. Yeah. Well, for the kids at the back of the class with with bad sight, they can't see a thing.
Or cognitive disabilities.
Yeah, I know.
Just get everyone a set of glasses.
Don't worry.
Are you trying
worry.
to prove a flat Earth here, Peter?
No, I'm explaining to you
Are you
LIGO.
trying to prove a globe Earth here, Peter?
Is this reality?
Or are
Peter?
you just
reality, yes.
Okay.
Right. So is that A and B? Are they horizontal?
Is the big circle really necessary?
They are on the horizontal plane.
We're talking about a straight line.
Oh, really? What, 2 points
Absolutely.
that are horizontal? Oh,
Absolutely,
right. I thought you said that if you had that, you lived on a flat Earth.
If they had the same elevation, which clearly they don't.
Well, they are.
Which is the
I'm
point
looking
of
at
the
it.
diagram that Bev showed.
They
Are you
though.
saying that 2
They
points
are.
on a horizontal don't have the same elevation?
Absolutely.
Well,
Well, there
your
you go.
picture
Case
looks
done.
exactly.
Case done.
Picture
You can
looks
see it.
horizontal.
You
Is that
can
what
see it.
is that what happens on a globe, Peter?
Absolutely. Yeah.
So horizontals have differing elevations on the globe.
Yes.
Right. Well,
For
in
the
reality, they
children,
don't.
for the children watching this on TV, point A has elevation of 0, and point B has an elevation of greater than 0.
See, this is
It's
why I have
very
a problem with the
obvious.
globe, Peter, because in reality, we have tools called auto levels, and they establish
you're
a
such a
horizontal
dummy.
plane of reference. And
Yes,
all
yes,
of the
the blue
points,
plane.
all
Yeah.
of the points on that plane have an equal elevation.
And unfortunately, in reality, that is not true, and it can be measured very easily. I rest my case, Your Honor.
You can measure the change of a
If you a
horizontal
person
in
a person
elevation
who
with a tool
believes
called
a
would you
person
use a
a
level?
person
Yeah, well, how do you check it? How do you check the horizontal? He measures to the ground, and if it's different, he's like, "Oh, the fucking horizontal's out."
a person who believes what you just said, Bev, is true is
Right, that's
known
what
as a flat earther, and a
Mhm.
person who believes that it's not true is called a normal person.
That's what you've drawn there. You said it was horizontal.
It's on a horizontal plane from the point of view of
yeah.
A.
Yeah,
Of the same
doesn't-
elevation.
Isn't a water level
Mhm.
a tool for establishing a horizontal plane of a local?
Water is level at every point, yes.
Horizontal, you said earlier.
No.
You read it. It's the tool for establishing a horizontal
Yeah,
plane.
it
You
was
read
in
it.
the definition.
At
of the
a
tool that you
local
read.
point. At a local point.
No, local
point.
to the water level, Peter.
Yes. Yes,
The
water
body- the
levels
body
are
of
used
water.
to establish the horizontal plane at a local point.
The locality
There we
of this
go.
is where Turquoise Dragon was getting you before with the bubble. When you have a water
Yeah.
level, there's no bubble in the middle. You're using the end points, just like you do with geometry.
Oh, Dragon, I love the picture that you shared.
Yeah. Now
That's
do
what
the
I was
same thing
trying
with a
to say.
water level.
Don't get distracted,
Yeah,
Peter.
so-
Two end points.
Right, yeah. So use the water level instead of that straight line and depict that.
And it's going to show you some kind of point between the
From
two points.
Equal elevation, right, Peter?
Equal potential of the gravitational
So
field.
would you be able to
Oh, then draw
measure
that.
up from one of the ends to find
don't know
out
what
where the
oop
horizontal would be?
Remember, he
what
don't
is
know what he's
oop.
talking about when it comes to level and horizontal. Just remember that. 'Cause he's never.
Are,
really
any
used the
questions about LIGO?
Peter.
How big was the prop at the end to support it from dropping?
Very tiny, because it's only a few inches at that distance at best.
Yeah, use the water level. Let's see what you could do with that.
Yeah, you know what you should do? You should come here. We'll go to LIGO here in
Measurable.
Washington State. We're going to ask to talk to the guy running LIGO. We're going to say, dude, you should use water level. And we're going to see what he says.
He's
Yeah,
gonna
well, he'll
laugh at you.
establish.
Yeah, he's going to
No,
chase us out.
wait,
points of equal elevation.
please, everyone, fucking stop this shit. Peter, what are you
Use a water level.
What are you trying to do?
Explain to you how LIGO was built.
No, you know nothing about how LIGO was built. You know nothing about geometry, and you know nothing about building. You know nothing
Well said,
about
Ben.
surveying.
Recognize that
I
circles
don't know what you are doing, Peter.
I'm showing you what it
You
means
are showing
that 2
us
points
a model
on a
affliction.
horizontal plane
It's
do
a
not
straight
share the
line.
same elevation. You see? That's what I'm showing you.
But you realise, I'll say it once more, Peter, a tool for establishing an equal elevation is called a level. That provides
No,
a
that's not what it
horizontal
establishes.
plane
Absolutely
of
not.
reference.
Absolutely not. You made that up. A level is not used to establish 2 points of the same elevation. Absolutely
yes, it is.
not.
Why is it called
No,
a
it's
water
not.
level then, Peter? Why is
Because
it
it
called a water
finds
level?
the level, it finds the horizontal at a given point.
Which point?
I
It
agree with
finds
that.
the tangential plane to the local point.
Where's the point that a water
Point
level
A,
is
point A.
horizontal? Where a
Point
water,
A on the
Peter, the water level. Where's the point that it's horizontal?
I don't know. Depends on where you deploy it, I guess.
So we go from A to B. A water
Just tell
level.
them points can't be horizontal.
Where's
and cut
the
it short.
point that it's horizontal, Peter?
I don't understand the question.
There's a water level, right? It goes from point A to point B. These 2 points are an equal elevation, right?
Okay.
Where's the point it's horizontal?
I think it will be a point on the plane that connects that the 2 points lie on, but that's not the horizontal plane.
What is
Oh
it then?
my god.
If I imagine the operation
What
of the water
is
level,
that plane called, Peter?
it's the plane that you can draw that the 2 points are on.
A horizontal plane, right?
The
No slope.
horizontal.
No, that's not the horizontal plane. I am showing you
So
a
is a
horizontal plane
horizontal
right now.
plane-
You're just ignoring.
Is the
you're just
horizontal
ignoring what I'm
line
saying.
longer than that line between A and B? That plane just made?
No, that is the straight line
That's
connecting
the
the
shortest
points.
distance between those 2 points
Yes,
at an equal
yes.
elevation. Do you not call
No.
that horizontal, Peter?
No,
Why
no.
not?
That is because that is not the.
Would a horizontal be longer than that line?
Jesus Christ, I
Peter?
can't keep up because every time you say something, I have to convert your words into reality and then back. So go slower. Ask me questions slower.
You've got point A and point B. We've established there is a straight line between the 2 points.
Yes. Are those 2 points same elevation?
Yes.
Okay.
It's a water level.
Say sea level. Let's say sea level.
So if I say that line's horizontal because there's no elevation change. Now, you, Peter, do you say that's horizontal too?
No.
Right, okay. So the horizontal would be longer than that line.
If I draw this for you, will you look or will
Peter,
you ignore it?
Peter, answer the question. Is the horizontal longer than that shortest distance between A and B?
It's a nonsensical question. I cannot answer it.
Yeah. Obviously, you don't understand the shortest.
And
distance
will you
between
look?
2 points,
Will you
do you?
look? Yes. Will
Is
you
the
look on my screen?
Is the problem that it's horizontal, and you can't
you
think
please?
of another name for that word?
Would you
for
do
that
me a
straight
favor
line
and look?
between those
Would you
2
look?
points at an equal elevation?
Would you look at the screen right now?
In reality, Peter, right? I am. These your screens there. People can see it. Everyone can see your screen.
Are you looking
They're
at it?
there. You're just waving a circle around, Peter. Everyone can see it. Carry on.
It's not a circle. It's a sphere.
Oh dear.
Okay, right now you've got 2 points. We've established a water level. 2 points at an equal elevation. There is a straight line going between those 2 points. What do you call that distance?
It's a chord line. It's a straight line.
A horizontal line?
No, absolutely not.
So is the horizontal line between those 2 points longer?
There isn't. There is no
shortest
horizontal line. There is no horizontal line between the 2 points.
But there is, in reality.
I shall demonstrate.
Peter.
I shall demonstrate.
Peter, there is a horizontal distance between 2 points in reality, isn't there?
No,
Peter?
Unfortunately, there isn't. That's the whole
so
point.
you've
There is
not
not.
got a
You did it out
horizontal
earlier,
distance now.
Peter. Come on, Peter. Stop being dishonest about that. You said earlier that the
Unfortunately,
water
not.
level
Model
is a
affliction.
horizontal.
Have you ever heard of the horizontal paradox, Peter?
No, you keep repeating it. No, I haven't.
That's because you can't actually have a horizontal, can you? You can't have a horizontal distance from A to B. It's not possible, is it, Peter? Tell everyone.
1 second, please.
Tell everybody. On my globe model, the dictated model to me, the dogmatic model, I'm not able to have a horizontal between A and B.
That is correct.
Can you say it for yourself?
In reality, there is no horizontal line connecting points A and B if these points are of the same elevation.
This globe.
This is what we're showing here.
Has to be. Just has to be.
Has to
be. Here's what we're showing.
You know what the problem is here, Peter?
Can I respond to the
People know
previous
that
question?
there are horizontal distances.
Yeah, you got a problem there, Peter.
Yeah. Big problem, mate.
These are 2 points of the same elevation.
A circle and some lines on it, and you're trying to convince people with this picture that they know. They already know the level's horizontal.
I'm not
yeah, you are. Of course you are.
No.
Of course you are. What are you showing it for then?
I'm teaching. I'm not convinced.
Yeah, convinced. Yeah, you are. You're trying to gaslight people into thinking that level's not
Oh,
horizontal. That's what you're
gaslight
trying to do.
people. I'm being gaslighted. I'm a grown-up man, and I'm being gaslighted on the internet.
No,
Oh
not
my
me.
goodness.
You're not trying to give
Yes,
it.
you're
I don't
gaslighting.
fall for your absolute horse shit that you're trying to show.
I'm
Right?
showing
I
you
know
basic
level's
geometry.
horizontal. Level is horizontal. It's a straight
Level
line,
is horizontal. I agree with you.
but not in
Remember
reality.
earlier,
Is that what you're
Peter.
saying?
No, in reality, level is horizontal. Yes, you're right.
Right. So what are you saying? It's not now.
No,
Contradicting
it's
himself
horizontal is
again,
level.
just for fun.
Yeah. Well, I'm not talking to this guy anymore. Sorry, I'm out of this. He's too far
Bye-bye.
gone for me.
This is a globe proof, isn't it? Dogmatic globe proof. Carry on, Peter. This is good. It's a dogmatic globe proof that you can't have a horizontal between point A and point B.
Absolutely, of same elevation. If they had different elevation, you could connect them with a line. Yes.
But you do realise that geometrically, that's horizontal, right, Peter? Do you want me to take you through it?
Geometrically, that's horizontal. What does that mean?
Okay, you've got a point A and a point B. Then in the centre of that, yeah, you're going to have a perpendicular. Yeah?
No, that's nonsense. No, I'm looking at 2 points, D and
You
F.
can't have a perpendicular at the centre of that line, can you not?
At the center of what line? This line connecting them, the chord line?
Yeah. Can you have a perpendicular there?
Absolutely, yes.
And would that be horizontal?
No.
Why not?
To what? What?
A vertical.
Spot on. You're going to have to take all that building down your
Vertical
building.
or
Where's
vertical?
the vertical,
What are you
Peter?
saying?
Where's your
For
vertical?
who? For who?
What?
A vertical for who?
What do you mean, for who?
All of us.
Vertical is relative to every point. It's obvious, right?
Right, okay, relative to that ball then.
Here is one vertical,
Okay,
and here is another vertical.
okay. So,
Perpendicular. What's confusing?
Perpendicular to the centre.
Perpendicular to the center.
Of that
How
line.
can you have a perpendicular
line.
to a center?
Of that line.
This red line?
You've just made 2 points there, Peter. Haven't you?
Yes.
A
yes.
and B.
D and F.
Right, that one of them's not even on the surface. What are you doing? You're just drawing lines anywhere.
Both of them are on the surface.
Peter, what are you doing?
They are on the surface. D and F are on the surface.
Right. Now, in the middle of that line.
The chord line.
Let's put another vertical.
Okay, why?
Let's just do it.
Why not?
For a laugh.
Okay, I'll try and do it. Okay,
right,
give me a second. Give me a second.
Mm-hmm.
Don't talk too much because then I get distracted.
He's going to break the software now.
No, I'm learning the software, so I'm still not proficient with it.
You're a computer expert.
How long?
Yes, I am.
How long you been drawing lines on these circles?
On balls.
A week.
Okay. Okay. Well, we might be able to do a bit of geometry here, Peter.
Well, yeah. Let's do that.
Okay.
Just give me 1 second. There's a way to
you
slice
can do this
a line
with a
in half.
circle, right? You can do it with a circle.
How would you like me to do it?
Do you want to do it as
you
a
may
circle?
You may be more proficient at it than I am. So how do you suggest? Okay, let's do it. Tell me how.
Circle. Draw a circle.
Where?
Anywhere.
Okay.
Do you know how to draw a circle?
Yeah.
He hasn't got a compass.
Yeah, you still drawing, are you?
He's getting a new page.
Yeah, I am.
Oh, go on. There. Come on.
No wonder it took how many
It's
weeks?
geometry, but I'm not.
Yeah.
Sorry, Elder. What did you say?
It's all right. So no wonder it took how many weeks to do this? If you can't draw a circle quickly.
Letting me.
Wow, come on, Peter. Start a new page.
Oh,
or
this is
something.
weird.
Did you get a master's, Peter, in your computer stuff?
I did?
Just a circle, Peter.
Wow.
Come on.
Wow.
1 second, 1 second. There you go. That's a circle.
Yeah, like just put it on the vertical so we can all see it as a circle, right?
Okay, what do you mean on the vertical?
It looks like it's on an inclined plane.
You
It's like
didn't
an egg.
specify where you wanted the circle. You just wanted a circle, so here you go. I'm just rolling with your nonsense. So you tell me where to take this.
Just
Let's
get
go.
a thing, get a blank page and put a circle on it.
Blank page with a circle on it.
Yeah.
Okay.
And not like an ellipse or anything like that. Just
Get
an
one of your
actual
templates. It's probably
circle.
got a circle template.
Yes,
I got you, buddy.
Orthographic view, yeah.
Here you go. What's
Right,
next?
just draw a circle.
Okay.
This is how you answered your professors when you were training.
Yes.
Really?
Here you go.
Okay, now we're going to put 2 points anywhere on the outside, right?
On the circle,
on
you
the
mean?
circumference, yeah. Put 2 points on
Okay.
the circumference.
Gotcha.
Okay. Draw a straight line between the two of them.
Okay.
This is like if you imagine the concept of a water level with 2 points, and you're going to make a straight line, shortest distance between the two of them. Peter's showing us just because he wants to do it on a circle, but this is the geometric concepts. Right now, in the center of that line, do a perpendicular to it.
Okay.
Right now,
It's
where
better
that
when
touches,
you tell him what to do, isn't he?
where that touches the circumference, put a tangent.
Yes.
Tangent, please.
Okay. Okay.
See what I mean? I think he's happier when he's doing what he's told.
This is just pure geometry, right?
Hmm.
Tangent line. Can you get it?
What? Yeah.
Put a
One
tangent
second.
line on it. You just put a tangent point. Can you make it a line?
Yeah, I will. Just let me find it
You
because
find the
I'm
button.
always
Yeah. Line tool, I think
Yeah.
it says.
It's a tangent, isn't it?
There you go.
Right now, that and the chord that you initially did. Yeah?
Yes.
Parallel, right?
Absolutely.
Okay. So if you put one of them horizontal, the other one will be horizontal, right?
If you put one of them horizontal, the other one will be horizontal.
Yeah.
It will be parallel to the horizontal, yes.
So it'll be horizontal.
At point D, yes.
Okay. So what we could say is that if that was a water level and each point was causing that straight line, the initial straight line, then the midpoint perpendicular to it and everywhere along that perpendicular, it will always be horizontal. So that line, it's horizontal, isn't it?
I'm not sure I understood. Let me make sure I understood, okay? What I'm showing here is 3 blue lines, right? And these blue lines are horizontal lines for points B. Wait. All 3 lines currently shown on the screen that are blue.
Triangle. We've already done it, Peter.
Please let me finish. Please let me finish. Let me finish.
Yeah.
Let me finish. Don't be with me.
I'm
Just shut
helping you
up.
with the rhetoric.
Shut up.
Don't tell the
The
person
3
who's going
blue
to tell
lines.
you the rhetoric for the
the
thing that
3
you're trying
blue
to
lines.
explain that you can't.
You don't say that to the guy teaching you normally.
The 3 blue lines
Mm-hmm.
that I am showing are horizontal lines for points B, D, and C respectively.
You've got a triangle made up of horizontals there, though, right?
Are there any questions?
Can you see that? If they're the rules that you're playing by, you have a triangle made up
Absolutely.
of horizontal lines.
Absolutely.
Yeah, that's ridiculous.
No, it is not.
Of course it is. We call it an equipotential
Why
triangle.
is that
Peter.
ridiculous? You can call it whatever you want. Why is this ridiculous?
Because horizontal lines don't intersect. Do
In reality, they do.
Well,
I just showed you. In reality, they do.
No, you showed on
What,
the
on
picture.
the
This is not reality.
On the picture.
This is a model of the reality that you're in
that's the
denial of.
problem, because you
Model.
assume that tangents are horizontals, but they're not.
Well, this is the difference between you and I. Exactly. I'm showing you my view of reality, and you explain to me yours, and now we've pinpointed the difference. Very well done. Well done. I couldn't have done it better.
You remember earlier, Peter, when I said, "Don't paint a picture. Don't paint a picture. Don't paint a picture."
I'm sorry.
That's what's going on. That's what's going on now.
What do you mean?
I want to thank you, Peter, because it's been a
You're
long
welcome.
time before anybody's actually pointed
Yes.
this out to everyone, right? This
Okay,
is a
so for the-
necessity of the globe model, and you're brave, Peter, brave.
It's not a necessity. It's an obvious thing that I'm saying.
Has to be.
So
yeah,
I will
know.
explain it. I will explain it for the audience that's watching. If this is recorded, that's great. I will. Hey, I'm speaking to the audience right now.
Yeah,
Right?
they're looking at it. They're looking at it.
Disregard the.
Can you
the maniac?
label the
Okay.
blue lines horizontal for everybody so that they're sure?
Yes, exactly. So we're going to say.
Maybe you could put water level device.
No, it doesn't need that. Just it's a what we call it is an equipotential triangle, Peter.
You can call it whatever you want, buddy.
I think Betty would imagine it's on a like on a horizontal plane, drawing a triangle on a horizontal plane.
Can't you write the horizontal on the actual line itself?
No, because I couldn't be bothered to try and get it straight. I want this to look very personal. You know, I'm going for the personal touch. So it's my handwriting. It looks like second grader. That's me. And you're welcome.
Somebody else is
absolutely welcome.
for you. Tassie Tiger in the chat there. Horizontal is perpendicular to vertical. So, yep, tangents are horizontal. Well done, Peter. You're going to have a good fan club here. Anyone else? Any more?
I'm king of the...
Any more for any more?
I'm the king of the fan club, though.
What about you? Do you think tangents are
Where
horizontal?
have you been, Yui, all this time?
Yui, do you think
where have
tangents
you
are
been?
horizontals?
Yes.
Are all tangents horizontals?
Yui, I hate you.
That's well, I don't know. Yeah, sure, why not?
Yeah.
Yui, I hate you.
Wait, is that
I don't know where you've been all this time. You left me here with these people.
Let's not spew hatred to Yui now. Come on now.
Leave Yui.
Yui, where were you?
Are all radiuses vertical?
But that's a
Yes,
nonsense question.
yes, they are.
Wow,
Are they?
that's fantastic.
Yeah, every radius is vertical to the point.
Are they?
Like when you get like
Oh,
a
I think
football. Like is it all of the radiuses of a football? Are they vertical?
I understand.
All of them?
I understand, yeah. Because they're... Yeah, no, I understand. Because they're vertical to the reference point, which will be the center.
Yes,
Is that
yes,
correct?
yes.
Yeah, okay. Sorry, I'm new
Has
to
to be.
geometry, guys. I'm new.
I'll show you. I'll show you.
Yeah, geometry's measuring the Earth measurement, whereas what Peter's doing here is just some sort of.
But the joke is on you
Not
because Earth measures exactly as shown.
You don't make.
I've been in
horizontal
construction
triangles.
You
for
see,
30
Yui.
years. Yeah.
See
Hey,
this
I've been in
radius
construction
A?
for 30 years, and if there's no horizontal that
Because
is
you're dealing with
intersecting with
very
another,
short
they're
distances. That's why
all
you're
horizontals
dealing.
are parallel
Yeah.
to each
Yeah.
other.
Because
Yeah.
you're
Every
dealing with
horizontal
very
I've ever
short
created
distances.
was
Yeah.
horizontal
Exactly.
to the
Because
other
you're
one that I
dealing.
created.
Because you're dealing with extremely short distances, and your tolerance for precision is low compared to something like LIGO, for example. So your distances are short,
Yeah.
and
What
your
sort of
tolerance
distances would you have to
for
deal with,
level is
Peter?
very big. You have a big tolerance for
Peter?
deviation from
Peter,
level.
have you ever dealt with any of the short numbers?
Absolutely.
Okay. Do you have any idea of what sort of a deviance, an elevation change of a horizontal over,
Absolutely.
say, 400
Absolutely.
meters?
Absolutely.
What's the elevation change of a horizontal over 400 meters? Do you know?
Very tiny, very small.
What is it?
Here, I'll tell you this. My house
I'll
is
tell you that you don't know,
Wait,
and I'll tell you that I
wait,
do.
wait. My house is relatively level, and the walls are vertical and perpendicular to the floor.
Mhm.
But if this level of precision was implemented at LIGO, you could take LIGO and throw it into a trash bin. Because my house is crooked, actually, if we look at it at the level of precision required for LIGO. Do you understand the difference? Scale is
I
everything.
know that you know
You can
nothing
build your
about
house
building, Peter.
with your perfect level. You can make it all nice and vertical, perpendicular, but it's going to be off by some amount. And you tolerate that amount in construction because it doesn't matter really. When you're building LIGO, the internal mechanism of LIGO, you could absolutely not tolerate that level of precision.
There
So
you go,
you, my
Peter.
friend, you've been working in construction
Look,
for
I'm
many
telling
years,
you here,
which I
look,
respect.
Peter.
But you don't have any idea
Peter,
about the curvature of the
Peter.
Earth because you never had to worry about it at that
Peter,
scale.
Peter, we've been there. We've already been there. We've got
Yes, I'm
we've
summarizing
got
for
some
the
of the
audience.
best globe mathematicians, geometers there are around. Have you ever heard of Starkodder?
No,
Right. Have you ever heard of Ruhif?
no.
Right. A few years ago, we went over the short numbers because there was a guy called Sly Sparkane. Ever heard of him?
No.
Okay. Yeah, you have. Sly Sparkane's been on with Red's Rhetoric on the Twitters.
Okay, I never talked to him.
Ah, right. Well, in fact, he had a water level test. He called it a bending water level experiment, I do believe.
Awesome.
Right? Now, he had 1,600 meters. 1,600. He did a GoFundMe, got it all paid for, got a P1000, got all of the equipment in his shed, I think. And he put the tubes together. Right? And he had 16 risers. So there's 100 meters, another 100 meters. So at each 100 meters of this water level, there was a riser. Okay?
Amazing.
Right? So the start, where the water level started, we got the guys to come up with the numbers, the short numbers, using the, obviously, quadratic equation, right? So over the first 100 meters, Starkodder says, 0.78480 millimeters drop, right? From the horizontal, obviously. Second
Amazing.
100 meters, it goes to 3.13922 millimeters. Do you reckon you could measure 3.2 millimeters?
If I could measure, probably not. I'm not that good.
You
I'm
couldn't
not that
measure
precise.
3.2 millimeters. Okay, over 300 meters.
Oh yeah, that's easy.
7.06325 millimeters. Could you measure that?
Probably.
Okay. 400 meters, 12.55689 millimeters.
Yep.
Okay, you could measure that. And then it goes up every 100 meters. Obviously, because it's a quadratic function, that keeps increasing until at the end of the 1,600 meters, which is around about a mile. Therefore, it's about 8 inches or something like that, but in millimeter form, right?
Sure.
Round about 200 millimeters or something like that, yeah? So they're the,
Yeah.
we call those the short numbers.
Okay.
Okay. So that would you say that those are the elevation changes of a horizontal over that distance from the start point?
No.
What are they then? What are those numbers?
Well, I'm not sure I was following because you speak like a special language that I never heard before, so I have to kind of translate it on the fly. But I think what you were describing was the drop from horizontal from a certain point.
Yeah,
so
would you not call that the elevation change of the horizontal?
No, because I assume you were measuring a drop from horizontal to the point of equal elevation, I think is what you were trying
That
to
would
say,
be an
right?
elevation change, yeah?
No, absolutely not.
Well, that's how, when we get a tool called a level, we measure the elevation change on the vertical, like that, with those numbers. That's what we measure.
No, that's not what we do. In the absurd Bev world, yes,
Well,
but
those
not in
numbers
reality.
there, where those measurements are they not on the vertical?
No, as far as I could follow, no.
Are they on the horizontal then?
No.
So what would you be measuring?
The difference in
the drop from the horizontal.
the
Just
drop
like we do,
from the horizontal, yes, yes.
like-
So let
like
me
we
show
do
you on
when
this
we're
picture.
measuring elevation changes in differential leveling.
Would you like me to
Peter,
explain?
I know
Or
you
are
don't
you-
know how to do any of this, but what we do when we go out and do actual changes of elevation checks, we measure them on the vertical datum.
On the vertical
Yeah,
datum,
we
don't we?
measure the elevation change
I'll show you what I
from
think you were saying. Would
the
you like me to?
horizontal. But you seem to be
Okay.
saying that the elevation change has
Mm-hmm.
a distance away from the horizontal.
Yeah. Would you like me to
Very
tell you what I
confusing,
think
isn't
you're
it, Peter?
measuring? It is very
Nobody's
confusing the way you
measuring it,
talk
Peter.
about it.
No, Peter, nobody's measuring that.
I think you're
They're the
intentionally
numbers.
confusing
They're the
when
numbers.
you talk about these
They're the
things.
numbers that Sly Sparkane will be measuring when he eventually gets round to do his bending water level test.
Just for the audience,
So
I
next time
suspect that
time you
Bev,
see Sly Sparkane on Twitter, just remind him of that, because he seems to have forgotten.
I have a question. Actually, a statement I'd
I
like to
think
make for
they
the
do
audience.
call that fraud, you know, when people do GoFundMes and then don't actually do the thing that they said that they were going to do.
My dear audience, I suspect that Bev talks about these things in a very confusing way on purpose to bamboozle you all.
No, they know what we're talking about. Don't worry.
Nobody in the real world talks about these simple things using the language that he uses. He does this to obfuscate his ignorance and lack of knowledge of basic geometry, to make you think that he knows something you don't know. But in fact, it is quite likely that you know way more about basic geometry than Bev. He's just using this sophistry
sure
and
people
this
are gonna
rhetoric to
believe
confuse
this,
you.
yes.
I believe, Bev, this whole rant you went on about all these drop measurements, I believe what they were trying to show was that when you have a horizontal from B, like the red line, and you have a point D on the same elevation, both B and D are same elevation of 0 of the surface of the circle, then the drop will be the distance between the horizontal line and the intersection of...
That's the hump, though, isn't it?
Of the...
You get the hump, don't you?
Hold on, hold on. I'm trying to think.
Are you
Give me a
doing the
second.
drop from the center point?
No.
Yeah, the
What
water level
fucking?
makes it
I'm sorry.
difficult, doesn't it? You're
What?
used to being on a mountain in the middle, but with the water level, you can't be.
Center point of what?
The water level.
You're. Oh my god. There's
Yes.
so much to handle,
It's what-
Beth.
I know,
I
it's one
like
of
you
the
for this.
problems, isn't
You're an
it?
awesome
Sly
challenge.
Sparkane made the point right that he was looking for the drop. I think he fooled Rumpus into believing that Rumpus could see the drop as well. But you've got a hump in the middle. You keep forgetting about it.
Oh, I've got a hump. I've got a hump.
Yeah, you have.
Anyways, I think that's the drop, as far as I can
Is
make
the
it out
hump
with
the
you
drop?
yakking into my ear in the background. I think that's the drop, geometrically speaking, because I have a horizontal here, and then I drop a bomb onto D. Ka-ching! If I were flying an airplane in a straight line horizontally from B to like in a straight line, not level, changing elevation, but go in the geometrically straight line from B, the tangent line, I would be dropping a bomb right around here at F. Boom.
Go on, draw
Or
a,
would I?
draw
Would
a
I?
little man with the bomb thing.
Nah.
Come on.
No,
Do
that's
a
wrong,
little
because
guy
then the
with
bomb
the
would. No, that's wrong. That's wrong. Okay, that's wrong. I'd be dropping a bomb here. Yeah. Yeah, that's true.
Are you all right, Peter? You think you're going to be okay?
I think I'm all right.
Yeah.
I'd be dropping the bomb at E. That's right.
Yeah.
Yeah.
You're
Change.
confusing
So that should be the drop.
tangents with horizontals, aren't you? Because the problem is that a horizontal is a reality term, Peter.
Yes.
That
So is
those
a
of us in
tangent.
reality use.
Yeah, you never see the tangent because you operate at such small scales that it's irrelevant if it's a tangent or not. You never need to think about this because you never build things that are humongous.
Safe word.
What?
Is a tangent a safe word?
No, a tangent is a concept on geometry that I am displaying right now.
Let's say in reality,
Yeah.
right, we've just got a water level with point A and point B.
That's beautiful. I'm happy for you.
There's no tangent, is there?
No, that's a chord line.
No, it's just a water level, Peter.
Yeah, the chord line between B and C.
No, there's no circle, Peter. It's just
I don't know.
water level.
I don't know.
Hello, Peter.
Okay.
It's just a water level.
Yeah, you can go back even further in human development. You could just say, I mean, people didn't even know what water level was at one point. They still lived. So you choose to reduce your knowledge about reality to just saying, there's just a level. Okay, why don't you go a step before humans could even speak? You could just say, or eat, fire, baby. Right? You could just reduce yourself to a human being that says 3 words: eat, fire, baby, woman.
Don't project.
Okay?
Don't project. You
would live
You are
successfully,
reducing
probably a happy
yourself
life.
to that level.
No, you are.
Yeah.
You're just saying,
No,
all we know is that there is level.
No, we're
Okay,
just
good
pointing
for
out
you.
that a water level just goes from A to B, right? There's no circles involved.
Okay.
Peter.
And if you want to end your inquiry about reality at that point, if you just want to say, me have water level, me 2 points, line between 2 points, level,
Horizontal,
me happy,
yes.
then just
Peter,
say that
we have a
and
water
be
level
happy. Have
that
your little
produces
cult,
a horizontal.
have your little group
Peter.
of followers
That's
that
enough,
keep
Peter.
saying water level, horizontal,
Yes.
perpendicular, and okay, live a happy life. I won't deny you that, right? But when you want to engage in a conversation about reality that goes a little bit further than just saying me water level 2 points line, then you're going to encounter some resistance from people who know a little bit more about reality than you choose to know. You choose to limit your knowledge of reality to these absurdities that you spew all day long. Well, it's your right as a grown man.
But your
Right?
reality is only picture.
No, my
It's only
reality
picture.
is reality. This is measured
It's
in
got a
reality.
triangle made up of horizontals.
This is measured in reality every
How?
day by many
How
people.
measured?
Very simply.
Show measurements, please.
Well, that's what my proof, my ultimate proof 2.0, that's what it shows. Would you like to go over there? Now would be a good time.
More lines on
your
circle.
proof?
Absolutely. I'm ready to deliver ultimate proof 2.0.
Here we go. Ultimate proof. Globe.
Okay.
The ultimate globe proof by Peter.
He's all warmed up now. He's all warmed up.
Here we go. This is
Okay,
it.
how about we go to a commercial break? I'm going to go get
You
some
want to go to
tea,
the toilet? Do all that.
powder
Get
my
ready.
nose,
Everybody
and I'll be back.
refresh themselves, right? Let's get ready.
All the viewers,
Yui,
refresh.
Yui.
Close.
Yeah.
Come on, Peter.
Are you
Go
able
on,
to
get
pay
to the toilet.
attention?
Go on, get it done.
Am I able to what? Sorry.
Are you able to follow the ultimate proof 2.0?
I did miss a bit. I've caught up. I think I know what's going on.
No, I
starting
haven't
again.
started it
Yeah.
yet.
No,
I will
no.
be
Okay.
starting
Yeah, it's
it
not
from
started.
scratch.
We're having an
Oh right, so
intermission.
good. Then I don't need to worry then because I lied. I didn't follow at all.
Yeah. Well, he's
Yeah.
not even
There's a small
started it yet,
intermission.
Yui. Don't worry.
It's
like
always
you,
good when
Yui.
you got
I
someone
like
you can rely on in your camp, isn't it?
Yeah. The whole
Yui, I
whole
like
Trinity
you.
is here.
We could be good friends. Okay. Manu, are you able to follow? I mean, it's nothing special. You guys have seen it already, but just
This is
pretending
Peter's
that we're
team.
actually
He's
caring.
just gathering his team ready.
Okay, I'll be back in
Nothing
2
special.
minutes. Okay.
Peter, don't
No, he's
don't set the bar so low. You said
I'm
it's
just
nothing
going to go
special.
I mean,
in.
the
I'm going
bar
to get
is
ready
very
for
low.
this. Everybody get your popcorn and everything. I'm just going to nip to the toilet. I'll be back
Yeah,
in a
this is
second.
an
So
intermission.
keep it going. Do the intermission.
Guys, the bar is so low it couldn't be any lower.
Right. He wasn't recruiting his followers, he was following just people, everybody. All the audience, go get a coffee, bring it back, sit down, get a pen, learn.
Yep.
I don't know.
Get a pen.
Criticize, write
Get prepared. Like strap yourselves in because this is the ultimate globe proof. 2.0.
Ultimate's in the word.
But don't forget the globe's not got any proofs. Never forget that.
Oh,
Well,
yes,
this
it does. Now
new
it does.
generation, you know.
Yeah, new generation doesn't care about semantics. So we
Hurry
deliver
up and go
proof
test them.
until you cannot handle it anymore. We ram the proof down your throat.
Exactly.
We're
Well,
the
don't ram it
aggressive
down
Globers.
mine and anyone else is in it. What about ramming it down the people that say there is no proof?
Those are idiots. We dislike them. We have separated from the
Globers?
mainstream Globers,
Oh, I
and we
see.
have proof. We have proof.
We've evolved, yeah, that's not we, I'm just saying.
It's like a schism in the globe.
Sorry, did you
There's
call
a
me,
schism.
Peter? Oh, I just nodded off there.
I'm just running this from a pure geometric and logistics of like fucking verbum, words and what they mean.
I'm
Because
back.
that's
I'm
essentially
ready.
what we're talking about.
I need one more minute. I just want to say this is the penultimate proof because Yui and Manu will deliver the ultimate some other time.
Oh, right.
One of 3. Yeah.
Consider this just a
first
warm up.
chapter.
Okay. Well, that's good. It's okay. This is only the warm up to a flood. You're going to open the floodgates. Competition's going to be rife for the globe proof, right? I like the idea of you
flew
giving it
around.
the ultimate tag.
What are the other ones called then? Yui, what's your proof called? Have you got a better name than Ultimate?
He's got a modus Polens in honor of Bob.
Supreme. The Supreme Gold
No,
proof.
no, it's a modus
Globe proof.
Polens. He's named it a modus Polens in honor of Bob. Yui's.
Okay.
Are you
Some fucking Latin. What are you trying to summon?
My Latin is not the best, but ultimate is more than supreme, right?
What you can have, Peter, yours can be called a Globus Trollins.
I like it. But
Yeah,
ultimate
that's
means the final. There's nothing beyond the ultimate. Supreme just means better, right?
Is Dragon joining the Father, the Son, and the Holy Ghost? He seems to be on your team.
Well, for now, he could be an apostle.
I'm a third
Also-
party. Yeah, I'm a disciple.
Disciple,
write?
yes. Disciple is the right word.
Can you write? Just need to. If you got to write down the Apostle of Saint Dragon or something later, so we can read it.
Yeah. Might chisel it in the rock
They'll do
there.
that in about 70 years' time. That's what they generally do.
Yeah.
Well, it's like Van Gogh paintings. They didn't sell for a lot until after we were dead, so you might, in about 50, 60 years, mate.
Just leave a paper trail so we can actually trace you back to the beginning. Don't want to just send me a pin a couple hundred years later.
Yeah.
from nowhere.
Always leave a couple of balls in your shed.
Right? Yeah, just so we remember. We could
Just
put a
in-
time
Just
capsule.
in case people want to.
I was only trying to weigh the earth, that kind of thing.
Yeah, in a shed, that's it.
I put my sticks in the back room.
Yeah. Leave a couple of sticks in the corner somewhere.
Some spirit levels.
My photograph of the gravitational lens is on the top shelf in the back parlour.
Yeah, we need to put this in like on scrolls and then put it in time capsules and then send it to Mars, and then when we get to Mars, we can discover it and be like, oh, yeah, I
This
forgot
is
about
one
this.
of the first. This is historic, right? Because it's one of the first actual globe-proof things using, well, attempted to use logic, right, within it. I know he's trying to use the advanced simplicity, but it can be used, right, within the dogmatic model. There is a proof, right?
The triumvirate of, honestly, yeah, all right.
Whatever
Depends on
anybody
it. So
else
there's
says.
supreme.
Are you guys ready?
No, 2
Whatever
seconds. I've got
anybody
these
else
words.
says, those infrabarometer arms didn't get shorter.
Let's not even go there, LD Bear.
So we've got supreme,
it's just a note
pinnacle.
for the
Let's
future.
not talk about advanced physics, okay? Let's talk about geometry.
Let's talk about advanced words. Supreme, pinnacle, paramount, peak, optimum, utmost, zenith, quintessenal. Oh my god.
Oh, zenith. That'd
Zenith
be a
would
good
be
one. He'd
probably
love
the best
that.
one.
Yeah, the
Zenith.
Yeah.
The
There you go.
zenith globe proof. How about that?
Yeah, zenith's a good one.
Mm.
No, the flat earthers can use that in their edition.
Go straight over your head.
Can we? Do you want me to give you a few words of wisdom beforehand, right, Peter?
Yes, please.
Inspiration. Okay.
You don't
Here we go.
understand.
What's the definition of pseudoscience, Craig? Something that doesn't follow the scientific method. There's no proof in the scientific method. You do realize, Caleb, though, that there's no such thing as scientific proof, right? You good? I just wanted you to be aware that in science, there is no... The concept of... I don't believe in that. I care what you believe, but there is
You're
no
going
such
against
thing
your
as
globe
scientific...
leader.
There's no such thing as scientific proof, but carry on, Peter. The
Yes,
ultimate
we are-
globe proof
Yes.
by Peter.
No, it is genuine truth.
Absolutely.
With two O's. Truth.
Absolutely. So we, the Trinity, we are at war with normal globers. We have seceded from the Glober organization. It's a schism. We are on a crusade. So we only deliver proofs. That's what we do. We're in the business of delivering globe proofs and the business of booming, cousin. Okay? So we're only going to use advanced simplicity today. Advanced simplicity. Okay. Who is having a
It
maniacal
will be
episode?
retarded complexity, I think,
Yeah,
is the one you're looking for.
Yes.
But anyway, go on.
Who is having an episode?
Yeah,
right there in the background?
microphone discipline, please, guys.
Yeah,
Let's give Peter some respect for his Ultimate Globe Proof 2.0.
Okay, 2.0. This is the first version. I finished it last night. I'm sure there will be some edits here. I'll welcome your feedback.
Can I ask a question? If this is the first version, why is it not 1.0 instead of 2.0? 2.0 implies a second version.
No, this is a second. This is the first minor version for the major version.
Oh, okay, thank you very much. Thank you for clarifying that.
So we're going to do this in 3 steps. Step 1, we're going to discuss if we can determine the shape of the Earth using only angle and distance measurements that we can perform in nature, I should say, in reality for this audience. Okay. Without making any presuppositions regarding the shape of the Earth. It's very important. So we're going to discuss this first geometrically speaking. Then I'm going to show some measurements made in reality. And then we're going to compare those measurements against flat Earth and globe and see which of the two possibilities they match. Okay?
Okay, so
awesome.
Can
Let's
I
do it.
ask you, you've crossed out nature? Did you think it was spelled wrong?
No, because for your group, I should have used the word reality.
It's the same thing though, isn't it?
Yeah, it is.
So why did you need to cross out nature?
Rhetorical effect.
I will fix that. For rhetorical effect, yes. Reality and nature. Now I'm gonna fix it. Reality. Here we go. All right? All good? So far, so good.
It looks a bit messy. I think we could clean it
Yeah.
up next time. It's not needed.
That's my style. It's my style.
Was that advice from the Holy Ghost, that one?
Hey, LD Bear. How's it going? So, some warm-up questions to the audience, okay? There are 4 questions here. If we don't agree on those questions, then we're going to have to abort this beautiful presentation. Okay. Question 1. Are human beings at this stage of their civilizational development capable of, question number 1, measuring distances from point A to B over the surface of the Earth at distances up to 40 kilometers? Is it yes or no?
Well, I think the fact that 40 kilometers is a distance would say that it's definitely measurable, yes.
I have never seen a silly answer like this before to
that
this
they
question.
can measure distances longer than that.
Okay, but all I need is 40 kilometers today. So
Thumbs
does
up.
everybody in the room agree that human beings, professionals, not me,
Not
but
you,
professionals,
obviously not you.
yeah, professionals, could determine distances over surface of the Earth up to 40 kilometers? Is that a yes? Okay, I don't see any. I don't hear any.
Yeah, they measure them
opposition.
from a horizontal. Yeah.
I didn't ask
Horizontal
how.
distance, yeah.
I didn't ask how, so that's irrelevant. Okay, that's a yes. Awesome. Do we agree that humans are capable of measuring the elevation of objects, such as mountains or buildings, off mean sea level?
Well, you do it from another datum point.
I don't care how you do it.
Oh,
Are
yeah.
we?
Yes.
Do we agree that
Barometric
humans are
pressure.
capable?
Yes.
No,
Yes,
but more
barometric pressure.
precise. No, more precise than barometric pressure.
Yeah, I don't know who was that.
Yes.
Who was
Of a
answering
datum.
that?
Of a datum. I'm gonna write
Who was
a
answering?
datum. Datum.
Dragon.
Oh, right.
Yeah.
Okay.
Your
Cool.
cheerleader. No,
I'm
I
gonna
would say
yeah,
you could
yeah.
actually measure
Disciple.
them with a measurement tool, like an
Yes.
actual
Yes.
measurement.
Exactly. The actual measurement tool. Yes.
Yeah. But you don't necessarily mean sea level. You can measure a height of something with respect to another point.
Absolutely.
Anywhere.
Yes.
You don't need mean sea level. So.
Absolutely. Yes. Yes. I
Mean
agree.
of 2 points, mean of 3 points, mean of 4 points, different.
Yeah.
Being
I just
average.
need 2 points today. All right. Third one. Measuring zenith angles from point A to B. Like looking from point A to point B.
Zenith angle from A
Yes.
to B.
Yes.
Where is point A and where is point B? On the horizontal?
No, just
No, within line of sight,
no, the
obviously.
vertical.
Yeah,
Yeah, your zenith angle from the vertical.
Are these
Vertical down.
points A
Well, zenith
and B
is from the vertical,
on the
right?
distance that you've been talking
Explain.
about, or are they on the vertical that you've been talking
They
about?
are, well, if they were on a vertical, then their
Points.
zenith angle would be 0.
What do you mean? Why would
0
the angle
point.
be 0?
Each point.
If 2 points
Well,
lie
if
on the
A
same
is
vertical,
above you and B is below you, are you saying the angle would be 0?
the zenith from looking from A to B is 0, right? The angle.
Well,
if I am at A looking
was,
at B,
if A was above you on the vertical and B was below you on the vertical,
but I am
you're
not in the
assuming
middle.
that angle is
No,
0,
I am
are
not.
you?
I am not.
No. Okay. That's what I was
Okay,
pointing
thank you.
out there.
Is that a yes? Are humans capable of measuring zenith angles?
From
Yes,
A
yes,
to
yes.
B?
Yes.
Okay, yeah. So you can have
But-
A and B in different positions, yeah? And you
Yes.
measure the angle on the vertical plane.
I understand.
No.
No, he's saying the
Just for my
distance between
feedback
A
for
and B.
future use, could this question be any more direct
Yeah.
and clear than it
The
is right
from.
now as written?
It's the word from. The word from is the problem.
Okay, what should
There's
it
no
be?
problem.
No, because then you're asking for the distance between
But
the A and B. You have to.
a zenith angle is in the vertical plane, right?
Yes.
Yes. But you're measuring to the.
It is in a vertical plane where points A and B exist on the same vertical plane. Yes.
Okay, right. So that would mean if A and B were above you and below you, you can measure the angle in the vertical plane. But if A was in front of you and B was behind you, the vertical plane would still apply for the angle, right?
Of course, yes. I can create a vertical plane that will contain me, point A, and point B.
No,
yes?
not you.
Oh, I can have a vertical plane that contains 3 points.
Yes, but not you.
Any 3 points.
The point of angle measurement, right?
Yes,
the
but
angle gets
you-
measured.
You
and
introduced
you
a third point.
Yeah, you scribe the
I
angle
am
from
point
A to B in the vertical plane.
You're just being obtuse, aren't
No,
you?
I'm not. I'm just pointing out.
Yeah, you are, totally.
Just so everybody knows what measuring
Don't
a zenith
speak on my
angle
behalf.
is.
This is my presentation,
It's just
so
an
shut up.
angle. Or,
Yeah.
right, here we go,
Shut up.
Peter, or is the zenith angle from the zenith to the point?
This is, I'm going to give you your first strike. You get 3. I'm ending this presentation.
Okay,
Hey,
well, I'm
Peter.
just pointing out,
Hey, Peter.
This is your first strike for being
But
obtuse.
I am pointing out, Peter.
I don't have time
that
for this
if
shit
you
today.
have
Hey,
point
Peter.
A
I
in
don't.
front of you and point B behind you, then there is 2 separate zenith
I'm going to give you
angles.
30
One
seconds to calm down.
from the zenith
and I'm
to
done.
A, and the other one from the zenith to B. Are you aware of that, Peter?
Is it 3 questions per panel member?
I don't think Peter knows what a zenith angle is.
Yes, if you are putting questions in your presentation, use words with meaning.
Because there's a difference between an elevation angle, a zenith angle, and an angle from A to B in the vertical plane. They're all different.
6, 5, 4.
It was that word from that threw everything.
Peter, are you okay with a little criticism, a little constructive criticism? In all seriousness.
Hey,
Yes, I am, but I need to ask a question to Bev first. Bev, are you done?
Can you put these restrictions right at the beginning? So
Bev, are you
instead
done?
of introducing them halfway
I
through.
will go to the next
there's
person
clock
until
and all that
Bev
stuff.
confirms that he is done with his commentary.
Yeah,
Are you done, Bev?
one more point.
Okay, thanks.
Is
one more point.
A the point of zenith in your angle that you're measuring from A to B?
No, it is not.
Okay, well, I don't agree with it then, because it's very unclear what measuring a zenith angle is to you. You don't seem to know, Peter.
I'll explain.
Is this yours or is this the combination of
I
the
think you
3
should
of
get
you?
Blue Marble Science in. I know you've got a breakaway group, but
This
I
angle
bet
here.
Blue Marble's shouting at you
Bev,
right now.
Bev, I'm addressing you now, Bev. I'm responding to your question. Here's point A. Here's point B. From point A, we measure this angle from vertical to the line of sight to a certain point B. Does that help?
Okay, so you are at the point of the angle.
That's what I was saying when you were talking over me. I kept saying I am point A, and you kept giving your example with me, point
I'm
A,
not
point
used
B.
to putting people.
You're
as
done now.
points.
You're finished, right? You're finished. So does that answer your question? Zenith angle from point A to point B, line of sight. Okay, Kevin, you had a question.
No, I had a constructive criticism, if you don't
Go
mind.
ahead. Go ahead, please.
In the future, I mean, I do have some experience in training and giving presentations myself. In the future, I would suggest that I think what you're looking for is just an assumption or a capitulation from people. So if you don't want the back and forth because you get frustrated, clearly, and I can understand that being a giving presentations myself, you may just want to make a set of assumptions and say these are the assumptions that I'm using. If you disagree with these, then you may not get what I'd like you to get out of this presentation.
Thank you,
Sure, you're welcome.
Yes, thank you. I am doing this on purpose, exactly the way I'm doing for a lot of reasons.
You're getting frustrated on purpose, then?
Yes.
That's kind of strange, but okay.
Frustration. I know. I can talk to you offline about why I do this way. I would never do it this way in the real world, but this is not the real world.
Well, I can tell you're getting frustrated. I'm just trying to help with your frustration.
Of course.
This is the real world.
Can I please address Kevin? Because so Kevin, we can talk later. I do this for a reason. That's all I'm saying. Okay, I can explain this to you later.
That'll be great.
Kevin, he's basically doing this in sandbox mode until this development presentation.
No, Not really, no.
No, you asked about the question.
Yes.
Carry on.
That's
Carry
not
on.
what I'm doing. Okay. Was there anybody else who had a question? So we had 3 yeses, okay?
Are there any more restrictions as we
Yes.
go along further?
Now
The
here
time,
comes, yeah,
or to the amount of
there will
questions?
be.
Is there a clock that's going to be ticking
Yes.
away?
Yes, there will be.
Can you make that clear, please?
Yes, the rules are this. You get, if I count 3 strikes, I'm terminating the presentation. We're at strike 1 from Bev. Okay? For
So
being
it's
obtuse.
one strike,
All right, so we
3
got 2
strikes
left.
for
Yes,
for
and it's game
everybody?
over. It depends on how pissed off I will be. I'm gonna give you all like a separate counter, or I'm gonna just do a common one. Okay, here comes. Thank you for your question, LD Bear. Here comes the 4th most difficult question of all. Okay. For the purpose of this presentation, we're going to define flat Earth in the following way. It is an Earth, or a reality, as someone's going to say, because you said it yesterday, so I'm preempting you saying that. Flat Earth is a reality where 2 points of the same elevation are always located on the same horizontal plane. Now, we cannot move on from this slide unless I get 4 yeses from you guys. It just doesn't make sense. It's not that I'm angry or anything. It's just a presentation. No, don't talk yet.
Are we agreeing
Don't-
that that's your assumption?
Presentation. So
Don't
go
speak yes.
with presentation. Don't
speak
ask
yes.
questions
Don't
in
speak yes.
presentations. In
Please do not
presentation, you
speak.
are not asking questions.
This is
You
an
are
interactive
presenting-
lecture.
You are present. Yes, lecture. You are presenting your point of view. Don't ask questions to the audience. And
This is not a
rely your
presentation.
no, this is just blackmail.
This is not a
You are
presentation.
blackmailing audience. Yes.
No. This is the assumption, right? He's asking us, are we okay with him making this assumption for his globe proof?
About the flat Earth.
It is implicit in presentation. So why asking questions?
To front load any misunderstandings. That's why.
It's like British Parliament. It's either ayes or noes. What are we having?
We're front loading all disagreements before the evidence is presented. That's why.
I'd say
if we do not
it
agree,
looks like you're setting up a false dichotomy, but I'd say, Peter, it's fine by me that you make an assumption about flat Earth like this. Yeah,
I'm not satisfied with that answer. No, I'm not happy with that answer. I will build on this, and I'm doing this because advancing further is going to be a waste of everybody's time unless we agree on these 4 points. We don't have to agree. If we disagree, then we simply don't advance. It's that simple.
We can agree that you've assumed that
I'm not done yet. I'm sorry.
This presentation,
no,
it says there, as it says.
Yeah.
You're dragging this out more than it's necessary.
Yes, and he's correct, and he should. Yes. You are blackmailing.
He's basically asking.
Yes, this is blackmail, typical blackmail.
Not blackmail.
You are dishonest. Yes.
No.
Yes.
No.
Would 90%
of
flat Earth... What Peter's asking, 1 second, Peter, is you're basically asking, would like 90% or the majority of flat earthers agree with this statement?
I don't care
about
90%.
That's not what I'm asking.
What he's saying is, he's saying if you go to a shop for a tool called a level that establishes equal elevations, right? Then he's saying you're a flat earther, I think, for the assumptions of this argument, right? But he's going to disprove it, so don't worry. There's no problem, right? You're not going to be a flat earther because Peter's going to disprove it. Right, Peter? That's what you're doing, setting up a false dichotomy. And for the purposes of this proof, right, you want us to assume that 2 points of an equal elevation lying on a horizontal plane is flat Earth, right? It's like a Houdini trick. I love it.
Okay, I don't agree, but
I don't agree it's flat Earth. No, but I mean, feel free to disprove flat Earth. Off you go.
This is your assumption in presentation. We don't need to agree with that. We will judge your presentation after, not now.
Is there a firing squad involved in this time countdown?
I say
I'm simply I'm
yes.
counting the
You're
time that
free
Bev
to
is
assume
wasting
this
for
in
you
your
guys.
argument. What everybody else say? Come on.
I'm going to add the
Very
time that
childish.
Bev is wasting. Are you done, Bev?
I was just trying to get everybody else G'd up for
Are
it.
you done?
It doesn't
Are you
seem
done?
like
Can
they're
I resume?
motivated, Peter.
Can I resume?
We are talking about your model, aren't we?
It's Peter's argument.
Let's resume. So, here's what I'm asking. That's why the answer that Bev gave is not good enough for me today. What I'm asking you all is this. Can anyone in this room, I don't want you to speak on behalf of other people. Can anyone in this room propose a flat earth idea, concept, whatever you want to call it, where this statement would not be true, where this statement would not be compatible with that vision that you may have of flat earth?
The Earth's not flat.
You showed that and agreed that.
Replace it with level Earth.
You showed that and agreed that on the previous globe model that you showed.
Level is not Earth.
Okay.
You showed a horizontal line that was at the same
I need you to
elevation.
answer my question.
Oh, this is
globe
your
model.
presentation. Are you going with your presentation or not?
It's not a presentation.
Yes, it is. You said it is presentation. So
Ultimate
now you
globe
are
prime.
lying.
Oh, look at it. Look at it.
Come on,
So
let's
now
see.
you
That's
are
a good
lying.
edit. Keep going. That's a good edit.
Not
That works.
a presentation.
Okay, so rhetorical questions. Okay.
This
Can
is
we-
a
can we
discussion
proceed?
of the ultimate proof of the
No,
globe.
this is presentation.
discussion,
Your
Gary.
point of view.
It is not a presentation.
We will discuss after. We will discuss your presentation.
Then you don't have to
after.
participate. You're welcome not to participate.
I am
Okay.
participating because
Is
I am
there
listening.
anyone in this room that would disagree with this statement?
So it's not a flat Earth now you're proposing.
Just where you
Whatever
live.
you want to call it, buddy.
Let him
Just
proceed.
live somewhere where 2 points of the same elevation are located on the same horizontal plane.
A level.
Is that what you're saying?
So we
Yes.
live where levels work and do the
Yeah.
job
Do you
that they're
agree? Do
designed
you
to do.
agree? I disagree with this statement. My question is, do you agree with
Do you
this
not
statement?
think levels work, Peter? But I mean,
Read
I
these
agree
words
that
on the
levels
screen.
do work, yes. Levels are tools for establishing a horizontal plane of reference.
Read these
Words
words
that are
on the
in
screen.
Where I live.
The
Tell
words in
me if you
conjunction-
agree with these words.
I live where levels work.
Those are not the words on the screen.
No. The two words in conjunction are horizontal plane. Now, horizontal plane means infinitely, right? Infinite horizontal plane.
Yes.
That's essentially what he's getting at.
A level is a tool for establishing a horizontal plane of reference.
No, but we're not using the.
Have you been in the back room in Dragon?
We are using horizontal plane. He's got it there.
Is this 4 in this?
Not level, just
Have you been
horizontal plane.
advised
Yeah, but a
or what?
level establishes 2 points
I'm going
of
through
an
semantics.
equal elevation. That's a water level.
Geometrically, a horizontal plane doesn't need the Earth's gravity involved or anything involved. It's just a
Nobody's mentioned it. We just said a
horizontal
water
plane.
level is a tool for establishing 2 points of equal elevation, and a level is a tool for establishing a horizontal plane of reference. Carry on.
Where I live. Who in this
A
room
level is
agrees
both a
with
tool
this
for
statement?
establishing a horizontal plane of reference and 2 points of equal elevation.
So you put
Or
flat Earth back again.
Yeah, he's sort of making a concession in wanting this to be flat Earth, but reality isn't flat, Peter. Don't know. Your model affliction is even worse. It's on overload.
So Spot On has a default position because he can actually establish a horizontal where 2 points are at the same elevation. So he's in a default position. He hasn't really got a choice. And anybody else who could do that also doesn't have a choice. There's no agreement. It's just the reality of that.
Can we continue now?
Yes, Peter, please.
I'm available. Okay. So, who in this room disagrees with this statement that we live? I'm not going to keep doing this all the time, as fun as it is, but like on an Earth, okay? Or 2 points of the same.
That statement, or it isn't that statement. Don't keep
Okay,
spinning
so
out. Just make a clear statement and stick to it.
okay, I disagree with this. I disagree with this statement. But I am here to prove to you that this statement is false. So, do you agree with this statement?
We can't
It doesn't matter. It doesn't matter. And you said that on the beginning of presentation that that would be without preassumptions.
Yes, there are no preassumptions.
Yeah, yes, it is for you, and it is completely useless for your presentation, because if you want to disprove that statement, just disprove that statement. Why asking us that if we agree or disagree? It doesn't matter.
You know why? Because the purpose of this whole thing is to make you realize that you're wrong. And if you at the end are going to use, I know what your ultimate defense is. You guys always use it. You say, I didn't agree with this in the first place.
Just do your presentation.
Yeah.
Can I
agree that this is flat Earth?
Could I break in, please?
Always.
Yeah, thank you. I appreciate that, but I do need to give Godzilla props because he sent a super chat in. $5 says, I can't believe it's Friday already and we still have people thinking they're on a globe. Thanks, Gords. Appreciate it. Carry on, Peter.
Okay. Does everybody agree that the only reasonable definition of flat Earth is an Earth where 2 points of the same elevation are always located on the same horizontal plane? If you disagree, then please describe a flat Earth where that condition is not held true.
What
The Earth's not flat, it's fictional, Peter.
I don't care what you call it. Just say, tell me of an Earth where that condition is not true. I can tell you of one. In fact, I'm going to prove to you that you live on one that's like that. But most of you disagree with that. So do you agree that the concept of flat Earth only makes sense with this condition standing?
I'm still going to go along with saying, Peter, that
okay,
I
think
know,
I'm going to take this because
know,
otherwise I'm going to
Peter,
get a stroke.
I know that a level is a tool for establishing an equal elevation,
Thank you, Bev.
horizontal plane with zero slope.
Thank you, Bev.
Right?
Thank you.
But I also know that the Earth's not flat. So you're leaving me in a bit of a problem here, because I can't agree to it being a flat Earth because I know it's not a flat Earth. But I know that 2 points of an equal elevation do lie on a horizontal plane also.
Awesome. Okay, you just
so
said
I'm
it.
stuck
That's
in a
what I needed.
contradiction there. So therefore,
I got you, buddy. You're
cannot
good.
agree.
You just said it.
Right
You just
now,
said it
if
accidentally.
I'm that one no, then that means this has to stop, right?
You just agreed accidentally. So I'm okay. I'm happy. Bev said this.
No, Bev said it's not a flat Earth, Peter.
Yeah.
You
Yeah.
could get rid of the
Ignoring,
flat Earth and Earth.
ignoring, yeah.
Lives.
So perceived reality.
Yes. That's good. Okay. We passed.
Not
We passed.
perceived,
It's all
actually
good.
known and proved.
It's all good.
Reality.
It's all good. We can move on.
You're like a big
That
kid,
was
Pete.
4.
We can move on.
Do I get 4 for my name? Like I'm worth
4
4,
yeses.
am I?
Yeah,
Look at that.
4
That was
yeses.
all it was.
Yeah.
Was
You
guys
count
are
as 4,
useless.
Bev.
You're not bothered. He
Yeah.
doesn't bother about you guys. at
Nobody
all.
else
Even
protested.
though I said like no, I can't go along
Silence
with
is
that.
consent.
He gives me 4 yeses.
Silence is consent. Are we good to proceed?
I would have we said proceed a while ago.
Yeah,
I don't
I
know
said,
why you
like,
sure.
oh,
Yeah, go ahead.
Yeah.
No, Bev is ranting. Until he's done ranting, we're not proceeding.
I said carry on. Yes, Peter. You want to consider
Okay.
that a rant?
It's all right,
You
the
done?
audience is watching.
The audience is watching.
Yeah.
Okay. Let's talk about some basic geometry. All right. Since on flat Earth, 2 points of equal elevation, such as A and B1, are always on the same horizontal plane, the geometrical relationship between 3 points A, B1, and C1 is as shown. Yes? B1, C1 is, let's say, a building of a known height, in this case, 3.
Vertical?
Vertical, yes. Point B is off the 0 level by elevation equals 1. So is point A. It's also elevated by 1. The distance on surface is d equals 20 in this case. And we establish a line of sight between point A and point C1. And we now measure the angle of the horizontal plane, alpha 1. This is clearly a right-angled triangle. And therefore, as we measure these values, in reality, the relationship between them must always be this. Is this at all controversial?
Looks like a geometric relationship of right-angled triangles to me.
Yes.
Silence is consent. Let's go. Move on.
Yeah, that
Okay,
definitely
let's-
applies to reality, doesn't it?
Yes,
The
but
relationship of
in
those
this sentence
triangles and
is
everything.
on flat Earth. It must. So on not existing thing,
Oh,
it has to
brackets
be
flat
true.
Earth.
Yeah.
Oh, right.
No. On the bottom. On
Oh, yeah,
FE.
flat Earth, 2 points. Yeah, on flat Earth. Why? Like, it does happen in reality, Peter. So, are you assuming, for this purposes, right, that only occurs
This is
on
just
flat Earth, or
sophistry.
can it happen in reality too?
We're gonna find out.
Let's say, Peter, just for an idea, right? There's somebody listening in, and they're a mathematician or whatever, and they go, "Oh, I remember that. That's the relationship of triangles, right?" That's actually what happens, like in what you're showing in this picture here, right? Now, are you going to disprove that?
No, disprove what?
That relationship.
I'm going to disprove a different relationship
than the one that you're showing.
The straw man. The straw man.
Yes, the key to understanding is going to be this.
You need to neutralize that statement at the bottom and just delete FE. It's just in reality.
No, he doesn't. What he needs
No,
to
no,
do
no.
is he needs to let
I'll
everybody
explain.
know that this is a property of triangles.
Yeah.
It is. I'm not going to disprove this property of triangles. This is one thing you can trust.
So what's the idea of you linking this property of triangles to flat Earth?
That is not what I'm doing.
It looks what
You've
it looks
polarized
like.
it. It's neutralized.
I
that
could
flat Earth
explain, but I'm going to wait until you're done explaining it on my behalf, and then I will explain it.
Is Dragon the adjudicator in this room?
Yeah, he looks like he's taking over here.
Yeah. What's all this?
You guys
got
let me know
agreement.
when you're ready
Sit
to
down.
resume, okay? I'm available anytime.
Well, it's just Peter's presentation.
Okay.
Don't need
So
anybody
this
else
relationship
impersonal.
of these points and lines and all of that are a relationship to triangles. And although you're trying to say flat Earth, Peter, I know you're putting a timer on. Put the picture back up. Then everyone can see the words that you're using. Like why you mentioned flat Earth 1, 2, 3 times. Anybody see any more? Are you trying to tie flat Earth to this property of triangles?
No.
No. But it is true that these values work within triangles, isn't it?
Some values do.
These values of measured distances and h and d, yeah? Height and distance.
Let me know when you're done so I
Rise
can
over
explain.
run. The arctan relationship, right? That's a property that's true within triangles, isn't it?
Yeah.
I'm talking to the mathematicians that are out there, right? So this property of triangles must be true in reality, and because it's provable within geometry. Why are you trying to link it to flat Earth, Peter?
I'm not.
It does
What's
look
the
like
limit
that
on
you
this
are,
clock?
Peter, though.
You are on the bottom.
So let the
of the screen.
adjudicator just neutralize it, man.
I
It
can
doesn't have to
explain.
involve flat Earth. Move on.
It has, you're misreading what I wrote there and you won't let me explain. So you decide how much more you want to cook in this.
Is there a limit on this clock? What's the limit?
No, this is just to show your audience how much time Bev is wasting by being obtuse.
Not wasting it. Is you asked questions.
And I told you I will explain, and you guys keep ranting, so I'm just waiting.
Much
You're not
ranting going
writing
on.
this.
Let me
Just
know
question.
when you want me to answer your question. Just say, Peter, please answer
Yes,
our
Peter,
question.
I'm sorry. Could you just give me the detention? I'll stay after school.
Bev had objections.
Let me know when
Simple.
you're ready to hear the answer.
You just present it without any questions, Peter. Just read it out.
No,
You
questions
obviously
are
don't
very
want any
important.
questions. And if there's any questions, well, we've done this for about 10 hours already.
You need
And
to
you've already
wait. You
tweeted
need to
this
let me respond.
presentation.
You need to let me respond. That's how it
No,
works.
I'm
You ask a
talking.
question, I respond.
You are you tweet this presentation for 10 hours to get to this point, and there's still questions.
Take it somewhere else. Take it to Blue Marble. Blue Marble Science.
Come on, Peter,
now there's more
answer us.
restrictions
Why are
than there
you
ever was.
trying to link
Okay.
that to flat Earth?
I am not.
You're not.
Yes. So the relationship in a right angle triangle that I'm showing here always exists. Right? It's not a specific feature of flat Earth. This relationship always exists.
So it happens in reality, right? Okay.
It happens in reality all
But
the
you
time.
want
Yes.
us to agree that it would also happen on a flat Earth?
No, because you have to read into what I'm saying here. The three numbers,
times then.
the three values that are shown
three
here are not just random numbers. They are the height of the building, which remains fixed during our measurement. Or in both cases, in any case, it's fixed,
Would
no
that
matter
be
what
measured?
shape the Earth is.
That would be actually measured.
The elevation is also fixed, no matter what Earth we
measured.
live on. The distance on
It's
surface
measured,
is what's...
Peter.
Yes. The distance on surface, it says measured here. If you bother to read, you would see that it says measured.
So if
Thank
you've
you for
got both
pointing
of
that
the
out.
distances, why do you need the angle?
The kicker here is the D, distance on surface. This will depend on the shape of the Earth. And then the triangle will change accordingly. No rules will be violated, just the value, the proportions between these values, angle measured, height measured, distance on surface measured, these proportions will change because the triangle will change. And now is the perfect time to advance to the next slide, which demonstrates exactly that. The only reason why I stage these slides is because the moment some people see the curve, they immediately freak out. So it's like a little foreplay. Before I show you the curve, I show you a simple triangle. So here are the two possibilities that we will be discussing today. The yellow triangle is the flat Earth. The red picture is globe Earth. Notice the difference.
You didn't say triangle.
Yes, because the red thing is not a triangle.
Why is
And I
that?
should have done this. I can do this in 5 seconds.
Why is that,
This
Peter?
would be a triangle. Because this is a triangle.
That's not a triangle. That's terrible. That it's blue. Look at it, wobbly line. That's not a triangle.
It's my bad. I'm missing one line.
Whoa, what's going on there?
I think we meant to see
We're
this.
going to fix that. We're going to fix that.
This is the workings. We're not meant to see this behind the scenes. So are you
We're
saying
going to do
that
an interactive
the
demo anyway.
difference between a triangle and it's a globe, right? The difference between the relationship that should happen geometrically and a globe is a difference in triangles? To one without that relationship of the H over D arctan.
Give me 1 second. I'm not good at multitasking.
Working on a computer.
Are you aware of the H equals? There's another one. Let me have a look. See if I can find it.
Okay, I'm ready to resume. Actually, give me 1 more second. Sorry.
Oh, we're going wild. You all right, Peter? I know doing this live on the
Yeah,
fly,
almost.
fixing
Almost.
the triangles.
How many hours does
Imagine
this
missing
take?
a
Gotta
line
know
on
your
the
audience.
triangle.
The lesson
We're not
here,
watching
kids,
it.
is
Don't
gotta
worry.
know
I've
your
moved it
audience.
away, so you're all right.
Okay. Okay, that's good.
Doesn't using the tan imply that you do actually already have the H and the D, or that you're trying to
Of
work
course,
out the
we
H
have.
and the D
No, we have.
with
I
the
mean,
angle?
it's written on the slide that we have them.
Right, so why do you need the angle then if you've already got both the H and the D?
Because that's a good question. Okay, let me go back.
The angles of no use at all, is it?
Yes, they are.
No, you need the distances.
We have the distances.
I know. That's the point. What's
It
the
says
use of
in the
having the
green.
angle? If you've already
To
got
see
the
if they match.
distances.
To see if they match. That's the whole point.
Mathematical.
The whole point is to determine if these three values match or don't. The whole point of this whole shtick is to say, did we measure angle A1? And therefore
Do you
it
not
equals
fear a
this.
stolen concept in
Or
here
did
somewhere,
we measure a
Peter?
different angle? And I will now explain what I mean by that. Since distance D is the same in both cases,
Oh,
and
wait,
the
can I come
height,
back to your slides now?
I am back to the slides,
Okay.
and the height is same in both cases.
Mm-hmm.
The only difference between the angles, the only way it can be explained, depending on which one we measure in reality, is because we either traveled a different distance away from the origin in a straight line, or we traveled in an arc. This is an arc.
Or, what about if you thought about this one? Or the angle measurement is useless over those distances.
In what sense?
Well, in the sense that you've already got the distances. I mean, if
you're saying don't measure
using
the
angle to check your distances, then
correct.
Oh, right. So you're using the angle measurement to check your distance measurements. I hope it's not the
Be
same
more
team
precise.
that's doing it.
No.
If you've got a team of angle measurers coming round to check the distance measurements,
You should
guys,
stop. Yeah,
then
you should stop.
There's going to be a problem, isn't there?
No. There's another possibility. Another possibility is that the distances are very well measured, checked over hundreds of years. Distances H and D are very well known, double checked, triple checked, 5 times checked. But our assumption about the shape of the surface that we traveled by 20 units is incorrect. This is what we're verifying.
I would say you're very, very close to a stolen concept here, Peter, and not aware.
What do you mean by that?
Have you ever heard of a self-refuting claim?
No, what do you mean by stolen concept?
It's called a self-refuting claim. Right,
okay.
So you're making a claim that these measured distances of a right angle triangle will have the proportion of what they have, right? As in, the hypotenuse can be known through the Pythagorean formula, right? Because you've already know two sides, you can use the Pythagorean theorem to work out the third side. Right?
That's not what the problem here is.
No, right? But that's okay. So you can set that triangle, and you know that to be true, without use of angles. But you are going to come along with an angle measuring device and measure the angle. Now, if the angle's different, is that hypotenuse going to change? Is that triangle that's formed by the known right angles going to change? Or
not at all.
Are you trying to say that it's a different triangle?
It's a different triangle, yes. You nailed it.
That's a stolen concept, mate.
What do you mean?
It's a stolen concept, as in you're using the laws of geometry and triangles and stuff like that to prove that that's not the case.
No.
Carry on.
Carry on with my presentation?
Mm-hmm.
Okay. I will show you this one thing that will help, okay? Give me 1 sec.
Everybody else
Once
with us?
we agree on this
We
one
okay?
point, everything's going to go very quick. I promise you all. The purpose of measuring this angle, it's really one angle, but I'm just showing two possibilities that it either comes out with one value or with the other. The purpose of doing this is to answer the following question. Are we in reality dealing with the yellow triangle, or are we dealing with the red triangle? I drew this red triangle for you.
Is that lower?
It is lower, and you're going to see that the length of it is shorter. You see? A equals 19.99. And the reason why that is that in this case, we traveled over a curve by distance of 20, because that's what we measured. We measured distance on the surface. If surface is a plane, a flat plane, then of course the distance is also the base of the triangle. That's the case in the yellow triangle. If, however, by some cosmic joke, the surface is curved, as the blue line suggests here, curvature, right? Everybody sees the curvature. Then we really traveled on an arc by distance of 20. And therefore the triangle that we formed has a different base dimension, 1999. And that's why we get a different angle. The law of triangles is not violated. We're just looking at a different triangle because we thought we were traveling in a straight line. Unfortunately, we were traveling in an arc. That's how we distinguish between these two cases. It's exactly because we know the value for H, we know the value for D, and we know the angle because we measure it in reality. We compare those three. If they add up like this, orange case, we know we're on a flat Earth. If they do not add up, nothing is broken with geometry. It's just that we know that the only way that we could have gotten from point A to B2 in such a way that it forms a triangle with C2 with the angle alpha 2 is by traveling over an arc. It's geometrically impossible for us to travel in any other way from A to B2 and form that triangle. It is geometrically impossible. Precisely because we know that we traveled by D equals 20 in this example. You can't establish this relationship A, B2, C2 in any other way by moving over this arc. Any other way, going in a slope, going in a zigzag, by distance of 20 would put this point B2 somewhere else. And we would have yet another triangle, a third triangle, and we would measure a different value for the angle. That's the whole point.
I like it, Peter. You can move a point measured in location by measuring an angle from somewhere else.
No, the point exists where it
like
exists. You don't change reality with your measurement. You change your understanding of reality due to the measurement.
Yeah, it's fantastic.
This is how we discover, this is how we
absolutely
learn
amazing.
about reality. We measure it and we think about it.
Mm-hmm.
We don't run away from our measurements and conclusions, waving our hands, flailing our arms, going horizontal and vertical. We measure we think about the geometry, we reach conclusions.
Perfect. Can I jump in now, just for half a second?
Absolutely.
Bev? So, Bev, you have done said measurements.
Straight line within
What's your
a
name
plane.
again? What's the other? Yeah, what's the other guy's name?
Peter.
Peter.
Peter the Globe.
Have you done any? Yeah. Peter, have you done any of these measurements? Because I've seen Bev do these measurements on video. Have you done any said measurements?
That is what's coming up.
All right, perfect. I'm waiting.
Before I show you the measurements, do we have an agreement in this room that this geometry allows us to determine if reality is orange or red?
No.
Euclidean geometry, right?
Geometry doesn't
All of this
enable
is
you to do
Euclidean
that.
geometry. All of this is Euclidean geometry.
No,
Perfect.
moving points
I
by
love it.
measuring angles is not Euclidean geometry.
We're not moving any points. The points exist no matter what we think.
Yes, but the problem is that you assume that we know that in the second triangle we traveled through the curve.
No,
It's
we
a different distance between
It's a
those
different
points.
distance.
It means that it wasn't measured in straight line.
Absolutely. Absolutely. Yes, you nailed
But
it.
it means that it wasn't measured because we only measure with straight lines.
No, we don't.
Yeah. Yes.
Does your car measure distance with straight lines?
Distance, yes.
Answer my question, please.
With straight lines, yes. Distance is straight line.
Oh, okay. So your car, when it goes over a hill that's curved, does it measure a straight line or does it measure the distance traveled over the arc?
You are conflating
Answer my question.
Distance with yes, I am
We've been through
clarifying
this
what
before.
you say.
Answer my
Not
question.
distance, but length. You are conflating
Okay.
length of the path with distance between 2 points.
Fantastic. Thank you. Thank you.
Yeah, there's a difference, Peter, between a
So-
longer distance and a shortest distance.
Yes. So
no disagreement now,
They're both
right?
still straight line distances, aren't
No disagreement
they? When
now,
compared
correct?
to each other, Peter.
No disagreement now, yes?
But one more clarifying. In first instance, this yellow triangle, we know that we traveled with a straight line.
Yes.
So it is distance.
Okay, and also length.
But yes, length and distance, because it is straight
Fantastic.
line. But in second instance, we don't know.
We don't know.
We don't know.
Actually, in my in this measurement, we don't know either.
Yeah, we do.
Because
We
we're not
know the 3
presupposing.
points,
We're not
don't we?
presupposing. Yes, that's what we do, but we don't know the angle. That's why we're measuring the angle. And
What do you
in
mean
fact,
you don't know the angle. You don't need to know the angle. You can do this by
you don't.
Pythagorean formula once you know those
Yes.
two.
Well, you don't know. You need to measure reality to see what she's like.
No, in order to get the triangle, you just
I'm not
need
presupposing,
those
brother.
2
I'm not presupposing.
distances, don't you?
But the whole point is not to presuppose if it's a straight line or if it's an arc.
You use the Pythagorean theorem. There's no need
But that's
to
not what I'm doing.
presuppose.
But that is not what I'm doing. You're missing the point.
Well, you're checking the distances then.
What I'm checking is what my anonymous friend eloquently explained, which is, was the length traveled?
A straight line.
By the way, I completely disagree that the word distance and length describe different things, but I am not going to argue this. So I'm just for the audience, I made this comment, so they don't think I'm stupid. So he said the length traveled is all we know.
So you're checking
we don't
that
know.
That's a straight line.
Yes. Yes, I'm checking if it's a straight line or if it's an arc. Exactly.
And
Bingo.
you're gonna measure an angle.
I love you, Bev. You're amazing.
You're
yes.
gonna measure an
By
angle.
measuring the angle, Bev.
Yeah.
I really like you right now. By measuring the angle, I am going to determine indirectly through this formula, which cannot be questioned, like you said so passionately. Using this firm formula, by measuring this angle, I'm going to determine if it was case X or case Y.
And case Y
X
is the fact that you couldn't actually measure an angle because it's
case
not a
X
straight
is
line.
happy face for flat Earth, and case Y is frowny face for flat Earth.
Yeah, you're going to assume that it's not an angle.
Yeah, you cannot measure angle to the curve.
That's a stolen concept. That's
I'm not
your
measuring
problem.
an angle
you
to the
were
curve.
stepping right there.
Where am I measuring?
You're measuring an angle to assume
the curve.
it wasn't an
Right.
angle.
Show me where.
This B2 is connected with dotted line, which is curve. And
Yes.
you are
Am I measuring an angle there?
measuring angle at yes. You
No.
Yes.
Yeah, that's where the angle is
Yes.
that you're measuring.
Yes.
It is not.
Yes. Angle
It's hard
is
to see. I will show you. The angle alpha 2 is angle between C2, A, and B1. It's the angle, it's the zenith. This is the horizontal line. I drew it on
But
purpose.
C1 and C2 are in different places.
C1, no. Read what it says. C2,
Yeah.
A.
But yeah, I'm saying
Obviously,
you're measuring an
B1.
angle in reality, but you've got two different positions for C1 and C2.
The
Again,
point is
these are two
the starting
possibilities.
point.
No, that's the angle that you're measuring, isn't it?
Bev, calm down. Calm down. I don't know which one I'm measuring. I'm just telling you that both alpha 1 and alpha 2 are zenith angles measured from horizontal, essentially it's the same thing, horizontal to this line. I could also show them like this. One angle here, one angle there. I'm sorry, to this line, to the line of sight. There's no curve involved in the angle at all. I realize that this is hard to see. I can zoom in on it if you guys want. But the angle is between line of sight. We don't know which one is the case. That's the whole point.
That's what I'm
But
saying. There's two
between
different
those and
things
the
there.
horizontal, these are two different possibilities.
But you're just measuring an angle.
I am measuring an angle, yes.
So why is there two different points? Which one are you using for your angle?
We don't know.
What do you mean you don't know?
In reality,
Paradigms.
we're
You do
looking
know
at
because you've measured them.
looking at a certain object. Let's call it
Are you
point
thinking
C.
that the people that measured those points for those buildings didn't actually know where they were? And then they said
knew
to
where
somebody,
they were.
go 20 away over there and measure an angle and tell us where we are. Because we're unsure.
No, these people were
It's a
at
stolen
point
concept,
B,
Peter.
and they measured
It's
a
all
vertical
known
height.
already. You're just
It
imagining
is.
you can change those positions with
I'm
an
not
angle.
changing any positions. No. This is how we do natural sciences. We go, we measure, and then we think. These are two
You think
possibilities
this
that
is
we
a
can measure.
natural science? You measuring an angle or something that
Absolutely.
you've never done. You've never done this, have you, Peter?
Absolutely.
You've never done
Measuring
it.
an
Absolutely,
angle
you've
tells
never
you some
done
things
this.
about reality. And here is one thing that it tells you.
These are two parallel universes. One's a flat Earth, one's a globe, and there's two alternatives.
And we
He's
need to
doing it
find
in
out which
reality.
one we're actually
He's
in.
doing it
right?
in reality, or he's imagining he's doing
Thank
it
you,
in
Dragon.
reality. There
I
are
hope the
people
audience I know that
do
the
this.
audience
Well,
understands
not actually this,
what I'm
because nobody
saying.
measures angles to
Bev is being
buildings
obtuse
from
on
20
purpose.
away.
He's done this before. I know what he's doing.
There's no purpose to do that.
The audience, most of the audience knows that I'm presenting two possibilities, and the purpose of the measurement is to determine which of the two possibilities we actually live in. Earth is flat,
Possibilities
Earth is
for
curved.
unknown, Peter.
Yes, because yes, known, but your second instance is unknown because
Both
you
of
don't
them are
know,
unknown.
Because in first instance we have distance, straight line, which is
But
measured.
you don't know. You don't know.
Yeah,
You're presupposing.
You said it was. That, if you go back to the first slide, what was number one,
presupposing.
Peter? What were the things that we had to agree on, Peter?
Right here?
Yeah. Measuring distances from point A to B over the surface of the Earth at distances of up to 40 kilometers. Now, when you add 20, was that just 20? Was that like within that? So it's a known, right?
Yes.
We are capable of doing that.
Yes.
If you are
We agree
changing
to
now,
it.
and if you are changing now this distance, and now it is length, it is still measured in straight line.
Let me ask you, does your car measure length in straight line when you travel
Peter,
over a
in
hill?
reality, we don't use cars.
Yes, we don't use cars.
Certainly we do. We can use an
No.
odometer.
No. To measure distance between point A and point B, we don't use cars.
Can we measure the length from point A to B?
No length, distance.
Can we measure, if we have a hill, can we measure the length of the road?
You are changing standard.
Yes.
Yeah.
Now,
Do not think.
So it means that you are dishonest at that point.
No.
Yes.
I'm just
Yes.
talking
do not
to
use a
the
car
language that you
to measure
use.
anything.
Let me
I'm
ask
an
a
auto
question.
mechanic. No, I work on cars every day, and the next person that says you can measure distance with an odometer is dumb.
Okay, I'm going to ask a different question. No more cars. If we have a road going over a hill, can we measure the length of the road?
Yes, we can measure length of the road, but we are talking about triangle, and
I am not talking about a triangle yet. If I traveled from point A to B, can I measure the length of the distance traveled?
Sorry, but in triangles we have straight lines only.
Will it help you if I delete the triangle and only show you the arc?
So you are deleting your proof then?
No. Just to help you get over
There's no
that
angle.
fact.
You're going to show us that there is no angle now in one of
No,
your
no.
models.
It's worth the time. I think it's worth
real
the
thing.
time. I'm going to take the time. Okay?
You mad,
to do
Peter?
that.
But I mean, hats off
No.
to you, man. You've
I'm
got to
very
get the
patient.
backing. I mean, I know you're a sect apart from the traditional globe guys, but this is a rogue sect, right? The globe guys will know, won't they?
Yeah, with a new breed. We're coming.
Mm-hmm. The
It's
globe
evolution.
provers.
Evolution, that's all.
If you have triangle, you have straight lines only.
I don't have a triangle anymore.
There are proofs in
You
mathematics,
have
though, Peter, right?
in your presentation. It is part
I
of
have a
your
question.
proof.
Okay, I have a question now for the audience. Let me just switch the screen.
It's like realizing Euclid, this sort of shit. It's pretty good, Peter.
Okay.
I like it.
Okay, that's cool. 1 second, please.
Get this shared out, everyone. Right? If you know
Okay, I have a
anybody that
question.
knows anything about globe, right? They're gonna want to know about this.
He might get
Okay,
coffee with
if
Brendan.
I'm
You
traveling,
might, there you go. Yui's right. you might get coffee with Brenda. Yui
That's
says
cool.
he might be able to sort you out for a coffee pass with Brenda and Mike.
That's nice.
And the
So I have
after
a question.
party, wink, wink, nudge, nudge.
I have a question. Can I measure the length of an arc traveled in reality, like over a hill?
Can you? No.
No, I'm sorry. Yes, good. Another question. Could a human being that's good at measuring things, not me, measure the length of an arc traveled, for example, over a hill?
Yeah, you'd have to know the elevations of all of the points across the hill to get that. But yeah, of course they could.
Do people that make maps, are they good at that? Can they measure, like, can they tell you to go from point A to B is length of this many, miles?
Yeah, like an elevation profile. If they're wanting to lay like
Answer my
pipe or
question.
whatever like
Do
that,
people
then they
who make
would
maps,
do. Yeah, they definitely. Yes.
are they able to represent distances between points as traveled on the surface, the
Yes.
length of
For
those
example,
between the 2 points?
whenever they're laying pipe for large distances across country, yes, they can do that. Elevation profiles to see exactly what would happen.
Nice,
Yes, they would
nice.
definitely know
So
that.
when they go, for example, they do power lines over a hill, they know that like the length they will need is bigger than if they were going through a straight line, right?
Absolutely, yes.
Okay, so what I'm showing on the picture, so I don't have to do this all over again, is doable. If you imagine blue is a hill, we could measure that length, d equals 20, yeah?
Yeah, but all they would do in reality would be to measure the horizontal and vertical, right?
I don't know, because it doesn't have to be like even, it could have bumps in it, right?
Yeah, but they would measure the verticals at all of the positions along the horizontal, right? In order for you to tell all of the different elevation changes from point A to B, right? Beginning to the end.
Okay.
Of course,
But in general, human beings are currently pretty good at establishing
we
the
agreed
length
to it,
between
Peter.
2
Yes,
points.
come on. We agreed
Awesome,
to it. We
awesome.
can measure distances.
That's all
we
I
can
needed.
apply all of these geometric facts
That's
to
all I needed.
reality. Yes.
That's all I needed. Going back to the ultimate proof.
We do know that you can't measure an angle to a curve, though, as well.
Yes, so we're not doing that. That's the good news. We're not doing that. Are there any other questions here? Why we're doing this, what these pictures mean, and what I mean when I say...
But yeah,
you will find out.
I did ask you a question earlier, Peter.
Yes, what was it?
Said, can you show me these measurements?
Yes,
you haven't
that's
shown
next.
any
That's
measurements yet. Yeah,
Yes,
that's what
that's
I heard half an hour ago.
But
Thanks.
before I show you, I need
Appreciate
to
it.
find out that you understand what I'm going to convey to you after I show you these measurements. So you get it. Everybody gets this, yeah?
Well, I guarantee you I will understand what you're putting across.
Fantastic. Let's go. Let's move on. Okay, here are the measurements. We have 2 points. We're observing from this point. This is not far where I live, actually. And we're observing another point. They're at the same elevation. And we're looking for this observer height, I should say, which is that plus the height of the instrument. And we are looking at a point. It's a building, but we're looking at a known point on the building that has this elevation. And we know the distance between the 2 points is exactly this. Okay? And we're measuring, the only thing we're measuring, all these things were measured for us by other people. The elevation, the height of the building, the distance. What we are measuring today is the zenith angle,
the
and the
people.
tool. The good people that are doing this.
Trustworthy people.
Very trustworthy, personally verified.
Wow.
What we're doing is we have a tool that is precise to within 10 arc seconds. So this much of a degree.
Oh, how precise? What is 10 arc seconds in a measurement? Yeah,
Here,
10 arc seconds. How much is that in, say, millimeters?
Well, it's in degrees.
Yeah. Can you transfer it to millimeters?
No, you don't.
please?
You don't. Degrees are not translated to length unit.
Yes,
We
you
don't
can,
measure. We don't measure
if you have the
anything in
distance.
degrees.
Sorry, if you have distance like 21 miles, you can translate this.
Yes, but that's not the point. That's a triangle I showed you. That's how you know the base of the line of sight. Yes, but that's not the point.
Late to the party on this.
We're measuring an angle.
Yeah, but what's the distance at 20? So did you work out what that
I'll
accuracy
show
was
you.
over that 20?
I will actually answer that question. I will answer that question a bit
10
later.
arc
I'll show you.
seconds is, George
This
used
is-
to talk about an accuracy of 1 arc second.
Yes, because there are more precise theodolites that use that can do 1 arc second, but that's not what was used in this observation. So I'm not lying
So
to
that's
you.
a
I'm
bad
telling
one,
you.
right? You get a mark
It's
down
an
by
okay.
George there.
Yeah, we
I'm
could
not
use
so
a
sure
better
you're
one.
ready, Peter, for taking up the final work. You're just not.
Oh, don't you worry. It is precise enough to demonstrate what needs to be demonstrated.
Put together a GoFundMe if you want a better one anyway.
So, any questions about the parameters of the observation?
You're measuring an angle over how far is that?
Measuring an angle over 34.12 kilometers.
Okay.
How accurate is that?
What was that?
10 arc second.
10 arc seconds precision of the tool, yes.
I still think it's relevant. Well, I guess you're going to get there. Never mind. Go ahead. Carry on.
Okay.
So you already know
Here it-
your elevation, the elevation of the thing, and the distance between, yeah?
Absolutely,
All
yes.
knowns.
Absolutely.
Okay.
The only thing that we are establishing is this.
The angle.
The drop angle, yes.
All of the other distances are known.
Yes.
Is it known to be a horizontal distance?
The distance on the surface is known, yes.
On the surface, it means
The length.
Yeah.
I'm sorry, I misspoke. The length.
Between the perpendiculars.
Yeah, I need to fix it just for
but
the
this
anonymous speaker.
length was measured with the straight lines or not?
Yeah.
It was measured using many different tools, many measurements on the maps. Every single map made of this area for the last 300 years has the length on surface of this valley.
Measurable with a scale ruler.
Measured using different tools,
Yeah.
many different tools.
No, but I
It
mean,
has
on
to
the
be-
map,
it
you could
has to
use
be
a
straight
scale
lines.
ruler to get a straight line distance from A to B, right?
Yeah, you could do that, or
That's
you
the
could
measured
calculate
distance, right? That's
the
how they
length
made the
on
map.
the surface. The length on the surface.
Mm-hmm.
It has
Yeah.
to be straight line then.
Yeah.
No, it doesn't.
Yeah,
Yeah.
it is. It's just a straight line, scaled
No.
map. We've just done
It's
it
like
with a ruler.
traveling from point A to point B on the surface. That's what this number is. Traveling on the surface and counting the length traveled.
I think
That's what it is.
that it is misrepresentation what this measurement was. Because
That's what it is.
Nobody measures length on surface from point A to B.
That's what people who make maps do.
No, absolutely not.
Yes, they do.
Absolutely not.
Yes, they do.
No.
Yes, they do. Because they can show you elevation and they can show you zero elevation and they can tell you the distance between 2 points of zero elevation. That's distance over surface or length,
Horizontal
as you say.
distance.
No,
According to
horizontal.
you, but we're here to decide if you're correct about your
So
interpretation
you're
of
checking
reality.
whether a horizontal is the shortest distance
No,
between
I'm
two
not
points.
checking. I'm showing that your understanding of reality is incorrect. That's the whole point of this measurement,
Yeah,
is
but
to
my
show to you.
understanding of reality is that the shortest distance between 2 points is a horizontal distance.
Exactly, and that's why I'm here.
To disprove that.
Exactly.
Carry on.
Because the statement you made only makes sense in the world.
It is the ultimate proof.
That is this world. This is the ultimate proof.
Yeah, just this.
The
Yeah,
statement
where we
you
live,
just
yeah.
made,
That's where it applies.
Bev, the state you just made that came out of your mouth just now only makes sense in this reality that I highlighted on the screen. And I am here to show you that this is not the reality we actually live in. That's the whole point. So you saying I disagree because the distance or whatever length is horizontal, schmontal. Yes, I expect you to say this, and I'm here to show you that that is not true. Okay? So I cannot accept your definitions because they are incorrect. I'm telling you that humans...
You do know, Peter, that I'm not a flat earther, right? You
No,
don't
absolutely
need to
not.
disprove this, which occurs in
What I am
reality, because you
disproving...
assume that I'm a flat earther, because I'm not.
No, I'm not assuming that. I'm sorry, the slides are done for other people too. What I am disproving, what I am proving, is that Bev, try thinking, is wrong about his interpretation of reality. This is what I am proving.
That the shortest distance between 2 points
And
is a horizontal distance.
I am here to show that Bev does not know what the distance on the surface of the actual Earth in reality is. Bev has an idea what it is, but that idea is incorrect, and it will be shown to be incorrect using basic high school geometry presented on the previous slides.
Peter, but I mean, please.
This is what we're going to show to the audience.
Peter, you do know that Bev's got a land surveying certificate, don't you?
Yes, he has an A in land surveying. He told us.
Making you aware.
Yeah, Peter's
Performing measurements
obviously
is not
just
the same
one
as
of these new
interpreting them.
breeds of troll sophists, right? Because he's
No,
literally trying to disprove
new breed of radical
a horizontal
globers.
distance, aren't you, Peter?
Absolutely not. There is such a thing as horizontal distance, you could say. For example, this line of sight.
Between 2 points.
Yeah, like the shortest distance between my eyeball in this picture and the top of the building is what you could call straight line distance. But that's I'm here to. It is not horizontal because I'm looking 0.044 degrees down the horizon line.
Yeah, if you were looking up, then that would be a longer distance, wouldn't it?
Exactly.
So the horizontal distance would be the shortest distance, wouldn't it?
Absolutely.
Yeah.
And what I am here to show you, but that's not what I'm here to show. What I'm here to show is that the distance traveled on the surface between A and B is an arc. Okay? So let's look at what these measurements mean, my friend.
Are you trying to say that the measured horizontal distance isn't
Here
a measured
is
horizontal distance?
No, that's not what I'm saying. Here's what we are showing, and
What
this
are
is
you
the
showing
same.
then, Peter? Because it's getting really confusing. And like, you're not only confusing
happy to
yourself,
take questions.
but there's a lot of people here listening, getting really bored and wondering, what the fuck you saying, Peter?
This is the last slide. So let me just blast through this slide and then I'll take any questions. So this is the same relationship that I showed you guys.
Measurements.
This is the same relationship that I showed you guys earlier. Okay. It is just to scale. So the radius of the Earth that we believe in, don't worry about it, is set to what we believe in. The distance or the length is what was in the observation. The height of the building in meters is what the observation was. And the elevation of sea level is also as in reality. So I know that these lines are all kind of blurred together. If I zoomed in, you'd see a slight difference, but on real Earth, the difference is quite small.
What, a
However,
difference in distances?
yes.
Like a
However,
meter?
yes.
So
However,
how much difference is there in a meter?
I'll show you in a minute, because I have a picture like that I can switch to. But I want to drive the conclusion, and then I'll show you and make myself available to all of your scrutiny, okay, collective scrutiny. So, in the flat Earth case, the angle measured should have been around 11 degrees. In the globe Earth case, it should be measured, oh, and that's positive and negative. So on flat Earth, we should have measured 11 degrees at that distance above eye level. And on curved Earth, with this radius, Neil deGrasse Tyson radius, we should have measured a negative angle, a drop angle of 0.38, yada yada. Those were the expected angles. However, we measured negative 0.044. This is off by 11% from the globe model, and it is off by 361 and 0.36% from flat Earth. I welcome you to the globe.
wrong?
I welcome you to the globe. And this beautiful planet is the planet that God created for all of you, including myself, to enjoy and live on. And I thank you for your time, my brothers and sisters.
Woo! More globe proof. Woo!
One note.
Thank you, Yui.
God didn't create planet.
He disagrees with you.
Did you know that? Did you know that you're taking advantage of the ignorance of most people of how vision works?
No, I'm taking advantage of their ignorance of geometry.
No, because you're conflating what you see with that side-on view, the telecentric view. You know, your vision is, yeah. You're
What's wrong with
two
my
different
vision?
things.
What's wrong with my vision?
But you have entocentric vision and you have perspective error that's involved with that. And that's why the tools are set up to only be used at a certain distance. You're going past that, taking advantage of most people's ignorance of that, how lenses work.
So, is it not possible to establish a line of sight between me and that location on the building?
At that distance, 20 kilometers or 20 miles, no, it is not possible.
So that's not a straight line?
It is not
Not an
possible.
accurate straight line.
Yeah, it could be deviated a little bit, right? By
Already a measured distance. It's already known.
On the surface?
Yeah, you already know the points that you're
On the
dealing with.
surface?
How do you think they know them?
On the surface?
They've already measured
No,
them.
you are adding this on the surface. Nobody measures distance between 2 points on the surface.
Yes, they do.
No, they don't.
People who build railroads do. They need to know how much track they need to lay.
Of course they, but this is not measuring distance between 2 points.
Of course it is.
So if they know if distance between 2 points on the horizontal is, let's say, 20 kilometers or whatever, and they measure elevation changes, so they know that this line will be longer. They know
You
that.
can measure distance between 2 points on the surface without knowing the shape of the surface.
You mean length? Yes, we can. Yes.
I actually decided not to keep saying length because I was too nice to you. So you can measure distance between 2 points on a surface without knowing the shape of the surface.
No, it is impossible.
Yes, you can. All you need to do is to move yourself from one point to the next and measure the increments in which you moved.
It is not distance. Yes, if line is curved, it is not distance. So
You can say whatever you
it
want.
doesn't.
But you can do that.
No. It is not that you are being polite. It is just being truthful or not.
You're misusing the English terms. Length would actually be a more appropriate term for describing the straight line
doesn't actually
distance.
know how it's done in reality. He's not really
Yeah,
got a clue. You can't blame him. He's just ignorant of it. But nice globe proof, Peter. I see how it works with your peers, really. I don't think it's us that you have to sell it to be honest. But, you know.
And by the way, I have general, let's say, statement about proof, because you didn't create proof, because proof is, for example, like syllogism or conditional statement, like modus ponens or modus tollens or whatever. This is argument.
I use modus ponens.
I'm still trying to work that one out, actually. Now paper says that. I mean, what would you sum it up as? If you measure an angle, then you can falsify the geometric principles that have been laid down and proved. Something like that.
I'll make it here. I'll form a... So we are a new radical breed of globers, okay? And we do things differently. First of all, we only do proofs. We provide no evidence whatsoever. We only provide proofs because we don't care what anybody else says.
Yeah, you don't actually know what a proof is, do you? But I mean...
But we do. We have our own definition. We're radical.
Yeah, ignorant
We're
of
radical.
proof.
Yeah. We have decided that to counter the level of stupid that currently emanates out of the flat earth community, we have to become even more radical. So we don't use any other syllogism but this one, modus ponens. Because I'm from Poland. So I use modus ponens, and actually my flavor is modus
you're not doing that
ponens
to take the piss out of Bob, are you?
Yes. So mine is modus ponens nolens, and it is as follows. Yui, keep me honest here because I'm still sketchy on my moduses. Yes. If flat Earth, then alpha.
Yeah, you are
will be
proper ignorant of this, aren't you?
8.53.
This is his globe. This is the dogmatic globe.
Hold
Right,
on.
it has to be. Has to be. Right, you best accept this.
Alpha was negative. Well, I'm sorry. This is not the real numbers.
The ultimate has to be.
Okay,
Yeah,
here it
has
goes.
to be. Yeah.
If flat Earth.
Stolen concept.
Then.
Falsified.
Yui, are you looking?
Principles.
Alpha, roughly.
Wait a second, Beth. I will deal with
Yui.
Yui's a bit quiet.
Angle was negative 0,
Whether he's the Son or the Holy Ghost, which one's he?
4, 4. Therefore.
If angle.
You sure you're not a doctor?
Therefore.
Not flat Earth.
Looks like a prescription there.
It's just a falsification of flat Earth. Don't forget about the false dichotomy.
And by the way, this is not modus tollens, it is modus tollens.
No, it's not.
Yes, it is.
No,
and
it's
by
not.
the way,
I don't use modus tollens.
By the way, do you know something about conditional statement?
Yes, I'm trying to remember what I know about.
Conditional statement, we have antecedent being the cause and consequent being effect.
Yes.
Yes. So in your example, what is antecedent and what is consequent?
Okay. If the Earth is flat, then the angle measured with these parameters that we know must be this value, or close to it, give or take measurement error, obviously.
Okay, so flat Earth is antecedent and
Yes.
angle is consequent.
Yes,
Measured
exactly.
angle.
So if the Earth were flat, then the angle measured must be, you know, as the consequence of the Earth being flat, this value. Of course, give or take, right? We're not saying exactly, but, you know, within. Okay? Since we measured a dramatically different angle by 361% different, then the Earth is not flat because of this.
And how does it prove globe?
Because then we formulate another Pohlens-Nolens. If the Earth is a globe with the radius of 6,370 kilometers, and then the angle measured should be negative 0.039, and we got a measurement with 11%.
And you think that this, because now you are creating positive proof, it means that you are creating a modus ponens, ponendo ponens.
I only do Pohlens-Nolens.
I don't
So
care.
that's rubbish in that
This
case.
is, but this is what you. This is modus ponens. By the anyway, you can call it modus ponens if you want, but in fact it is known. It is known as modus ponens, modus ponendo ponens, affirming by affirming. But in modus ponens, you are affirming P to affirm Q, but you are going otherwise. It means that you are affirming that the Earth is a globe, which is antecedent, by affirming the consequent. And
That's
this
not
is
what
called,
I'm affirming.
Yes, exactly. This is what you are doing.
I don't think so.
You are affirming that this is a globe because you are affirming the angle measured.
I don't think so.
Yes, this is what you wrote.
But I don't think so.
Wrote.
I don't
Yes,
think so.
It is on the screen. It was on the screen. So
I do not think so.
I don't care what you think.
Because I can explain this to you.
I'm
can
telling
explain.
you
Okay.
how this works. It means that if the Earth is a globe, then we have this angle, and this is what you have had on the screen.
Okay.
And this is modus ponens, but fallacious, because you are, instead of affirming antecedent, you are affirming consequent. So you are affirming consequent by affirming consequent. This is logical fallacy. Yes, this is formal logical fallacy. Thank you. Your proof is invalid and incorrect.
Let's try a different one. Let's try a different one.
You can try.
Okay. Here's what I'm saying. It is not possible to travel from point A to B2 on the surface by distance of 20, or, you know, in the actual measurement, it was different, but you know what I mean. And measure this angle unless the Earth is a globe with a known radius. Here's my new Pohlens-Nolens. If
it is impossible.
No, listen. If D H E alpha as measured, then no, it still should be done the other way around.
No,
And
because
if
sorry for interruption, but you are trying to change position of P and Q.
no. Let me reformulate. No, I'm reformulating.
What about this
If
paper? I think it should be
no,
called
wait,
the
don't interrupt.
self-refuting proof of the dogmatic globe.
Yes, globe has to be antecedent because globe is before measurement. So
Yes,
it
yes,
has to be
yes.
antecedent.
Okay, here you go.
If globe, then globe. Tis
No,
globe.
no, no, no. Wait. Stop trolling, you useless idiot. Adults are talking.
You haven't got a clue about this. You just keep changing it when you realise
Adults are
what a mess
speaking.
you've
It's
made.
going to be that. If globe, then globe. Tis globe. It has to be.
Okay,
There's
it
no other
doesn't-
way
If
it's
wait,
connected.
wait.
It
Jesus
doesn't matter.
Christ.
Angle measurement is consequent of the globe.
Exactly.
And what you have
I feel
measured.
sorry.
Here's what I'm saying. I'm going to simplify this. If the Earth is a globe with a radius of this much, then
So glad you chose us to
the
do this. You could have
relationship
chose Nathan Oakley, but you chose
then
us,
the
Peter.
relationship
Thank you very much.
then the relationship between these four values in reality must be like this.
Has to be.
Can you imagine a glober listening to this?
Yes, and these
thinking, is this all I got?
This is
these
it.
values.
This is it.
It's the ultimate.
So these
This is it.
values are
One's got it.
consequent of the globe.
Absolutely, yes.
Yes. So
you nailed it.
and you
Should be
are
honoured.
measuring these values to prove the globe. It means that you are affirming the consequent.
Has Dave Weiss still got that Bitcoin?
No, what I'm
going?
saying
We'll
is
get him over here.
These
It is
values.
still-
Somebody get Dave Weiss.
Yes,
Let's
I
get
am-
that Bitcoin.
Yeah, quick.
Let's
Oh
have a
no,
piece of
I
it.
got it.
What's
I know what
is
I
the
did
value
wrong.
of Bitcoin at the minute?
If and only
it.
if.
Yeah, I'm having this.
Only, yeah.
I'm having
Yes.
this, Peter.
Only.
Yui, where are you, Yui?
Yes,
You're the big fan of this.
Open it up a
Handed
bit. Get
you,
us some better
man.
slides.
Yui,
You
Get a
got
piece of
dragon
that.
instead.
Yeah.
Yui,
How to
Yui.
get rid of fallacy? You cannot.
Yui.
You cannot. It is
Yui.
impossible. It
I
is
just got rid of
Say
it.
fallacies like
I
you
got
wiped
rid of
away
it.
perm.
Have you got an
Yui,
erase
where are
function,
you?
Peter?
Yui.
I think
Erase
Yui might have
function.
stepped away for a bit.
What?
Yui, I think he has. He's embarrassed.
Manu, what did you say?
I think Yui might have stepped away for a bit, but
Yeah.
if and
So
only if
embarrassed.
is a good start. Yeah.
Yes. If, and this is what I was trying to say geometrically, but I didn't formulate it as a modus ponens nolens.
You can
So
just,
the
you
updated
can just start it with if, though, right? You can shorten if and only
if
to
and
just
only if.
Yeah, just
No,
No,
those are not the same
it's
thing.
different. Yeah.
Yes, they are if you use two Fs.
Modus pollen nolens, new modus pollen nolens, updated. If and only if the Earth is a globe with radius 6370, then in that particular relationship, in that reality situation, then the measurements for D, H, E, and alpha have to be this. There's no other way. You
Yes.
cannot have those four numbers unless the Earth is a globe with that radius.
Yes, but still P
That's the modus ponens
antecedent.
nolens.
Yes. Okay, so it is still fallacy.
No, it's a
because you are-
biconditional.
Biconditional.
This is Yui's little thing. He's biconditional.
Conditional statement.
Yes. this
If
is
and only
conditional.
if.
Yeah. Yes.
Either
and-
way, though, you could just flip those around. I mean, it doesn't really matter. It
I know,
doesn't-
of course.
when you yeah, but someone's saying that the Earth is the cause of the measurements. That's not necessarily the case. Not for a logical
Is
syllogism.
antecedent. Is antecedent. Absolutely antecedent. You cannot have measurement without
If and
globe.
only if.
Depends on what the syllogism is.
No. I am talking about antecedent in a conditional statement.
I understand what you're talking about.
It is necessary antecedent of these measurements.
Hmm.
Without
Okay, how does this sound as a syllogism?
it is not syllogism.
Sure, but here's I'm proposing one. Let's see if it's acceptable. Peter, can you go back to the first slide?
Can I
You
point
guys are
out
taking it
Absolutely.
too serious.
Yeah, can I point out that the proof by
Sorry.
self-refutation is a
The
pretty
third slide.
hard, sophisticated proof to pull
One more?
off,
This one?
and
Yeah,
it
yes,
relies
perfect.
upon the ignorance of the people around. Mainly, I think the ignorance of the guy proposing the argument,
let
but
Manu speak.
also
Manu
the
has
people
something
in the
useful to say.
around.
Stop bloviating. Let him speak.
Okay, I'm going to try this out. So if the measurements taken in the real world of angle A, distance D, and height BC retain the relationship as described by I just said A, right? A equals arctan H over D. Then we can know within tolerances of the instruments used that the world in which we live has curve.
This is
No,
not
no. If
syllogism.
no.
No, wait a
If they
minute.
retain this, if they
Oh,
retain,
right. Yes.
then flat
The world in
Earth.
which we live
Okay,
does
it
not
doesn't matter.
curve.
Right.
Details
It doesn't
doesn't
matter.
matter. In syllogism, you have three sentences: if, and if, therefore. And you have in syllogism, you have to have link between subject and predication.
Okay,
And
so that's the
second,
first one,
so
right? That's
it is.
That's what he said. Let him finish, though. Let him finish.
This is not what he said, because he said if, then. It is not syllogism.
He didn't finish, I don't think.
I think he did.
You don't even know what he's talking about. You're talking about, Pete. That's why you've got his other guys to
Well, he
explain
said
it. So you should
yeah.
be quiet.
It relies upon the
And
ignorance
and
of the guy making the argument, this self-refutation one.
And he's well
By
ignorant.
the way, in syllogism, still you have to go from general premise, major premise, to through minor premise to conclusion.
Yeah, that's why I would say, Mano, I would say
globe
if
is
the Earth is flat, then the three things measured, alpha, H, and D,
Yeah, but he
as
is right.
measured, will be in this relationship.
You're wrong, Peter.
But that's
Right?
Yes,
modus
so that would be the
tollens.
second premise, though. So the first premise would be that this relationship holds true for all right-angled triangles. All
Absolutely.
all right-angled triangles. If real-world measurements follow that relationship, blah 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 blah, then we can know that the Earth is flat. We took those measurements and they don't hold, therefore, not flat.
It is still fallacious
Exactly.
because
That's
you are.
I think that's what I said.
Sorry, my critique here. You were talking about word measurements, so on the surface, and in triangle, because you are talking about relation within triangle, we are not talking about surface. We are talking about straight lines. So we are not assuming.
Well, that's
any
your
surface.
last line of defense, to deny humanity the ability to measure distances over surface.
I'm just pointing out fallacies. So
That's and now, Kevin, you asked me why I had this here. Remember?
Hey, Peter.
Remember?
Yeah.
That's why I had it here.
Peter, when they measured the distances, it was mentioned that it was said earlier that the distance were measured on a horizontal baseline.
Nope.
1785, mate. Go and have a little listen. I'll put it up as a track. It's some old surveyors talking about how they used to do it with the horizontal baseline
in America.
Oh yeah. No, I think I have the link. Is it the link to the surveyors that measured spherical axis on the Earth?
No.
Oh, not
Definitely
those
not.
ones, huh? Not the ones that measured the spherical axis.
No.
Some other ones.
The ones that laid out the baseline.
But I'm gonna look at the ones that looked at the spherical axis. Why not? Maybe that's another ultimate proof in the hiding.
And what's spherical axis, Peter?
It's measuring more than 180 degrees between 3 points on the surface, Bev. But let's not go there tonight. I don't have the energy to do 2 ultimate proofs in a single day.
No, save it. That'll be a good one.
So,
Don't want to
since,
overload us.
and this was a great example of regarding the conversation between me and Kevin, what I was trying to say. You see, this is why I front load all these absurdities early on. So some guy, by the time he realizes that he was just shown the proof for globe, doesn't go like, oh yeah, but humans can't really look at things, or oh, humans don't know how to measure something because it could be 100 feet one day and 6 feet the next day, and stupid shit like that. So that's why we have it here up front. And now Mr. Anonymous tries to tell us that we cannot measure distance on the surface because he knows that the whole thing falls apart like a house of cards when we do.
Well, how does your triangle become the surface of anything? What that's if you're measuring
what triangle?
Sorry?
The one with
what triangle?
spherical excess.
I don't want to talk about spherical axis. It's not relevant here.
Well, I'm talking about the right angle triangle.
Okay, what about it?
The baseline of that triangle is the Earth. Is that what you're saying?
In the yellow case, yes. Maybe it's hard to see. I know this.
Get your Bitcoin.
What?
You should. This is your ultimate globe proof. You should go get your three Bitcoin. Do you know how much Bitcoin's worth right now?
I have
40
no idea.
grand.
Yeah.
Yeah, listen to me. 1 Bitcoin is worth like 40 grand.
Okay, I'll make you a deal right now.
Listen, no, shut up. Let me finish.
I know it.
There's a guy offering 3 Bitcoins for 1 globe proof. If you have it, go talk to him and get your money, bro.
Okay. Yeah.
Instead of wasting your time here, I don't want your deal. I got a good deal where I'm at. Don't worry about me.
Rob,
but I'm just trying to help you out.
Rob, if you help me collect the 3 Bitcoins, I'll give you 2 of those Bitcoins. I take 1, you take 2.
I don't need the Bitcoin.
Okay.
Don't worry about me.
Anyone else? This is a standing offer to anyone. Yes. This is a standing offer to anyone listening in the audience right now. If you help me deliver this proof to whoever the person is and collect and make them actually pay the 3 Bitcoins, you get 2 Bitcoins from me. I swear. I swear on everything. You get 2 Bitcoins. I get 1.
You've got the dragon. Let's go. Let's go. You got the dragon, man.
Peter, you know who Dave
Weiss is. Yeah, go with the dragon and bugger off. Go on.
It only makes sense.
Yes, I do know. Get your money.
Let's get him. We've talked to Dave, you know. Like, do you want to get him over here, Peter?
I kind of want to bet on whether he'd actually pay up.
Yeah. So if you help me,
his claim.
He's
making the offer.
Help me collect.
I mean, how could he deny that, right? All you've got to do is give it to him.
If
He
you
just-
help
he
me,
presents
of course
it
I'll
to
give it to him, and it's the ultimate proof. So there's no way it can fail.
Just
If you help
tag
me
your wallet.
Imagine how famous you would be, not amongst this crowd, right? Not only would you get, all of the Bitcoin off Dave Weiss, but can you imagine the adoration? The globe community.
It would be in the history books.
They'd be like breathing a sigh of relief. It's like, finally, we've got a proof to shut the flat earthers up.
Yes, we do. We have.
Are you here, Peter? Are you here? How many people are watching this?
Millions.
It'd encourage a lot of the flat earthers to do experiments, though, wouldn't it?
I think it'll
Try
have
and
a
disprove
wave
it.
of globe proofs, really. They've been sat around with nothing to do just to tell flat earthers that the earth's not flat. I mean, now they've got something positive to aim for.
I mean, we can't just rely on NASA all the time, can we?
I know. Just think about people will learn logic to formulate the arguments, put it together in the
Oh
correct
shit, yeah.
form.
I told you it's an
Science.
evolution of science. An evolution of science. We're the next stage of evolution.
Mm-hmm.
That's all.
Go and tell all the builders to just chuck away all their levels, all their spirit levels, water levels, and get themselves.
Why would they?
What would you replace it with? A sextant?
Just
Hey
change
guys,
the
you
manual.
know,
You just have to change the way it's worded in the manual.
Why
You'll be
would
all
you
right.
need to do that? Why?
Hey, spot on. They can only build at night then, you know.
The angle thing
Get
would
the
have to
star
be
position.
changed, though, wouldn't it?
Why? Why would you need
Or
to
would
do
it?
that?
Because if you have a level, you live on flat Earth.
Give me
They
one
wouldn't want to
reason
hear.
why. One
They
reason.
say, "Bugger off! I'm just building a house."
Yeah.
Give us one reason.
What do you mean I'm a flat earther? I'm only building a house.
Yeah, say, tell him
Yeah.
Peter's measured an angle. Like, do you know this
You just have
angle's
to
been measured
recommend
over here?
So
Give
all
us
of the
one reason.
millions of globers out there who build buildings for a living, who use levels every single day, and don't
Yeah.
lose a minute of sleep.
I know. No,
Why do you
nobody
think
does.
that is?
No, but
Because
Just
the thing what Peter said.
all it is it's only because
People-
someone hasn't called him a flat earther yet.
Yeah.
Sorry.
No, what it is from before, it's just because we need to recommend that they're not to using like a 5-mile spirit level. That's all.
Wait,
Give
Get
me
wait
some
one
till
fixed
they
goals.
reason
find
why
out
they would
that.
have to give up
Wait till
those
they
tools.
find
One
out that
reason.
level being horizontal is flat Earth. They'll give it up in a second, in a heartbeat. Don't
If
worry
one
about it.
reason, one of you maniacs provide one reason
You
why
don't even
builders
you
need
don't
to
even
give up
need to
levels.
replace it with
Because
anything.
you
Just
said-
say like, that's flat Earth.
You should put up billboards and watch the globers convert by the millions.
I don't know.
You said
No, we-
that if it's possible to have 2 points at equal elevation that are horizontal, that you live on flat Earth.
Yeah.
Yes, and
That's
it's
it.
not
So if you
possible.
have
So what?
if a builder has a tool for establishing that, therefore he lives on flat Earth.
Yeah.
One thing though,
No, there's one more possibility. What he is doing on that scale can absolutely tolerate the minute, extremely minute difference
But you can't
in the
measure-
horizontal. In the
What
horizontal
happens?
plane.
What happens if
Extremely
it's
minute,
So
almost
level
negligible.
can't be horizontal.
what if he's
Then.
also
But
everybody
you-
seems to have ignored the word always in what Peter wrote.
Right.
what happens if he's making a canal for 6
Um,
miles
and
long?
only if.
Then
If and only
he
if.
can just stay level at every point. He's going to be fine.
Well, he knows that.
Mm-hmm.
Yeah, just stay the same elevation at every point, be it 0, for example, through the length of the
Yeah.
canal. Don't even worry if it's
The
curved
water.
or not.
And that'll work on a flat or a globe.
Exactly. Just
amazing.
stay at 0. Stay at
It
0.
works in
No
reality,
problemo.
doesn't it?
Absolutely.
does.
That's the only reason why we have canals.
Yeah. That's
So I guess
why.
canals aren't proof either way.
Yeah, but level being
You've never measured
horizontal
one, what would you know?
happens in reality,
No.
right? But that happens on the real globe, right?
That only
No,
happens in
on a
this
small
VC.
scale.
Yes,
Yeah, on a small
they're
scale.
not
The
on the
real
same
globe
plane.
where everybody lives.
They're
In
not on the same plane, Bev.
reality.
In reality,
Yeah.
2 points
Reality.
of
The
equal
canal is 6
elevation
miles long and it's
are
level.
not on the same horizontal plane. They're not. I just
But
showed
they
you.
are.
Shift that bridge, Peter.
They
I
are,
just showed
though,
you.
Peter.
I just showed you that they're not.
Yeah, that's how you
Peter?
measure elevation changes, Peter. Using the
I
principle
literally
of the
just
tool.
showed you.
You said it's locally level and horizontal, and
I literally
so
just
your
showed you.
canal's level and horizontal. Yeah.
I literally just showed you that points A, if you look at the screen, points A and B2 are specifically points of equal elevation. I even freaking drew this here. Elevation equals 1, elevation equals 1. Yet, they're not on the same horizontal plane. The horizontal plane for point A is this plane, and you can clearly see that point
level
B2 is below it.
horizontal earlier. You said level is horizontal.
Absolutely, it is
Yeah,
right here. Horizontal equals level at point
Right.
A.
Okay. So the
Absolutely.
canal is level and horizontal, the surface of the water. Yeah.
Canal is level at every point on the
Every
canal.
point.
Here, here,
And
here,
horizontal.
here,
Yeah.
here, and it has its own horizontal here, a slightly different horizontal here. Obviously these are skewed. But I showed you in GeoGebra earlier exactly
Dip
what
or
that
drop
means.
then.
So it's not one
Dip or
horizontal.
drop.
You've got more than
Hump or
one.
drop.
Every point on a sphere has its own horizontal plane. Yes,
So you
absolutely.
say. Hump or
Yes.
drop.
Absolutely.
Hump or drop.
Is it? Yeah.
Absolutely.
It depends
Where
on
do
where
you
you
go for the
stood.
hump or the drop?
Mic
Yeah.
drop.
Hump
Absolutely.
or
Stood
drop.
in the middle is the drop, and then if you
No, on the
stood at
canal.
the end,
On the canal, hump or drop.
on the
You're
dogmatic
always on
globe.
the
obviously.
sagittal. You're always on the
the
sagittal
canal.
between 2
In
points.
reality, the
These
water
guys, fucking
is
hell.
level, horizontal for 6 miles. In reality,
These
Did someone
guys.
just say a hump or a drop?
These
you
guys.
said it is.
At
You
each
said
point,
it's curving. You said it's
you take
curving.
a step. There's a new horizontal and a
Water is
new level.
curving. You said
And
water's curving. 6 miles. So is it dropping? A hump in the middle? How does that work? In
it's not just in the middle, though.
reality.
The
Yeah.
sagittal is in the middle.
So it's lower at the other end then, is it? If you stood on a
Sagittarius the
bridge
hump.
and
It's
there's a bridge at
relative.
either end and you
It's
stood on one of
relative
the
to where
bridges.
you're measuring it from.
Yeah, okay. So if you stood on one bridge, does it drop into the other bridge?
You need relevance to the other person's measurement, and this is what we're talking about. It's the relationship between the two observers' measurements.
Yeah, you have the
Are you actually
water.
being serious?
Yeah, he is. He thinks he is.
Do you reckon he is being serious? Seriously, though. Seriously, in a serious.
Perhaps in his mind, that's because he's planted a model there that has to conform to that. It cannot conform to what we can see in reality. But how do you describe that in reality? That when you look at 6 miles of water that we know is going to be horizontal, not flowing, it's at rest. Now describe where it's curving, what's dropping. Is it a hump in the middle? You just said Sagittarius, that's a hump.
I was putting in like
If you stand in the
better
middle of
word.
the Sagittarius, then what? Is there another hump between you and the bridge, and the one behind you? Is another hump there?
There's like an infinite amount of sagittars between you. Depends on where you're measuring from, man. Wherever you measure from, there's a
24
sagittar.
feet. You've got to account
You're at
for
the
24 feet. You've got to account for 24 feet of the 6 miles. Describe that. Describe that. In reality,
They can't. They can't. That's the thing. They can
without the
talk all this
water
stuff
flowing.
and draw things on boards and all that shit. Look. I mean, Peter's globe proof there.
If you raise the water level up, because at different elevations, then the water will flow, won't it?
It's about time. Bevy, you're not like thrilled. What's going on?
Because you just got to get off of your computer and you're shining your ass on a chair university and apply that in
Globe
reality.
proof is finally here.
No, it's not.
It's
Just a lot of
globe.
scribbling
We've
on
always told
paper.
you.
That had to be
We've
changed
got some
1,000
better
times.
dogmatic proof than you.
Yeah. And it's not going to go down well, I'm telling you. If you go and show this to anyone else apart from us, you're going to be getting some serious stick, I'm telling you.
Yeah, I hope this.
What's going to happen? What's going to
It's
happen?
a good job this won't be going out to many people, right?
Yeah.
I'm gonna get my Bitcoin
Because you got
wallet
proof.
ready. Don't worry.
Any glober that goes around saying they got a proof is going to get
But
pushed
we are
away.
the new radical group of Globers. Yui, why were you
Never
not
mind.
here?
Radical
Yeah, but they say that men. They say men can be women too.
If you look
That's
at your
new.
DMs, Peter, there's
What?
a reason why I wasn't focusing on what was going on in the VC. And that's
Because you don't give a shit. That's why. You don't give a shit about what Peter's doing. You're just here for the laugh. You know that.
Is ready. It's ready.
Listen to him.
It's done.
It's ready.
What's ready?
Ultimate Globe Proof 3.0.
Are you gonna drop
Wow,
it now?
so soon.
No, I want you in Manufactotum to watch it first.
It's evolving. We told you.
Oh man, look at this.
Well, 4. There's 4 now, isn't it? Is Dragon part of the group now?
If they had proof, they'd be going to Dave Weiss and getting
wait
their
a minute,
fucking
no,
Bitcoin.
don't put them off. Don't put them off. We can sort that out. This is polishing their globe proof off, right?
Polishing their turd.
So, yeah, polishing it up, fixing it up. We can
Yeah.
sort out Dave Weiss and all of that. Don't worry about
It's like
it.
stress testing.
Yeah,
Modern
Stress
man,
testing, don't worry.
modern globe.
These guys
Are you ready to have a go at it then?
Yui, Mano, should we meet just the three of us?
Do you want like a 5 or 10 minute get together to just sort of, because I mean, like, you've never seen it, you don't want to be going over it blind, do you? At least
the mesh
sort
you
out
made of
between
the
yourselves, right?
Well, the other two, you ain't got a fucking clue anyway about what Pete was talking about a minute ago.
Well,
So
I know he needs to come up with it, yeah. Blue Marbles advised him on this one. Is this the one? Yeah.
The modus polens nonsense.
Yeah, modus polens.
Modus polens.
Yeah.
Quick, scribble that bit out. No, I didn't mean that. Let me just change this a bit. No, sorry, no, I didn't mean that.
No, this is the new breed. Don't stifle them. These are a radical new group of globe provers.
They're actually glowing anti-logo.
Radical, I like.
Yeah, well, they've not been doing it for years. All of them old, the boomer squad, let's call them that.
Yeah,
they're gone.
Dangling balls in sheds.
Who needs
and
them?
shit.
Yeah.
Exactly.
Who needs that? Who needs the size mama dish?
Yeah, that was done 2,000 years ago, wasn't it? Something like that.
Yeah.
Anyway, some time ago when they were measuring sticks and shadows,
Yeah.
that kind of time.
Yeah,
The
you're not
old
going to
school.
start getting the sticks out, are you?
Yeah, okay. Well,
Usually
I'm gonna be
carbon
right
fibre
back. We're
poles
just going
these days.
to convene with the Trinity, and then we'll be back once we've.
Okie dokie.
I thought there was
Don't
four
leave
of
us
them.
hanging for too long, right?
We won't.
Take Turquoise with you. Don't let him out, right? He's
Yeah,
I'm
jeez.
not part of the Trinity.
part of the team.
Yeah, you slipped in here and just waited to
Turquoise.
the
So
opportune
Turquoise has
moment.
just turned a triangle into a four-sided. Well, I don't even know what they call it these days.
Five-sided square, you mean?
Five-sided square.
Yeah.
540-degree triangle.
180, 180, 180. Do you know where you are? Oh,
Yeah, I'm over there.
You're giving someone some directions. Yeah.
I went round the back of the shops.
I'm glad that they're doing it tonight because, like we say, it is
Oh,
UFC
really?
night
Oh,
tomorrow.
midnight,
and,
man.
I'm not having any of that like we did last week.
Well, it's technically it's Saturday in like 15 minutes.
Yeah,
so
no, I don't know. I'll check the.
It's only 4:00 in the afternoon. What are you people talking about?
well, we're in the
Hey,
future,
do we not
Rob.
keep you entertained?
I tell you guys as much as I can. I love being here.
There's no better place for globe proofs, right?
There's-
If you're going to
there's
find a
no
globe
better
proof,
place.
right, this is the only place you'll ever see them.
It's like
Yeah,
Einstein.
because
but
if
down
you
the
saw them
pub.
anywhere, else, you'd have your Bitcoin.
We've been looking for them. We've been on the search. That's what we've been doing. And initially it was hard work, right? Because they didn't seem to get logic or anything. But what we had to do was we had to wait for the new evolution of radical globe provers.
And here they are.
And here they are, yeah. Like Max Planck says, right? New sciences are born of people just getting old and dying. And these new things coming, these guys, they don't even need a shadow giant. They don't even know what a shadow giant is.
I wonder
what
what these guys would have been like in 2015.
Their main weapon is ignorance.
Yeah. And what's the other? Confidence. That's the other one.
Yeah, confidence. Get involved with the confidence. Yeah.
Yeah, but the ignorance, like I was kind of half joking him playing on other people's ignorance, but it was really his ignorance.
Yeah,
because I mean,
ignorance outweighs the confidence.
yeah, like they did the old school theodolite over 30 miles or 30.
Got a lot of confidence.
Yeah,
3 mile long spirit levels.
It was about 8,000 miles his spirit level.
His globe.
Yeah, it's a bit like Einstein going down the village pub and saying, "Yeah, I have these ideas. Would you like to hear them?" Yeah, get around here, mate. Yeah, mine's a pint, right? Yeah, what are you writing? You what? You what?
Fourth
The light
dimension.
was bending.
Fuck off.
Yeah, where'd you
Oh,
get
I'm
that
teasing
fourth
on him.
one from?
A five-sided square.
Can you get me a pickled egg, please? Decent Annie and Chris, mate. Right, we've seen that. Let's get on the shots then, Einstein. Sambuca. I'll have a Jaeger. Yeah. Now, sit down. What was his name? Lorenz? Who's he? See the postman?
How much is 4 points at
Yeah,
pound
yeah.
each?
Can you do pardon?
Go on, Einstein.
You'd have him do the scores, mate. We're going to play darts.
Yeah.
Einstein, get
Have
on
a game of darts. 301 or 501.
You do the numbers.
Let's
Did
go
you bring your arrows?
14,365.
Yeah.
Did you bring your arrows, Einstein?
And none of that four-dimensional shit, mate.
Yeah. 180.
No. Can't be 180. That's 3 darts. At 180, isn't it?
3 darts. Yeah. 181.5436.
Yeah, it was very close to the wire.
Can you sing, Einstein? Can you sing us a song? Do you
Sorry
know any
about
Irish
this. You
ones?
just wait, people. We should be building this up. As
Well,
you've
it's
seen, we have seen globe proof. Was this one the ultimate globe proof 2.0?
Ultimate.
Now they've gone for a slight little conference, a little update, and now the ultimate globe proof 3.0 is about to be presented. Now, this is from a trio, a group, maybe 4. They may have a new member. Of a radical new group of globe provers. A new breed.
So any of you people out there that live on a dogmatic globe, this is your time.
Yeah.
You don't have to do any more. It's here.
Just take what these guys say and you can go forward happily with globe proofs. Just tell the flat earther, right? Well, first off, step 1, as Jeremy said, make the flat earther look stupid by pointing out that there's mountains and valleys. Put them in a state of shock, right? Because they're they feel a bit silly. And then you'll be able to present them this, I don't know, angle, or I don't know what this new one's going to be. And then that'll be it. Game over. You'll be able to just get on with your life. Imagine what all of these people here are going to be doing after, what they're going to do once they work out. There's not really anything to argue about or anything.
If there's anyone in the audience, and you've been taking notes, be quick, slip over to Dave Weiss and pick up those bitcoins before they're
nobody else will bother about that. We'll have to. We will get in touch with him. I mean, of course, Dave Weiss will have to know about these new globe proofs.
Yeah, no globers want to no other glober is going to want to have someone else's work and represent that. They're going to find their own, aren't they? No one can actually copy another, although they do live on the same dogmatic globe. They've got their own proof.
There is definitely evolution. Because we had a few years ago we had guy proofless logician, so he had logic but no proofs. But they have proofs but no logic. So I would say that this is definitely some kind of evolution. Okay, people, I am off to bed. Good night. Thank you very much.
We need modus nolens.
You're gonna miss the best part, paper.
You think they will return tonight?
Yeah, this
No.
is the new
Yeah,
one.
they're just talking. Yeah, yeah.
Hey,
Oh, they're
I'm,
coming back.
I'm
definitely.
staying up. I'm staying
They're
up.
just
for
going
this
to the
one.
back room just to
Yeah.
make sure they got everything, all minding their P's and Q's.
Yeah, get your whatever in. It's this is the weekend.
Yeah.
It's Friday night.
Okay.
Let
Okay,
your
so
head
I'm
down.
joking aside.
I
I actually
stay.
do think they're being serious.
Yeah.
So,
This is a globe proof, right? I
Hmm.
mean, they think they might be having a bit of a laugh or whatever, but I mean, this is it. There is no other. This is, like they say, the ultimate. There's nothing else out there, and we've been looking.
They're sick of it, aren't they?
Yeah.
Imagine that, not having a proof for so long, and then you got one.
Yeah. I mean, like, we've got proof, right? Got a proof that the Earth's not flat. That's one for one. Doesn't take much. Dead easy to find these proofs. This is the globe proof. We've always said that you can't. And even flat earthers, fighting flat earther people have told them that you can't have a proof. But these guys, they're a radical group of globe provers. They're flying in the face of the dogma. Apart from the fact that they say you can't prove it because, well, you can't prove a fallacy.
Science doesn't prove anything.
Yeah. Well, that's what they use as the
According
excuse.
to,
But the real thing is that you can prove stuff. That you just can't prove the globe. Right? There can be no proof of the globe because, unfortunately, it's just something you imagine in your mind. They'll be good, though. They'll be right.
Imaginings.
Yeah.
Imaginometry. Shining.
Modus Polens. Nathan Oakley thought we were joking, right? When took a Modus Polens over to him. It's globe. It is globe. When you want to say, like, that's globe. This is what you should be thinking of. Call it. It's like sophistry's quite challenging to spot. You have to understand how logic's formed and all of that in order to spot it. Well, this is... I was trying to combine, like the way you combine words. And I was trying to think of a word for shit sophistry, right? Somebody who's really bad at it. But bad in the way that they don't even know the logic, right? In order to be a sophist, you should really know the logic to know how to get around it. But, like, this is a form of sophistry where they don't even know the logic. It's like free form.
Yeah.
Don't know.
On the fly.
Yes, like improvisation.
Reaction.
Like improvisation without rules.
Yeah, with no logic.
It's just noise. Not
Yeah.
logic.
Like knowledge, but no logic, sort of.
Sounds like knowledge, but it's just ideology. Propaganda.
Sophish shits.
These guys seem really happy as well, wouldn't they, about it? I mean, the other two that didn't say a lot, they're
I was
going
thinking
along with it.
shitophistry.
Ooh. That's good.
Yeah, that's good description. Yes.
Yeah, I'd go with that.
It is sophistry.
Shitophistry.
Yeah, shitophistry.
Yeah.
A shitophist. The shit offists of the globe.
They're taking their time, aren't they?
Well, it'll be tough, right, in order to get themselves together. And they'd also have to review how well they did in the earlier performance, right? And how to go about presenting this one. I mean, they might think about doing it another day, but that won't be tomorrow because, like we say, it's UFC night. And yes, we ain't putting up with that shit officery.
I think they must have spent 15 hours here, more. I mean, 15 hours in the evening, but they've been here in the daytime, refining it and picking things out. So I don't know how many hours actually they've been spending on this and then presenting it over in the other forums for hours and hours and hours, and still come here and have to keep swapping things around and adding bits and changing it.
Yeah, and Peter's trying to stay calm about it. Whilst, can you imagine being the guy that brings the proof and then being knocked so many times and all your mates looking at you going, should have done better. Should have done better.
He should have just gone to Epstein Island. He'd have got a pass.
It's all your fault, Peter. We had the perfect
Yeah.
thing. You didn't present it correctly. It's all down to you. You were the rhetoric guy.
Oh, that's what he said earlier, wasn't it? It's like Blue Marble didn't understand because
Blue been in the chat?
I didn't understand Blue Marble, and it's his downfall that that he's just not very good at explaining things. I think that kind of
level is horizontal. Like there can only be a couple. I don't think that was recorded. That was before we went live when he was saying that.
Yeah.
Has Blue or Charles or Rumpus been in the chat? Have they been to support them and shout up, shout
No, they
shout
won't
from
want
the
to.
sidelines?
They won't want to acknowledge that they've heard anything about it. They'll be like, Bev, who? Oh, he does a live thing, did he? Oh.
Especially, like Rums's shit diagrams he used to do. I'm like, this guy's better at doing that, isn't he? He's a lot better than Rumpus on the diagrams.
Peter might be doing one of his live shows on Twitter soon. Because he does that, doesn't he? He does like a few hours over here, and then he goes to Twitter over weekend.
Can't say I've been watching, mate.
Yeah, Peter's a Twitter guy.
Quite big, isn't he? On Twitter?
No.
Oh, sorry, X, is it? Or what it was called?
Yeah, no. He's not really. But he's trying,
All right, we're back.
He's hanging around with the right people.
We're ready. We decided to present. So, just waiting for the others to get back, and then.
Who's are you like team presenting, but somebody's going to take the screen?
Peter will be in control, won't he?
I think so.
He's not going to let one of these guys take over his proof, isn't it? These guys are just tagging along.
No, this isn't. This is Huey's.
Oh, is that?
Yeah.
Yeah, there's words, there's numbers, and then Peter's going to sing, I think, and tap dance.
Oh, this is what you was on about the other day.
Yeah, he's got the words. Got manufactored with the numbers. And Peter's just, I think he's going to sing
slides.
Yeah.
Peter's the visual aid, Manufactotum's the explainer aid, and I'm the word aid.
Okay. Right.
Did you bring a band-aid?
Turquoise Dragon's a new member of the crew.
Yeah.
The triangle.
I'm unallocated. Yeah. Unallocated member.
Good for you. I think.
He's a
All right,
hearing aid.
Peter, you going to stream or?
Yeah, I'm doing this YouTube thing. Can you guys see?
Oh, the activity. Okay, the channel's activity thing. I see it.
See?
Does that work for
Francis
everybody?
already knows about it.
Yeah, I'm the presenter. So there's kind of a rule where we're gonna kind of
So
present,
you are part of this
and
group.
we'd like just attention and no comments till the end, if that's okay.
What's this authorized thing?
If
How
you got
long
any
is it?
problems,
5
write it down.
Or 4 minutes 27.
Oh,
Not
what's
the
this
longest video
external
you'll ever
application wants
experience,
to
don't worry
access your
about it.
Discord account? What's that about?
Yeah,
It disrupts the magic in the spell if you don't let them keep saying the spell. You have
What's
to
this?
don't cut in.
Can you give us the YouTube link so we don't have to? I don't really want to authorize through Discord. Is that?
I will change this.
Can you not
it,
just put
you know,
it
it's
on
asking-
your YouTube and then we can watch
Yeah.
it, Peter?
I will do that
You can
instead,
present
yeah.
and then we can just go
She might
through
be
with
just
it. Because you can
trolling,
pause
so
it
I
and do
will.
all of that sort of stuff. It doesn't really work too well in Discord like that.
Okay.
I don't think he's going to be pausing it, Bev. Do you? He's going to be playing it. I think they've learned from the last time
Yeah,
that
I
4
know, but
minute.
it's better for
thing
Peter
lasts
to
2 hours.
present it like he has been presenting it, and then
Oh,
everybody can
sorry.
just get used to doing it the same
Sorry.
way.
Sorry.
That's
We
all
need
right.
to cancel that.
You
Now,
know,
whose
Turquoise,
is
you've
this
become
video?
another untrustworthy member
Whose
of the
is this
community.
video?
Okay, I'm going to play it.
Peter,
Hold on.
whose is this video?
It's mine.
This is the ultimate proof of Globe version 3.0 by the Holy Trinity of
Okay,
Globe.
now, as you well know, we are live streaming right now.
That's fantastic.
Right? Is there anything on this video that might, perchance, get copyright struck or
Well,
anything?
that's a good question because there is
copyright.
background music.
Right. Well, that can't be on here.
Play it on mute.
No, we can't.
No, it must,
sensitive.
it must be played fully with audio and everything. So we gotta terminate the stream, I guess.
Wait, hold on.
Yep.
Yui,
Yeah.
what if as it plays, how about you just read
If
the
there's
text?
music in
we
the
keep-
background, it doesn't
No,
really
no,
matter. It
no.
will still pick it up.
The production is too good.
Oh,
The
with it
production is too good the way it is. To
Yeah, it is pretty.
It is.
So
That would be a
Can we
shame.
just have it like
Yeah.
exclusive to Discord for this showing?
Yeah,
You need
exactly.
the full experience. Bev.
Can you maybe just do me a favor and give a link to this video in the live chat?
We want you to watch it with us together.
I understand.
Don't
And
post
so
my
immediately
YouTube
after the
link
video
until I've edited
plays,
the
we will
video
give
because
you
I
the
think
link.
there's a bit at the end where I just want to cut it out, just in case there's any private stuff there. But yeah.
Well, I tell you what, you guys watch it, and I'll stick out of this for a bit, and we'll just discuss it afterwards, right? How about that?
Yeah, I'm sure. Yeah, I'm sure the others will be able to pick it up.
Okay, just to confirm. So I'm going to play the video right now. Everybody's going to watch it. Withhold any questions or comments until the end, and then I will share the link to the YouTube. Is that what we agreed to?
You can, and then everybody
He said
else
he
can
didn't
watch
want
it.
to
Yeah,
play
I
it.
won't. I will keep out of it, whilst you guys are doing what you're doing, right, for the thing. Or perhaps I could put the sound. Oh no, I can't put the sound through. No, I'll just stick it at the side. You guys watch it, and
But
maybe
how
I'll
are you-
I'll put a Buster song on. How long it's for?
It's 4 minutes.
4 minutes.
4
okay,
minutes
okay.
27.
You guys can listen to a Buster song, and you guys can go and watch Peter's thing, please.
Well, Bev,
Go
is it
ahead.
possible for you to show the video and mute the sound on the out end?
No.
Okay, never mind.
You guys
Well,
do it. We'll talk about it, and I'll watch the video at a later date, right? Don't worry about it. Go on, please. Off you go, and we'll talk about it.
Wait, I'd like your all attention and mute if possible, and You know, get the timestamp of any questions you have, and it'll make it easy to relate back to it.
Okay, here we go. But if Bev's not listening, what's the point?
Well, the others can pick up on it, right? We may as well play
Okay,
it.
let's do it. Let's do it. I'm
So
gonna play
Euclid
it.
is a fantasy model. Bev is model afflicted.
Well, it's wrong.
Wait, Euclid is a fantasy. Have you read the book? It's called Euclid Elements. That's really good. You should give it a look.
Well,
look
it's
over.
wrong.
Yeah, well, probably one of the most perfect books ever wrote.
Well, it's
Mathematical
wrong
as well.
Well, it's wrong.
What Euclid's
Isn't it?
Euclid's elements are wrong.
No, it's wrong, isn't it?
I don't know. You say it's wrong. Like you've
Well,
just
on
said
a
it
surface-
three or four times there. But how
Yeah.
is it wrong? You're just saying that Euclid's elements is wrong. Euclidean geometry is wrong. Brenda.
Right.
This is getting old, Brenda. I mean, come on. You've got to do better than that. How you're not going to sell many globes talking like that.
It's wrong.
Yep.
It's wrong because in the presence of gravity, space is non-Euclidean.
Hyperbolic geometry is not the same, right, as reality.
Okay, well, that's good.
However,
You did say it was in reality, though. So where would you find that?
It's a better description of reality than
Well,
Euclid.
it's wrong.
It's better.
What?
Do you have like the book on hyperbolic geometry with the author's name and all the definitions and axioms and all, or do you just
Should
add
be-
it on as book 16 to Euclid? Like, what's going on?
Well, it's wrong.
So general relativity. So Euclid is a fantasy model. So Euclid is a fantasy. Bev is model afflicted.
Wait, Euclid is a fantasy. Have you read the book? It's called Euclid Elements. That's really good. You should give it a look over.
Well, it's wrong.
So Euclid is a fantasy model.
That's child abuse.
Please don't be model afflicted like Brenda.
That's child abuse.
Bev,
That's child abuse.
you are model afflicted.
Euclid is fantasy,
That's child abuse.
but space-time geometry is real. Wow, Brenda, you outdid yourself.
I have in my imagination lab, try to focus. If I use Euclidean geometry
That's child
to
abuse.
describe reality, I have in my imagination lab, which is real.
It's inherent in nature.
Well, it's wrong.
It's not my problem if you don't want to learn. You just don't.
I don't understand the doublespeak. I don't understand the contradictions.
I'm not sure that I would call myself a diletheist. I don't understand diletheism, because that's what logic is.
Yeah, absolutely foundational, right?
And there are different logics with different axioms. Well, it's limited by imagination, so I can just bend it in my imagination. I'm not sure that I would call myself a diletheist. I don't understand diletheism. Well, it's limited by imagination, so I can just bend it in my imagination.
Can you explain to us why they disagree?
That's child abuse. That's child
Because
abuse.
it turns out I can just bend it in my imagination. Space-time is non-Euclidean.
Well, it's wrong.
Euclidean.
Yeah.
One of Kant's well known mistakes.
It's not my problem that you don't want to learn. You just on your own.
Well, if the current,
so
if the plane is saddle shaped, so I can just bend it in my imagination. If the plane is if you bend it, make it saddle shaped, then
it's not a plane then, Brenda.
You think things are doublespeak, but that's because you don't understand. Well, if the plane is curved, so I can just bend it in my imagination. If the plane is saddle shaped, if the plane is if you bend it, make it saddle shaped, then
it's not a plane then, Brenda.
This
is getting old, Brenda. I mean, come on, you've got to do better than that. You're not going to sell many globes talking like that.
So I can just bend it in my imagination. It's obvious to
Up
everybody.
your game, Brenda.
No, I have.
You're meant to be an expert at this. Aren't you? Aren't you one of the best?
No, so I can just bend it in my imagination. Well known mistakes.
Well, it's wrong.
I just understand.
It's wrong.
It's not my problem that you you don't want to learn. You just
It's inherent in nature.
That's
a quote.
what it is. They need Euclidean geometry to do all their stolen concept shit.
no reason, no logic, no wisdom, no worry.
As a front.
You're just on your own.
But in the back, they're doing their magic globe shit.
No logic, no answers to question.
Their magic globe shit.
You're just on your own.
Yes, that's what logic is.
Yeah, absolutely foundational, right?
And there are different logics with different axioms.
Reality, yeah.
It's inherent in nature. That's a quote.
Transcendental, relating to the spiritual realm.
If you read the second one, that's interesting.
Kantian philosophy. Is that what you're after? You like a bit of Kant? Presupposed and necessary to experience a priori. I think we say that a lot. Is that a better way of?
Self-evident truth.
Yeah. Now, I can demonstrate this definition, right? I think it's self-evident. I think we all agree that the shortest distance between 2 points on the surface of a sphere is an arc, and that could be demonstrated by a thought experiment. So that is why it's an axiom. It is. They're very similar to definitions, but I would say that there's different ways you could define it, which could both be true. So it would be more true to say axiomatic, I think.
All right. So an axiom is an unprovable rule or first principle accepted as true because it is self-evident.
Yeah, it's self-evident. So I could establish that with pure logic, right?
Yes, but this is not what this axiom 1 says. It refers to our vision. So this is a posteriori. It means that from our experience, if we draw a line on a sphere, etc., we call it great circle, and it is possible shortest length between 2 points on that surface, but this is completely a posteriori. It is
I'd
not
say
an
it's a
axiom.
priori.
No, it's a mathematical. It's mathematically provable.
Yeah, I could derive that with pure logic. It's a priori.
No.
It is a mathematical theorem that it's proved in mathematics that 2 points on the surface of a sphere, when connected, form an arc.
Math is reality.
In reality, yes, in reality.
You just said in mathematics, though.
Well, in reality, we have objects that approximate spheres. So this is approximately true in reality, yes.
Yeah, still it is not an axiom because self-evident truth refers to our reasoning only.
Yeah, I'll reason it for you.
And by and here we have just definition what great circle is.
Let you reason that for us.
Let's reason it. Let's suppose, right? So we've already started in a alternative reality. Let's suppose that you are standing upon a sphere, right? And there, whatever causes anything else is accounted for through other physical mechanisms, whatever. You're standing on a sphere, and I ask you to walk in a direction, a straight path. Would that follow an arc? Yes or no? That would be you need only a priori reasoning to establish that the truth of that fact that it is true that you'd follow an arc, right?
Well, if I said to you though, in reality,
appeal to a posteriori knowledge. Then.
If you're in reality and I sent you in a direction, one direction, yeah, I'm not going to say which direction, but that way, yeah. Do you think that on a straight line? Do you think you're going to come back to the same place? Do you think you're going to come back to the same place?
On a sphere, yes.
If I said for you,
no, in a sphere. I mean, in reality, like you stood there, and I say walk. Hold on. I say walk that way, and you go, yeah, okay. You keep walking.
We're doing pure logic to establish the axiom, so let's not go into reality just yet, right?
No,
okay.
So if I asked you to walk in a straight line along along a sphere, along the surface of a sphere, you would say, I can't do that, right? You can't reason walking in a straight line along a surface of a sphere, but you can logic going in an arc.
No, but this is sorry, but you are talking about inferring from experience or whatever. It is still a posteriori.
No, it's
and
pure
yes,
based on what a sphere is. All I need
no,
to know.
yes, yes. That's why it is not an axiom, because first, before understanding what a great circle is, you have to have knowledge about sphere.
Yeah, you
And
can
this is
arrive at
know
that
how
by
axioms
knowing the
work.
properties of a sphere.
Yes, so it is antecedent for axiom is a sphere, and it is
Do you
wrong.
think shapes are a posteriori?
No, I think that you cannot create axioms based on something else. They are straightforward. They are linked to first principles of reasoning. So that's why it is, because otherwise you need to prove something first.
You'd have to establish where the synthetic is in that axiom. Where is it?
No, I have to establish it is self-evident truth. It means that you cannot make any assumptions beforehand.
Just establish where the synthetic is in that axiom. Because if you can't, it's a priori, right?
Or what assumptions are being made?
And to be honest with you, these are practical axioms. They're not
assumption
hardcore
is
logical
that
axioms.
that
Don't
we
forget, we've got the diletheism. We've talked with Brenda. They think an axiom is an assumption that they make at the beginning.
Yes, yeah. This is not assumption.
No. There are hardcore logical axioms, right? The first one is a bit more close to that. The second one is more of a practical axiom, right?
No,
But
there's
for
no
the
such
purpose
thing
of
as
the first
practical
Called
axiom.
law of identity, the law of the excluded middle, and the law of non-contradiction.
For the purpose of the first one,
They're the axioms of logic.
For the purpose of the first one, that is much more close to a priori. The second one is a posteriori, right? So I'll agree with you on the second one. The first one is a priori completely.
But it is not an axiom. Therefore, it is not an axiom.
All right, I'll call it a practical axiom next time. I'll amend
Okay,
that. It's fine. No, doesn't really matter, because this is just setting up the assumptions we made to structure the argument.
That's my point. It is not axioms.
What we take to be self-evident, right?
Okay, you take, but this is subjective. Logic is subjective. You cannot say that this is axiom because I objectively think, subjectively think that this is an axiom.
What's your subjective take on axiom one?
It's not my subjective.
I thought we already determined it's not an axiom.
Yeah, it's a definition.
What seems to still be in contention, if I understood correctly, you think it's not an axiom because it requires assumptions to get there. But I'm curious what those assumptions are.
Well, your second one definitely has a vacuous statement in it.
Sure, but the first one.
No, we'll focus on we'll get step by step. All right, axiom one. It's apparently a posteriori. It has prior assumptions, right? And it's synthetic. That's what's being levied against the first one. I want to hear why.
No, it is. First sentence is a great circle, and idea of great circle is based on something else. So you need radius for that and circumference. So that's
must we?
Well, the synthetic is the spherical geometry. I'm just saying that as a starter.
I think if it's the case that there are things that we need to know about a sphere beforehand, then that's as good as saying maybe perhaps more axioms were needed in this argument. But for simplicity's sake, I think it's better to keep it shorter and we don't need to establish what a sphere is a priori.
Okay,
just do that.
That's
already we already knew that, and then start with the relevant axiom.
The sphere was already defined in Euclidean geometry. Are you talking about
Yes.
non-Euclidean geometry when you say
No.
spherical geometry axiom?
No, we're talking, first we're saying there are spheres. That's implied. Does
Yeah,
everybody
duh.
agree that spheres exist?
That's not what I'm
Yeah.
saying. Are
Let's
you
walk
implying
with me
when
through
you
it.
say sphere? Hang on. When you say spherical geometry axiom, are you implying that it's the non-Euclidean spherical geometry, or are you talking about the spherical part, like the book 11? Is that right?
What
Book
we're
11?
saying
Yeah.
is this. Spheres exist, and on spheres, when you connect 2 points, the shortest distance between them on the surface is an
Length.
arc of a
That's
great
great,
circle.
but you're not answering my question.
Because that's not relevant.
It is
This is-
relevant because you say spherical geometry. Are you talking about the non-Euclidean spherical geometry,
No,
or are you
you're just
talking about
picking one
Euclidean
aspect
geometry?
of it out of it, and this is the aspect.
So you're taking out of book 11 from Euclidean geometry when you say spherical geometry. I'm asking. I'm confused.
Let's call it axiom 1, Peter's axiom. Just pretend you're reading that it says Peter's axiom. and
Just
then read the text.
pretend. Always one of the
Oh.
best ways of globe proof.
Yeah.
Always.
Hey,
I'm
hey,
seeing
no,
approximated
this-
in here as well.
Well,
a
the,
bit-
well,
a
yeah,
bit.
hang on. He said, hang on. We're going over the first
I
one. He
will
wants to know what the
clarify.
synthetic is, and I'm trying to
Let's take
point
a
out
note
that you left
that
something open to
we need to rename
interpretation,
axiom 1 to
and now
say
he's trying to change the subject, so it's okay.
nature of spheres axiom. The nature of spheres.
Yes, but the nature of sphere is described in Euclid, and by the way, it is so sphere is part of Euclidean geometry, and in Euclid,
just before we continue,
hang on, and part of Euclidean geometry, first thing is straight line.
If I
So,
may, just ask someone, maybe Buster or Paper, one of you to transcribe your critiques so we can, if we agree with them, improve them, right? But I'm going to be, obviously for the sake of this, I'm going to be defending the argument. But if I do agree after, might adapt the argument to take a
It was just a it was just a question of clarification for me. When you say spherical geometry, are you saying non-Euclidean spherical geometry?
No, we're
No.
not.
But spherical geometry is non-Euclidean.
Yes. No, no. The geometry of spheres is not non-Euclidean.
It's not non-Euclidean.
So it is Euclidean. Double negation.
Yeah, they're not.
Creates affirmation. Yeah.
Yeah. Double
The
negative.
geometry of hyperbolic surfaces is non-Euclidean. The geometry of a sphere is Euclidean.
But when you say, like, do you understand, like,
I
when you
understand-
put
I answered
something
your
on
question.
that,
Why are you
when you
repeating
write
your
it down and it says spherical geometry, the people in this server, we've looked at it. We
That's why
are
we need to
assuming you're
rename it.
implying the non-Euclidean. It's called spherical geometry.
No, because you people in the server confuse geometries. So we should rename
We're
this
not confused
to
at
remove
all.
the word
Period.
spherical geometry.
No, we're not confused about the differences, but you have put spherical
You wouldn't
geometry.
be asking this question if you were not confused.
I'm confused with what you're implying, but if you're implying that it's Euclidean, then you should change the way it's worded.
The outcome of this proof isn't meant for people like us.
Did you read
We're
the text
refining
of
it for people who are
Buster,
ignorant
did you
of
read it?
this. This will just sound like it's a good thing.
Buster, what is controversial in the text for Axiom 1?
When they're
Not the
finished with
title,
it.
but the text. What is controversial?
What's controversial is when you're saying, you know what? I want you. Well, I guess you've already answered. If you're talking about Euclidean geometry, when you say spherical or sphere, if you're implying Euclidean, then you just need to change that wording because non-Euclidean spherical geometry is called spherical geometry, and I think that's a confusing point.
Okay,
and it will
fair
be
enough,
for most because
fair
it
enough.
implies a lot of things that you should learn about.
Fair enough. Do you agree that on the surface of a three-dimensional sphere, the shortest possible distance between 2 points is along the arc of a great circle?
Now, the
Well, I'm with
shortest
Bev, like
possible distance would
this
be
is straight line.
the straight line.
Do you agree, I repeat, do you agree that it's self-evident that on the surface of a sphere, the shortest possible distance between 2 points is along the arc of a great circle?
No, it is wrong. It is wrong. Shortest
What
length.
is it? What would Euclid say?
Euclid wouldn't say anything about that because Euclid didn't measure distances on the surface of the sphere.
Yeah, he just wrote the geometry.
Yeah.
Right.
Was he aware of arcs?
He uses the
Just
straight
Yes.
line.
just to be clear, right? So far we've got two assumptions instead of axioms, if that is preferable language. One, spherical geometry is a loaded term, and the last one is that we just can't seem to lock horns over the idea that if you were standing on a sphere, let's say thousands of kilometers across, and I told you to walk in a straight line along the surface of a sphere, you would say, I don't know how to make sense of those words.
Well, if you handed me a sphere and I was to walk on it, it'd be pretty. I could balance on it, but I couldn't walk.
How about draw a line?
Yes, but imagine shortest distance between 2 points, and these 2 points are extremities of this distance.
I will read it for you, Mr. Paper. One more
No,
time.
hang on. Just
I understand.
I think it's useful to read it out. One last time, okay? Do me this favor.
We've read it.
On
I've read it 4 or 5 times.
the surface
Yeah.
of a sphere.
Okay, hang on.
The shortest possible distance.
But
Yes.
two
So
points
I am talking. So I am
is along
talking.
the arc
Yes.
of a great
Yes.
circle.
So I am talking about shortest possible distance on the surface of the sphere.
What is it?
2 points lying all together with the closest 2 points as they can be. This is the shortest distance on the surface of the sphere, and in space, by the way, also.
But the problem here is here's my problem with it. Like you
What you
said,
just
it's
said
it's a loaded axiom because you say spherical geometry, which most people like in this room anyway would think you're implying non-Euclidean, and then you say on the surface of the sphere, the shortest distance, but actual non-Euclidean it's only 2D.
Well,
But in Euclidean geometry, it's 3D. So the shortest distance
of
is.
a sphere.
Yeah, I think you're just getting hung up on the title of the axiom.
Yeah. Can we rename it?
It's a loaded. Yui said it's a loaded thing, and like
let me ask you a question.
It is.
If it's loaded,
I've noted it. I will change it to something a little less loaded.
If we say geometry of a sphere, would this be less loaded? Geometry of a sphere axiom.
Or assumption. I don't really care if they
would this not be loaded? Would this trigger you less?
Rather definition. Yes.
Geometry of a sphere axiom, or whatever you guys want to say. Yes,
That's Euclidean.
Okay. Note taken. Geometry of a sphere is the appropriate title.
But as for
the geometry of the sphere is Euclidean.
Yeah. As for the assumption in the axiom, I was going to call it an axiom for the sake of argument.
In first axiom,
would you agree that on the surface of a sphere, the shortest possible distance between 2 points is along the arc of a great circle? If you were standing on a sphere, someone said, go in that direction, do you think you would be along the surface? Do you think you'd be going in a straight line on a sphere or along an arc? Yes, which one? Arc, right. We agree. Axiom 2.
No, it is not. As I said, 2 points. Because we are talking about 2 points, the shortest distance between 2 points. These 2 points lying all together, they are creating the shortest distance, and it is straight line.
Well, you only have the points because of diameter in the first place.
I think the issue here is that there's obviously a key insertion which is implied in the axiom that you're not doing anything. All you have to deal with right now, all you have to think about, is the surface. Nothing else.
Well,
I
don't think that's the problem. So if you say 2 points that are very, very close together.
Yes, 2 points creating a line. Line containing only these 2 points.
Okay. And you're saying that those would not lie along the arc of a great circle?
If you have 2 points, it is only straight line. You cannot have curve To curve,
And
to have a curve, it means that you have some infinite angle, but
okay,
you need three points, not two.
sure.
It's
So
for a
firstly,
triangle.
to get 2 points close enough that there's no points between them, I think is
Yeah.
conceptually impossible. But
Conceptually
even
possible, practically impossible, of course.
I
But that's
think
not
even
what he
conceptually.
said. Why are
But
you playing along with him, Manu?
well, because I knew this was going to come up and it needs to be addressed. Even giving that to you, to draw a line across the surface between these 2 points that are touching would not deviate from the arc of a great circle. The arc of a great circle would be perceptibly, even conceptually, straight, but it doesn't break that definition.
It does, because this would be straight line, and
Yeah.
great circle is not straight line.
But the arc of a great circle between those 2 points, depending on how big your sphere is, would be straight. I mean, it just doesn't deviate from curvature by any perceptible amount. That's all that is.
Yes, but still, if these 2 points are creating straight line, it means that prolonging this straight line will not give you a great circle.
It would if you prolong it along the surface.
Yes, this is a backward definition. So first you have great circle and then shortest distance. So you cannot describe shortest distance because it is still a posteriori. So first,
No, what I'm saying is, I think I understand what you're saying, but what I'm saying is, if you draw a great circle across those 2 points, the distance between them will still lie on that arc of the great circle. You've just taken a straight section of that circle.
Yes, because it is in definition or in this axiom, the shortest possible distance between 2 points.
Yeah, and it would still lie on the arc of a great circle.
It will, but it will be not. It will be not an arc.
Okay,
These 2
that's
points.
fine. If we agree that it still lies on the arc of a great circle, that's enough for me.
Okay, so our statement was this. Given any 2 points on the surface, for example, the blue point and the orange point on the screen, the shortest distance in general is a straight line, a chord line between blue and orange, and the shortest distance on the surface is an arc of a great circle, shown here in red.
Bev, I'm going to send you the PDF version of this argument if you want.
That's why I disagree with this distance, because we have a contradiction. Because if you say that shortest distance can be at the same time curved line and straight line, it is contradiction.
I don't
know. These are 2 different statements.
Yes, it is. Because if you say that the shortest possible length of the line is great circle on the surface of the sphere, I agree. Because the shorter, which is not on the surface, is straight line.
So you want us to use the English language in a certain way. That's your problem, yes?
Because distance is shortest distance. It is very clear.
Okay, listen to the words coming out of my mouth now if you're serious. The shortest distance between 2 points in space that happen to be on the surface of a sphere is a straight line, in this case, the chord line M of length 9.99.
Yes, it is straight line, and it is the shortest distance between 2 points. And now
Now listen to that. Listen, give me 1 second because I don't want to mislead you. Give me 1 second, please, in silence. Now, the shortest distance between those 2 points, not in space, but on the surface of the sphere, is an arc of a great circle.
No, it is wrong. And by the way, there are 2 wrongs in that sentence.
Okay, Let me
said
repeat.
that not in space.
I already know. The length. Okay. The 2 points on the surface, the 2 points on the surface of a sphere, when connected in space, are connected by a segment of a line, and that's the shortest distance between those 2 points. When we connect those 2 points on the surface of a sphere, that will form an arc of a great circle, and that will be the shortest length by which we can connect them on the surface of a sphere.
Yes, I agree. Yeah.
Okay, that's what we're saying in the axiom.
No, this is not.
That's literally what we're saying in the axiom.
Okay, but
we're saying when you take
different
2 points on a surface of a sphere and you connect them on the surface of the sphere, it will be an arc of a great circle, and that will be the shortest length of any connection that you can create while
I
staying
agree.
on the surface of this. Thank you very much. This is middle school geometry. Can we
All
now
right.
move on?
What's the next problem, do you guys think? That you have?
I have to see that on the screen.
With the whole argument? Oh, the second axiom. Axiom 2. In practical scales and considerations, typical human activities and measurements, the Earth's curvature can be approximated as a sphere, and spherical geometry approaches Euclidean geometry, becoming indistinguishable from Euclidean geometry at smaller scales.
It seems like you've separated spherical geometry and Euclidean geometry, whereas you said earlier you didn't.
In this axiom, we are, not in the previous one.
But axioms cannot contradict
They
themselves,
don't. They don't.
each other.
They don't.
Yeah, they do.
They don't.
Think of it as a pathway, right? Don't if you can accept axiom 1 for what it is, and then axiom 2 includes extra information where the separation begins to emerge, then you can quibble with that one, right?
Separation between what? Your
Well,
first one says spherical geometry, but you said that was Euclidean. And now you're saying that there's a separation between that and Euclidean, but it is Euclidean to start off with. I mean,
he's saying,
how confused do you want to be?
He's saying, in practical scales and considerations, the Earth's curvature can be approximated as a sphere, and spherical geometry of that sphere, again, in practical scales and considerations of reality, approaches Euclidean geometry.
It is Euclidean, you said.
Wait, yeah, that's why I specifically asked, what are you implying when you say spherical geometry? But in axiom 2, you saying spherical geometry is Euclidean. So Euclidean geometry approaches Euclidean geometry, becomes indistinguishable. I mean, that's like about as vacuous as you can get.
It was already Euclidean to start off with.
No. We know this is a second axiom. First, Buster, we were discussing the first one, and now we're discussing the second one. The second
that's
one,
why you guys.
It's obvious.
Yes,
dude.
but you are using.
Nonsense.
But we were talking about spherical geometry in axiom 1. You agreed that spherical geometry means geometry of the sphere, so you have to replace because you have.
No, now we're talking about the geometry of the surface of a sphere.
Yeah, this is just
you said it was
wordplay and sophistry. It's
no, these are
terrible.
two different problems in geometry.
So
globe, totally globe.
So,
I think
so
manufacturing.
please explain spherical geometry in axiom 2. What it is.
So in the first one, it's called spherical geometry, but all we're laying out is how distances work on the surface of a sphere. You can relate that back to spherical geometry or not. That is irrelevant.
It
in
kind
the
of is
second
relevant.
one, it's not to the first axiom. No. Everything in that first axiom, you can perfectly express in Euclidean geometry.
So you are using it is let's say illicit axiom because you have to be consistent. So if you are using the same expression in axiom 1 and axiom 2, they have to mean the same. They have to.
What is being used in the first axiom, spherical geometry, is only the title. And
So
if that's
it doesn't
confusing,
matter. It doesn't
that's fine.
matter.
If that's confusing, that can be
It's not
changed.
Yes,
confusing.
It is
should
not
be.
confusing.
It's
Clearly
just
it
Not
is.
at all.
dishonest.
Yes, very.
Blatantly dishonest.
Well, I think dishonest would imply that when
it's just
it
that
was
we've
written,
seen it. Don't worry about it. Not many people will see it, right? When you leave this place, most people out there won't be aware of your sophistry in play here, right? Don't worry about it.
So with the title of the first one, it's like it's a question of, are you satisfied with
It would
what
be
the
a good
axiom saying?
reason
So
for people to
if the axiom
learn
saying
these principles for themselves.
if the
right?
axiom
Bev,
that would be worthwhile.
if the axiom is
Bev,
just a
you know,
second, just a
they,
second.
wait,
I want to
wait.
clarify, right? If the axiom in the first one is substantively, that means the words in the axiom itself, what it's saying, is agreeable
dishonest, dude.
in both spherical geometry
No,
and
but
Euclidean
it's just
geometry,
dishonest.
then it's irrelevant.
You've got spherical
which
geometry
direction we're
being
gonna go in
Euclidean,
next.
and then
It's
you've got spherical
non-contradictory.
geometry becoming Euclidean when it
just
already was
non-contradictory.
Euclidean to start off with. Just dishonest.
Manufactotum, sorry. It is even in court. If you are using expression with one meaning, you cannot change during the whole process.
The title of axiom 1 is not given a meaning. It's only a title.
No, it doesn't matter. So
the first mention, the first use of the word spherical geometry is in the second axiom.
So, but now you are contradicting, because you said that spherical geometry is a geometry of the sphere. So I expect that in the second axiom should be the same expression. And
Yes, it is. It is in the second axiom. The first axiom does not use the term spherical geometry. It mentions it. It's just the title. It can be changed if that's causing this confusion.
It should be. It should
Already
be.
noted. Already noted. Noted
Exactly.
a while ago.
Yeah.
The confusion will lie because people like Blue Marble Science have done videos on spherical pie.
Understandable. That's perfectly fine.
But still, it would be a problem, because if geometry of the sphere is Euclidean geometry, you would have tautology, and geometry of the sphere approaches Euclidean geometry. This is tautology, and
I understand that.
In fact, nonsense, because how the same thing can approach itself? It is nonsense.
I understand that. That's because you're still equating spherical geometry as being defined as Euclidean geometry. That was simply to further the understanding of the first axiom. Now in axiom 2, we are introducing spherical geometry, and we're saying something about it. We didn't do that until axiom 2.
Well, what's the predication on spherical geometry?
Sorry?
What are you predicating upon with spherical geometry? You're just saying you're introducing it, but there's no saying what it is or what it isn't,
Yes,
or
what
it
it
says
is.
approaches Euclidean geometry.
Approaches, it means only what it does, but you cannot
Maybe we
say
should
what it does if you don't know what it is.
Do you guys know of spherical geometry in mathematics?
I think that's the issue, is that it hasn't been defined enough to be used. Am I understanding you correctly? Okay.
Undefined and, in fact, non-existent, because...
Okay, let me ask you a question. Is it controversial for this audience that spherical geometry is a very well-developed branch of mathematics?
It is not.
It is
Can
not.
I make an
Okay.
important distinction,
We need to
please?
avoid this presentation.
Please. Can I make an important distinction with your spherical geometry?
Yeah.
It is treated as a two-dimensional surface, whereas a sphere is, in reality, a three-dimensional object. Thank you.
Absolutely. Yes, that's true. We agree.
Yeah.
If people, here's the point, Manu. If people in the audience disagree that spherical geometry is an established branch of mathematics. I don't think we can talk to them beyond this slide.
I
Well,
hope so.
there's-
I hope
think
so.
we can.
Please
there's
let that
caveats,
be
right?
true.
So first of all, I think it's useful to have a clear and concise definition for spherical geometry. It's probably going to be quite controversial in this group, I imagine. But I also think that with the second axiom, it's going to have to be able to accurately, like, because we have a key word list, right, for use if anyone wants to pick on a particular word, but we haven't done that for spherical geometry yet. So
Yeah,
I don't want to articulate what exactly I'm going to describe about it without
Okay,
thinking
yeah, fair
about
enough.
each word carefully.
Fair enough.
But,
Like, so you haven't yourself got a
the thing about the
definition for
argument
that.
is
But you're saying
it actually doesn't depend so much on axiom 2 being true. It's more of like a supporting, like I said, a practical axiom, not so much something to say about the actual argument itself.
On the practical side of it, it says that the spherical geometry approaches Euclidean. Like, that would be the first question. What does that mean? And then the second question would, well, I guess there'd be 3. I'll just go with 2. Approaches becoming indistinguishable from Euclidean geometry at smaller scales. I mean, what's the scale we're talking about
I'll
here?
explain. I can explain. It means that because of when the curvature is sufficiently large, where the radius is large, and your practical scale is small.
Radius of what?
Of a sphere. Then locally.
Any sphere.
Then locally it approaches Euclidean, meaning triangles will look to be nearly 180 degrees and so on.
Well, then you're going to have a problem with radius, because then you, like as Yui said, you haven't really clearly in your own back channel defined spherical.
Radius be a straight line?
That's what I was going to ask, Bev, was like, where's the radius in spherical geometries?
No. We're just explaining the geometry of
You're
spheres.
saying there's a scale problem, but the scale's related to the radius, and the radius
No.
is Euclidean.
Don't worry about the radius.
Yes.
What axiom 2 is. Yeah, what axiom 2 is talking about is exactly the objection that was brought up earlier, with 2 points being very close together. So that line that is actually an arc, well, not infinitely. If you put them infinitely close together, then that's 1 point.
No,
but what?
No, it is not. No.
If they're so close together,
in Euclid,
if they're so close together, if they are so close together that there can be no points between them,
definitely it's just points, series of points, a circle, a circumference.
Exactly. How do you get 2 points that are so close together that no points can be between them?
It's just a single point.
Exactly. So if they're close enough, though, that they're not yet 1 point, if they're not yet 1 point, but they're close enough, then
Euclidean.
the proportion of that
There's 1
distance
point,
to
that's
the actual
Euclidean.
still
If there's
speaking,
more than 1
Bev,
point, that's Euclidean. If there's an
Bev.
infinite points, that's also Euclidean.
Bev.
So ranging from 0, 1
Bev.
to infinity, that's
I implore
Euclidean.
you, Bev, please. If they're so close together that that line is disproportionately small to an extraordinarily large sphere, then it's going to look straight. That's all the second axiom is saying.
But there's no radius or circles
Don't
in
need a
spherical
radius.
geometry.
That is all it's
And geometry, by the way, is not about what looks like. It is not geometrical term.
Okay.
Looking like straight line.
We have 2 problems here.
Your
The first-
ignorance and
the first
your
problem is this.
misunderstanding of basic logic.
Yes. The first problem is this.
It was a valiant attempt, though, boys. I will give you that.
Can I speak for 1 second?
Yeah, no Bitcoin for you, though.
Yeah.
Yeah,
Let's
message
imagine
from
I was-
asking from the chat, don't nut sack yourself. Be
Okay.
careful.
Let's imagine that I was trying to make an axiom related to the Pythagorean theorem. And the resistance that I got was from the audience
That's
that they
Euclidean,
don't
though.
believe triangles exist. Well, there's no point proceeding, right? If someone says triangles don't exist, how can I talk about Pythagorean theorem in my argument? I cannot. This is a similar situation here, where people are half refusing to admit that spherical geometry is a branch of geometry.
Yeah, but you're trying to falsify the Pythagorean theorem, aren't you?
Yeah, that's right. Now, what Manu was trying to say
So
was...
you are trying to falsify triangles.
Absolutely, yes. So what Manu was trying to say
you
was
are
that,
the person that says
yeah,
that
I am that
triangles
person.
don't exist.
What Manu
You
was
are
trying to
that
say was
person that
this.
you're talking about.
What Manu was saying...
Brilliantly. That's
what Manu
globe
was
for
saying,
you there, right? Globe
I'm
proof right
visualizing
for
for
you.
the audience what Manu was trying to say. If we have a sphere, no matter the radius, we don't care what it is, some radius r.
Straight.
And we
Euclidean.
are at large scale. Then we have a spherical triangle whose angles add up to 198, significantly over 180. But if we make the triangle very small in relation to the sphere, look what happens. It starts approaching 180. You see how now it's only 0.19 degrees above 180? That's because this little dudin is so small.
Triangles have a
So local.
proven
I'm not saying
180
this for you,
degrees,
bad
though, don't they, Peter?
Shut up.
There's a misunderstanding of what a
It's so
triangle
small.
is.
See how small it is?
There is a proof that triangles have 180 degrees.
Yeah,
though,
I
Peter.
know. I'm saying this for your audience, okay? It approximates 180 because locally on this sphere, when we make it sufficiently small, it is almost Euclidean, even though it's on a sphere. Now, if we blow out this triangle in relation to the radius, it starts diverging. It starts moving away from Euclidean. That's what we mean by scale.
If you move it away
But there's
from
no
the
straight
radius.
lines on a sphere.
Arcs. These are always arcs, but at small
Triangles
scale,
are the
they
inclination of
almost,
3 straight lines.
they're arcs. So at small scale, they become almost straight lines because the curvature is so tiny. It's so tiny that they are almost straight lines. The closer we get,
Ever
that
heard
sucker.
somebody so obsessed with balls?
Do you see it?
They can't see triangles in
Does
reality.
the audience see it? I think the audience sees it.
Spit out my drink.
Okay.
Can you see a triangle
Anu,
not on a ball,
Anu,
Peter?
is that what you meant?
Were you asking me?
Yeah. When you were
Essentially,
trying.
yes.
Yeah.
I would add, in fact, that what we're doing is setting up, obviously, this is going to relate back to the Earth. So there may have been some assumption of charitability here that was perhaps unwarranted. But the language used was to that end. We were kind of building up to use of these geometries as they pertain to reality.
Yeah, can you guys imagine a triangle not on a ball? Just like 3 points?
Yeah.
That's a triangle, right?
Absolutely.
A normal triangle.
Yeah.
Jolly good.
Any other objections to these axioms besides the ones noted and taken?
I think we can move on to the next slide.
Can we object the fact that you're calling them axioms? I think we did that as
Yes.
well, didn't we?
I think we already did, yes.
Yeah, that was already taken. Premises.
Questions, comments, concerns, quandaries, considerations, conundrums, contemplations. I'm out of
What's
C-word
nearly?
synonyms.
How about denials?
What's nearly spherical?
Yeah, can you change that for sort of? I prefer sort of.
I prefer nearly.
these premises, because premise is it is statement in syllogism. So it is assumption. I would say that these are assumptions, not premises, because premises is a sentence in syllogism. And if you are not, we cannot see here a syllogism, so they are not premises.
Well, the first one isn't a statement to start off with. You can't have nearly. That's not a statement, right? You're not applying the laws of the excluded middle. Nearly. That's not.
Yeah.
What are you
we're talking about reality
here? Yeah, what are you trying to avoid?
Just talking about the fundamental laws of logic,
No, we're
right?
being truthful. Our statement is that
Okay, just a second. I need to clarify something. These are obviously not part of a syllogism yet, right? They are setting up what P, Q, R, and S will mean in the syllogism. They will become premises, right?
Well, it's not. Like I say, like it's not a statement.
Yes, but there is a problem because if the Earth is nearly spherical object, so it is not spherical object.
It's not spherical.
But still, you will be using your spherical geometry.
Yeah.
Which is
we
about
anticipated this.
Spheres, not.
We anticipated this, right? We anticipated
Fine,
the idea.
you're not spherical.
We were thinking
geometry.
the nearly spherical object might
be able to squeeze that one through without us noticing it.
We thought you wouldn't notice it, but what we were thinking was
and I noticed it first. That's
that
great.
we could change that.
Well done.
We did consider changing it. We did consider changing it where you could encompass spherical, nearly spherical, or maybe a wider understanding of like a wider
that'll
net
do kind
for
of statement.
kinds of
Sort of.
curved surfaces, right? So lens shaped or whatever, right? But for the
right,
sake of
no.
argument, we assume that you would probably not quibble over that one too much, right?
Yeah, but you want definition. You want proof at the end of it, not from assumption.
Yeah, no, I appreciate. We had a thought
from
that's what I'm
proof
saying.
in the first place.
this is not
and clear statements.
not exactly final copy.
Yeah, we thought
Yeah,
it.
this
Don't worry,
isn't
I'll do
meant
that.
for
We're way
us,
ahead
is
of-
it?
we're
I
way
mean,
ahead of
this
you.
is meant for ignorant people of logic and geometry, right? You can get a double whammy when you do this. Put a Eric DeBay voice in the background. You know, anybody will believe it.
Because the end point, it'll be like 2 + 2 is 5.
Yeah.
And then your end point, you'll say, did they
Wait, was that the Eric
didn't
DeBay
notice?
Tis globe.
Tis globe.
Yeah.
You-
And then Nathan Oakley can do
Because-
one that sounds pretty similar that just says the earth is measured flat.
Yui, did you
Peter-
use Eric DeBay's
No,
voice?
I
make
didn't.
any
I
difference,
used
really,
an
does it?
AI that sounds
No,
eerily
Peter
similar to
says-
manufactured.
That's nice.
Peter
just
says,
shows
let's
how
not
good-
mention
Yeah, people are going to need
the
to learn
dogmatic
logic.
globe.
It's going to be a must. It's going to be a necessity. Otherwise, you're going to get cheated out of stuff. You're going to get people messing with your minds,
Yeah,
fucking
well,
you
look,
about, telling you
yeah,
all
we-
sorts of stupid shit.
I appreciate
So-
the two critiques. One is that you you
least
would
you're not
prefer
crossing
it
it
if
out
we
with
just
an
called it, I
Excel
don't know, clarification of what
No.
will become the premise.
You're talking about what you're going to come to in the end is you're going to call that reality and that's where we live.
Yeah.
But
He's
actually
trying to
you're
bend straight
avoiding it
lines.
here. Yeah, you're avoiding it here because you've got something to hide. So you
Well,
have
you
to
wouldn't put the
the-
conclusion at the start, would you? What do you mean
No,
something to
but,
hide?
but this is going to lead to this is a 2 + 2 = 5, isn't it?
Well,
It's
I mean, you'd have to show
absurd.
that, right? I don't know how you've come to that conclusion.
Circles are straight.
Because you have a model. And you're trying to prove this model that isn't spherical.
Nearly
Yeah, don't
spherical.
forget
Well,
that in
then
reality,
draw your geometry then that's not spherical.
Nearly spherical.
Well,
don't
what's
forget
that? It's not spherical.
I mean, I nearly fixed your water
Yeah.
leak, so I mean, it's
Yeah.
like I nearly did it.
And
I
you're
nearly got
nearly
it
right, but
fixed.
you're
I
not.
mean, I nearly fixed your oil leak. It's
want
just
to
a little
avoid
drip,
it.
but I almost got
Funny
it.
how you
You're
guys have
nearly
It's
there.
no idea about
inconvenient.
natural sciences. Natural
It's
sciences
inconvenient to your argument.
The problem is, unfortunately, if we would have said the Earth is a spherical object, that would have simply been incorrect.
Well, then
Well, there
that's
you
why
go.
you put nearly, because you know it's incorrect.
Yeah, that's
But
definitely
nearly
You know it's
spherical
not
is not.
spherical.
Nearly spherical is not
You
incorrect.
know
That
it.
is
You
correct.
know. Well, if I said this is a sphere, but it's not really a sphere,
Yeah,
but
but
let's
this is
pretend it's a sphere, you
but
would
this is
argue about it.
this is not
It
predication.
depends what you're talking
The
about.
Earth is
Right?
the
We're
Earth
talking
is
about what you're trying to prove, which is you're
Would
trying
it
to
be
say
better
that
if
this
we
is
said it
reality, that this
approximates
globe.
a sphere? Approximates a sphere.
That's
Yeah,
not
well,
good
you
enough.
could say
Or
that
it could be
a
approximated
circumference
by.
is nearly straight, isn't it?
What do you want us to
Nearly.
say? Like,
What is
we
a
didn't
straight
create here.
circumference? Exactly.
Circumference is nearly
We
Right,
straight.
well, don't worry.
create it.
I've noted
it's
the
definitely
critique.
You don't
not
have a
straight.
circumference.
We'll reformulate it at a later date. There's no
You
use
don't
in
have
trying
a
to.
well. Then how can we agree to go further on?
Well, we're not
We
doing
don't.
it for
You know,
they're not
Well,
doing
you've
it
got
for
to
us,
take
like we
it.
keep
say.
in mind. Let's keep in mind
This is
that
going to
this was a
fool
point
a
of
lot
contention.
of people. It probably already has. I mean,
Oh my
look
God,
at some
Bev.
how mine messed
I have
up.
Bev on mute. Is he going off?
Yeah, you need to chill. So let's keep in mind that
Need
this
to
is a point of
chill.
contention, and if this
You
becomes
sure?
a
You
sticking
taking the
point,
piss?
Are you sure?
It is a sticking point now.
You're coming here
I understand
telling
that.
us that we need to chill when you're
Yeah.
telling us that are nearly straight.
Broken
So
minds.
in
Like nearly straight
good
isn't straight, is it?
in good faith, me and Yui and Peter
So
have
nearly
tried
spherical is something that isn't
have
spherical.
tried we have tried
Sophisticate an
to
argument.
describe with
Sophisticate.
accurate
Not
wording and not
spherical.
misrepresentations,
But
and all you've
nearly
done so
spherical can
far,
make you believe that it
all you've done
is.
so far is accuse
If it
us
was
of being
spherical, you'd call it
dishonest.
spherical.
You are.
Can you understand how that might be a little disconcerting to me?
Sophist term.
It nearly is
As you've
disconcerting
just
to me.
done again.
I feel like Bev, you're getting a little bit worried.
But
Well,
can
I
we
just
might be on
just say that?
globe proof.
Can I just say that in
Nearly
reality,
worried.
To do that to Bev.
sorry,
in
but still,
reality, people measure distances with straight lines. No fucking curves.
by the way, these triangles, these spherical triangles, these numbers of angles, it doesn't work.
They're
because
not
it is
triangles,
nearly,
right?
Yes, they are not triangles, but if you call them spherical triangles, it is not working still because it is nearly spherical object, and this what you have shown, it was on a sphere.
It approximates.
Nearly a triangle.
Do you know what an
nearly
approximation is?
A sphere.
In mathematics or in physics?
Apart from the 540-degree
Something
triangle that
approximates
is a circle.
Approximates a square.
Peter showed us the other day.
Approximates a sphere.
It's nearly
Yes,
as
You know what
problematic.
it means.
But
You
you
know
cannot define because you are defining what Earth is.
Do you know? No,
It's
we're
nearly
only setting up the
sophistry.
premises.
Yes, this first premise is definition of the Earth.
Yes, so
It's
we are
saying
defining, yes.
what Earth is, and
So
it
stop
says that it is
bloviating all this nonsense and listen to what we're saying. We're saying we're proposing
You're
these
just too
things.
scared to
and
say
we're
that
gonna
you
prove
want
to
a
you
straight
that they're
line to
true.
be a circle.
So you
Just come
picking
out
on
and
us
say
for
it.
saying you said
Nearly.
nearly
Brave.
spherical. Well, we said nearly spherical because we wanted to be nearly spherical in our argument.
No, you didn't. That's all you
Yes.
got.
What do you think? It's a typo that like Yui fell asleep on the keyboard and he typed nearly?
Okay, so you are
Yes,
just
You
saying
purposely
you are,
put it in there, yes.
so
You're
you are
We
trying
put it
to
in our
being
argument
deceitful.
for a
We can
reason,
see it,
and you need to
and
think
you
through
get
it. And you
upset.
guys are so
no
childish
think. It is
and
just
take everything in such hilarious, nonsensical ways.
You're just trying to
No,
browbeat
no,
us
no.
into agreeing to your fallacy.
No, your premises are nonsensical. This is just bullshit.
Why?
Because
I cannot have an object that's
Bullshit because
nearly spherical?
you cannot define thing, but this nearly spherical object because we don't know what Earth is in this
You
definition.
don't even
It is
exactly.
nearly
You
spherical.
don't
It's a little
even
bit
know
off.
what it is. You don't know what it is.
So how can you prove
Okay.
anything
Okay.
No one
I'll take
knows
this
what it
feedback.
is.
I'll take this
If we don't
feedback.
try, we'll never find out.
Yui, and Manu.
No, but you're trying to say it's a proof.
Okay.
This is your proof.
Thank you. Thank you. I would like to take this
So
feedback.
trying to find out is not proof.
And can we say, instead of nearly spherical, can we say it's an oblate spheroid with a difference between radii of 0.03%?
Is a straight line nearly
Can we just say
spherical?
that?
So, did you hear what Peter said, Bev? Would you accept the?
Yeah, well, how did you measure your
No,
flipping
we're
radius?
just that's our
Radii.
premise. That's our premise.
Does your radii come into it?
That's our premise.
I
Yes,
want to
the
know.
radius
I wanna
kind
know,
of-
if
is
you
a
say
straight
so.
line nearly spherical?
It's our premise. This is
Yeah,
our premise.
okay, Peter, I can go along with
This is our
that.
premise.
It means that it is oblate spheroid, but you don't have any more great circles.
No, we will say it's an oblate spheroid with the proportion between, with the difference between the two extreme radii of 0.03%, and therefore all the spherical, all the arcs and great circles are approximate. They're ellipsoids, really,
Yeah,
but very tiny
if
ones.
we had a
So almost
radius of
circle.
infinite length, would the straight line be
It's
nearly
almost
spherical?
circle. It's almost circles.
If we had a radius of infinite length, would the straight line
Yeah, but we don't.
become
So that's not our
nearly
premise.
spherical?
I'm not listening to you. I have you turned down because you're annoying as hell.
It
So
doesn't
are you,
matter.
geez.
It is
The greatest
this
glow
is
proof
we
ever,
are
first
just
of its kind.
showing how contradictory your premises, axioms are. It is
Okay.
just
This is not
doesn't make
contradictory.
any sense.
Show a contradiction, because that's a big look. So far I've heard quibbling over words, but I've not heard like contradiction yet. I'd love to hear that one.
Contradiction means there is a contradiction
I
between.
want to hear. Show me where it is.
So I will show you in first sentence. The Earth is nearly spherical object, and the Earth is spherical object. This is contradiction.
Where does it say the Earth is a spherical object?
It's in your geometry.
What?
It is. I am showing you
Spherical
contradiction.
geometry. Is spherical geometry nearly spherical geometry?
No,
Or is
spherical
that
geometry is spherical
geometry?
geometry.
No, that was the axiom 2, Bev. They said indistinguishable.
That was
so
earlier,
like
yeah,
that's a that's a
Right,
I mean,
I
that was a
understand.
lead
So
up.
that's
That was
not
like I guess that's
nearly
predicating
spherical,
on
is
it.
it?
You guys think
that is spherical.
Indistinguishable.
You guys think that with taking into account Peter's reformulation, that we can't reconcile spherical geometry?
Can you go to GeoGebra and draw this nearly spherical object?
Do you think it can be
Because you've never drawn it
irreconcilable,
yet.
Peter?
Just drawn it a
again?
sphere.
Okay, sorry, I am off to bed.
All right,
Enough for me.
Yeah,
This
yeah.
bullshit.
Have a good one.
Well, I mean, unless Buster wants
Everything
to
that Peter describes on his spheres and balls and circles, he's drawing. It's nothing to do with what you've got here. It's not
Well, it
nearly
does.
spherical. It's spherical.
Yeah, so it's nearly correct.
So it's nearly a proof. Nearly the ultimate proof.
No,
Is that what
the
you mean?
proof,
Is that good
the
enough?
proof, you're conflating the proof and the sphericity of the Earth. The two have nothing to do
No,
with
the
each other.
nearly sphericity of the roof of the Earth.
The proof?
What proof?
We're trying to show it, but
No, we don't
Yeah,
give
but
proof.
it's near. What's
We
nearly?
just give. Oh no, we give proof, no evidence. Sorry.
It's
My bad.
vague.
We give ultimate glow proof. It'd be even better.
As long as 2 + 2 is 5.
I don't know how you've logicked that from what we've said so far.
You're trying to
Well,
use
because you want
comedy
to
as
add.
well.
You
It's
want
not-
to. You want
not
to
that it's-
inject nearly into
It's
it.
being
At
emotional.
this
is
point.
all.
No, it's just a question. You obviously understand it because you want to change it.
I accept
You can't.
that there's two kinds of people, and this is why I said this is geared towards Bev, right? It's people
The
understand
people who don't ask
the
that question.
spirit of an argument, right? So basically,
So
nearly
the
spherical is
spirit
kind
of
of vague,
proof.
but if it's clarified, it's clarified. We call it a day, right? But I know there's some people out there that if the words aren't on the paper and it's implied, or any clarification of terms
They'll-
are given, that they won't accept it because the letters weren't on the paper. That's you. That's fine. That's what it was
No,
geared towards.
because you want to bamboozle people into accepting something that they don't necessarily need to accept.
They'll have to accept it anyway. It's not going to be because of the words. That's not a great reason not to accept something. Don't accept it because it doesn't make sense, because it's wrong, because it's fallacious or whatever, but
Well,
not because of the words, right?
Yeah, that's how I begin to throw it out. All these
It
bits
sounds to me
means
so far
I
it's
don't
just
paint
been
a
quibbling
picture.
over the words.
I throw it out. Well, this is the first
Reality.
time I've said anything.
It's okay.
And
Well,
spherical isn't nearly spherical.
I'll
That's
go
the
back
point.
to the drawing board with it and change some words around.
You
I
can't, because
appreciate
your
the
model,
objections, though, especially
your
from
model
Buster.
dictates that it's not a
But,
sphere.
Right.
think-
Which is why we said nearly
I think
spherical,
if you
which we
can't-
never said spherical was nearly spherical.
How do you have
if you
how do you
can't
have a
accept P,
flexible radius?
If you can't accept P, from
And
what
where
you're
is the
giving us,
center?
then you won't accept the argument because P becomes the conclusion, obviously.
Yeah, but you're trying to, you pull out all these graphs and geometry that doesn't bear any relation to the reality you're trying to say that
relation.
exists.
No, you can't say any relation.
A few moments, you don't even have to wait because you listen to the whole thing, right? You know that reality was used.
You don't know what reality is.
That's just rhetoric.
You haven't got a clue what reality is.
What will be the conclusion of the
You've
presentation?
just got a model that you're trying to adapt to fit and then say that's your
4
reality.
So
But
5
that's not
direct
reality.
inferences that were given, and 3 out of the 5 were statements of reality. Flight paths, aeronautical navigation, nautical navigation.
We haven't even got to there. I didn't even.
Yeah,
I
but you
didn't
watched,
even.
you listened to it, so you know that reality was mentioned. So
I
your
didn't.
critique
I didn't even.
was
I
unfair.
didn't condense it at all. It just went by.
So what's the?
I really didn't take any
what's the
notice
scale?
of it. Why would I? You're now going through it piece by piece. Why would I need to?
Yeah,
You
that
just
sucks.
dance by with some music, with these little weird voices. It was so fast. There's no. It's impossible to condense all of that information.
That's
And
fair.
if you want
I'll note that as
want
a
the
critique.
ordinary person who's going to be bamboozled into believing it without question, then they aren't going to condense that either.
Yeah,
and
I'll
absorb
note
it.
that as a critique. It's very dense information.
Right.
There's a lot of text on the screen.
Okay.
I get that.
And now that's what you're doing now. You're going through it.
Yeah, like
So
you
could
guys,
if you said that it's stipulated that we have to agree to it all.
No,
without
I don't
looking
think.
at
Well,
it,
could I
reading it,
could I point out
understanding it.
could I point out one other contradiction real quick?
Go on.
Yeah.
I know what you mean by other, but yeah, go on.
Just another that hasn't been mentioned yet. Like on the first, the axioms,
Yeah, go on.
the spherical geometry approaches Euclidean and it's indistinguishable at small scales.
Mm-hmm.
On your premises, spherical geometry is utilized in reality for practical applications, including navigation, satellite communication. I mean, is that where like the scale comes? Oh, it's gone now. Is that where the scale comes into play? That it is distinguishable?
Yeah.
Can you say that again?
In your axiom 2, it said that spherical geometry, as spherical geometry approaches Euclidean, it's indistinguishable on small scales. But in your premises, you say in reality, you use them for these practical purposes. Like, is that where, like the ones you mentioned, are those small scale that still makes them indistinguishable, or
Yes.
are you making a distinction between the two geometries in a larger
those are
scale?
Yes.
Yeah, those are the scales where spherical geometry matters. It's
Yes.
still, because it's nearly spherical, it's still going to be an approximation, but if you approximate flat, you get the wrong answers.
So in your premises, when you've given those larger scales, the spherical geometry is distinguishable. So now you're gonna have to make the distinction between
Obviously,
the two.
yes, that's the whole point. The point is, at small scales, it approaches Euclidean geometry and is nearly indistinguishable. We should add nearly there, Yui, I think.
What's
But you're practical. That's what I'm asking. That you're using large scale things, and now you're going to have to say what spherical geometry is and how it's different.
Absolutely. No, we assume
It's
everybody
distinguishable.
knows what
Now it's
spherical
distinguishable in
geometry is.
4S.
Yeah, that's a fair critique. So we should mention where that difference happens, and it's going to depend on what exactly we're doing.
no.
So if we're
What's
flying
the
halfway around the,
difference?
still speaking. So if we
What's
fly
the
halfway around the
difference?
globe, for example,
always
then
got
spherical geometry is
representation.
going to be important. If we're
Where's
building a house,
the
not so
difference?
much.
Yeah, a scale has always got a representation. So therefore, if it's a small scale, a large scale, or whatever it is, there's always a representation. So therefore, the premise is always there. So what you're talking about is gobshite.
Where's the difference, guys? Come on.
You're a gobshite.
It's
You
in
don't
the
know what
scale.
approaches means.
Right, well, we've got Euclidean. We know what that is. Where's the difference?
Manu, just turn down Bev and speak over him. That's what I'm doing.
Well, it doesn't matter if it's he's
Anybody
not
who
going to
might
listen.
ask you a question.
Yeah,
You
the
said
difference
it
is in the
today,
scale.
you lot.
The
That's
scale.
it.
That's
We
what
just
I'm
gotta agree
asking.
with your
Scale is a
bullshit.
proportion of 1 to something, right?
Right.
Well, the
So
1
depending
to
on what
1 is the Euclidean. Where's the difference?
That's not 1 to 1.
Yeah, 1 to 1 is the reality scale.
Just to be clear,
That
you
was the
asked
bit where you
what's the
said it was local.
No, well, Bev, maybe
you're
their
asking
1 to 1
where,
is the spherical, but now
No,
they
no,
need to make the
1 to
distinction.
1. No, you're map mixing. That's not the kind of scale we're talking about.
What do you mean the kind of scale? It's a proportion.
We're talking about the scale, not a proportion, the scale at which we're using these methods, apparatus, techniques, whatever you
Well,
want to
what's
call them.
that
tools.
scale?
Depending on what we're doing,
1
that scale will
to
vary.
what? What's the
No,
What's the
that's
scale?
not the kind of scale I'm talking about. We're not building little models. We're talking about the scale at which we're performing some act,
Yeah,
right?
but
On a
what is
human
that
scale,
scale?
on
Yes.
a country scale,
What
on an
is that
ocean scale,
scale?
on a
Tell
globe
us.
scale. I just did. You spoke right through it.
Yeah, but in your premises, you've got things that are practical uses that are on a larger scale, I'm assuming. And now you've got to distinguish between the two. Because
Yes, that
in
is
the
something
axiom,
that should probably be done. Yeah.
yeah.
But again, it's not going to be a single sort of thing. It's going to be relative to what specifically we're talking about.
I've got a
Oh, so the
scale
scale
ruler
could
here,
be-
right? It's got
Yeah,
1 to 1,
relative.
and it's got 1
Yeah.
to 1,250. Now, which one of those
That's the
would you say
relative
is a
part.
large scale, and which one is a small scale? Considering the ruler is the same size. So tell me, what does scale mean if it doesn't mean this?
It is the
means-
ratio.
No, not the ratio. What I mean is how big of a surface are you using these tools on, or taking measurements from, or measuring with some kind of apparatus?
Do you mean a big 1 to
Compared to
1
the radius.
scale where that just gets bigger? Or do you
Yes.
mean a scale where you can relate the 1 to something that's very big?
The first one.
What, where 1 to 1 just gets bigger?
That's right.
It's still scale 1 to 1.
That's right.
It's just very big.
Correct.
It's not very big scale. It's 1
Okay,
to
let's
1
use an
scale.
example,
It's
Manu.
just very
Let's give them an
big.
example. When you're building a house, in reality, geometry approaches Euclidean. When you're building a railroad from Washington State to Illinois, it stops approaching Euclidean.
No, that's just scale 1 to 1.
Yeah, 1 to 1, different scales, different distances. Building a house, almost totally Euclidean. No need to worry about nothing spherical.
Okay, so
If you're
let's
building a
let's just go with it. Let's go with it. Simple
spherical.
terms, right? We've got a straight line. Now we're going to make it bigger. What happens
Yeah.
to it?
Over longer distances, we start noticing it's an arc. It was never a straight line
Right,
in
so
the first place.
it bends.
Yeah, we just never noticed at smaller
Do we know
scales.
in what direction it bends?
Absolutely.
Okay. Does it always bend in the same direction?
Absolutely, yes.
Okay, so and as it gets bigger,
But
does it
straight
bend
lines
more?
don't bend.
No, but arcs do.
No, as it gets bigger, does it bend more?
No, it bends at the same rate.
Okay. So it's always bent then?
Yes, we just don't notice it at small scales because
It's
it's
never
so tiny.
straight.
It's never straight.
Yeah, it just
Never
approaches
straight.
straight.
That's a
Never.
stolen
Not even on the
concept, Peter.
I don't
Not
know
even
what-
on the flat Earth
Because
model
we
you had.
started off with a straight line and then it turned into a curve that was
No,
never
he
straight
did-
in the
he did-
first place.
He did
It's
say.
a
He did say.
self-refuting claim,
No,
right?
no, he didn't.
You
He
try
did
to
say.
you make
he
it
did say
bigger
that
to refute
he-
the fact that it
You're
was
just trying to
straight
wait
in
for
the
Ben
first
to
did
wind
place.
down.
clarify. He
It's
did. He
crazy.
did clarify before your rebuttal that it wasn't straight to begin with. He said that immediately.
It was never straight.
Okay, so how did he draw the triangles in his first proof? If
Yep.
the straight line doesn't exist.
It doesn't exist, but it's
Triggered by straight lines.
Well, wait a minute. What's your reference? How do you reference anything? Is your reference a curved line?
You establish one.
The distance
You establish-
must be a curved line if you can't have a straight line. So the meter
Jesus,
that you
calm down.
consider as
Yes.
straight can't be straight, Peter. Is that right? Because that's
No
going to
line
really
is
do
straight.
people's nutting, right? If you go round telling people they can't have straight lines,
They can. They approximate straight lines.
Or you establish one.
Think about it in the question of utility, Bev. At the scale, at such a small scale, on a curved surface, what practical issue would you have with establishing a close to a straight line? You wouldn't have any, right? You'll be able to build your houses, you'll be able to build your railroads. Doesn't matter, right? So for us,
I only have problem with people
virtually straight.
gaslighting straight lines.
Yes,
Because
I'm gaslighting
that
straight
has a serious consequence to people's minds. And you guys think it's
Does it?
funny.
Yeah,
People are
Great
going to
view.
be affected by this sort of shit. People already have been affected by this sort of shit.
You heard
I'm
Adam
noticing.
today? Did you hear
Yeah,
Adam today?
these 3 or 4, they've been affected by it.
Yeah.
That's what happens when you start bending
Yeah.
fucking straight lines. Can you not see that?
They got me.
Yeah.
I never thought it'd come down to the straight line, but and I heard it
Yeah.
said, and I thought, no, surely not. But here it is. This is the base of it all. You don't have to go any
In
further. You don't have to go any
It's
further.
like-
There's no straight lines.
Let
That's
it
me-
be.
what you need
Let
to
it
say.
be granted. Let
Can't
it be
have a straight line.
granted that on the
This
surface
is the
of a
great
sphere,
disproving of Euclidean geometry.
let it
Euclidean
be-
geometry and mathematics is
let it-
based
let
upon
it
that
be
straight line.
granted. Let it be granted.
You guys
on the
are
surface
geniuses.
of a sphere, along the surface of a sphere, there are
All for the
no
sphere.
straight lines.
Let's get rid of
There's no
Euclidean
straight lines
geometry.
anywhere.
You don't need it.
Let it be
No
granted.
straight lines anywhere.
Let
I
it
just
be
said
granted.
the triangle.
Tis glow.
Hang on. I said
This
the
is what I-
triangle that Peter drew.
Hang,
The straight lines are not. The triangle's not straight lines.
hang
He
on.
said
Like,
they're straight
this is
lines.
what I was getting at earlier, like 45 minutes ago, was that now if you don't have straight lines, you don't have pi anymore. I mean, like, what are you supposed to make of this?
You can
What
have
are you-
straight
what are you
lines.
doing?
I don't
What
know
are you
what's wrong with everyone. Nobody has problems with straight lines. The
Apart
issue
from
is
Peter's
the
just said we
straight
can't
line
have straight lines. You're
is
doing
the straight
Peter's
line
nutting.
is the straight
Captain.
line the same as the Earth is the issue.
We're talking
Okay,
about a
can I
straight
just show
line.
this?
That's the problem.
But just
We're not. We're talking
just
about the
stop
Earth.
it.
Well,
Can I just
Peter's
demonstrate-
talking
We're
about
talking
a
about
straight line.
lines.
He's just told
Okay,
us.
No one
you
has
haven't
problem
got
with
the
straight
Earth yet.
lines.
You best
I
clear
haven't
that
got
up
the
with
Earth.
Peter.
I will demonstrate. Okay, so here, do you see the gray lines on the screen? Are they straight? Do you see, does everybody see, can everybody see the triangle above, the gray lines? It's formed using straight lines. Do you guys see it?
It's a
No, can't
triangle,
see that.
yes. Peter.
Okay, straight lines.
So they
those
are straight
lines?
lines. We're allowed to have them,
Yeah.
are we, Peter?
Yes.
Okay.
Now, what we're saying at the same time, the points on the surface of the sphere are connected using arcs.
Yeah, but they can also be connected using straight lines too.
Not on the surface of a
Of
sphere,
course
no.
they can. You can make a triangle
why?
from
No.
3 points, connecting
How
with
could they
straight
be connected?
lines.
Okay.
Will those be on the
What?
surface?
Make me draw it. I will
The
draw it
points
for
are
you
on
on
the
geometry.
surface, yes. You just said.
Tell me how to do that. I'll do it right now in front of the live audience. How do I do? Walk me through it.
Get your line tool.
Okay.
Place it on 1 point.
Okay.
And then move it to the other point. And make
Like
your
this?
line from 1 point to the other.
Okay. Is that on the surface of a sphere? The line?
2 points are, yes.
Yeah, but is the line on the surface?
The line is the shortest distance between those 2
Yes.
points.
It is? Is it on the surface?
The 2 points are on the
Can't
surface.
answer that
yes.
question,
No.
Peter.
Is the line, I'm going to keep repeating it, is the line on the surface?
The
It
line
simply
is the
will not
shortest
compute.
distance
He will
between those 2
refuse.
points.
Yeah, but I want to embarrass him in front of the audience, okay? I know he's not going to
That's
say.
fair.
So, is the line on the surface, Bev?
The line is the shortest distance between those 2
Yes.
points.
That's
This
correct.
is
Is it on
amazing.
the surface?
The 2 points are on the surface, Peter.
Yes. Is the line on the surface?
The line is the shortest distance between those 2 points, Peter.
Yes, it is. Is the line on the
The
surface?
2 points are on the surface, Peter.
They are. Is the line on the surface?
The line is
You're
the
gonna
shortest
break him,
distance
Peter.
between those 2 points, Peter.
That's true. Is the line on the
The
surface?
2 points are on the surface, Peter.
Yes, they are. Is the line on the surface?
The line is the shortest distance between those 2
Yes,
points,
it is
Peter.
indeed. Is the line on the surface?
The line, again, I'll say this one, change it up a bit. The line is the shortest distance between the 2 points that are on the
Absolutely.
surface, Peter.
Absolutely. It is.
Easiest bullet anyone could ever
It is.
bite.
Is the line on the surface of the sphere?
The line, Peter, is the shortest distance between those 2 points.
Absolutely.
It's like the end of Braveheart. Just
No,
mercy.
let me try, Manu.
You do
I'm
that.
gonna try
You do
another
that
one.
with all of the points, Peter,
Yeah.
and you'll
No.
get a triangle.
Okay. Yes, that is true. Now I have a question. Do you see on the screen any other line connecting the blue and green points? Are there
blue
any
and
other
green
lines
points.
with us in the
Yeah,
room
you've got
right
one
now?
that looks a bit longer than that shortest.
Yes, the red line, the red one. This one?
The red one.
Yes.
Yeah.
Yes.
It looks
Is
longer.
that line on the surface of a
It
sphere?
looks longer, doesn't it?
Yes, it is longer. Is
There
it
you
on
go.
the surface
Brilliant.
of a sphere? Is it?
The red line.
Yeah.
Yeah, it's longer than the shortest distance, so therefore
Absolutely.
it's
Is it on
definitely
the surface
curved,
of
isn't
the-
it? Because
Yes.
the shortest distance is straight.
Yes. Is the red line, the longer line, the curved line, on the surface of the sphere?
Yes, but it is longer, right?
Yes. Yes. Let me
Remember Bob's
rephrase the
modus
question.
ponens?
Absolutely. Let me rephrase the question.
So the shortest
Is the
distance
red-
is the straight line, isn't it?
Yes. Let me ask you this. It's a new question. Is the red, longer, and curved line on the surface of the sphere?
On this, yeah.
Okay. So what we were trying to say was, on the surface of a sphere, you cannot have straight lines. You can only have arcs connecting points. Underneath the surface, or even above it, depending on kind of the plane you choose, you can certainly have straight lines, as many as you want. No issue with that. So all we're saying, we're not denying the existence of straight lines. What we're saying is that on the surface of a sphere, you can never connect 2 points with something that is on the surface and is at the same time a straight line. Does that make sense?
But the shortest distance between any 2 points
Absolutely.
in any
Absolutely.
direction isn't a great circle, is it? It's a straight line.
No, absolutely, it's a straight line, but on the surface, it is an arc. I hope this helps, right? I think we landed the point, Manu. I think, we persevered.
But the surface is definitely 3D.
Yes, the object is 3D, yeah.
The surface is 3D.
The surface is two-dimensional.
Of a sphere?
Yes.
You sure?
Absolutely.
A plane's 2D, isn't
It's
it?
very easy
you're
to
wrong.
prove. No, it's very easy to prove.
A plane is 2D, though, isn't it?
No.
Yes.
A plane
Yes.
is 2D. Come on,
A
make your
plane,
mind
yes,
up,
yes,
Peter.
yes.
Come on.
I'm just ignoring what you're saying, Bev, so I give random answers.
Yeah, your
Buster,
advisor
I
would
can prove
advise
that
you
the
not to
surface-
just give random
I
answers
can
like
prove
that.
that
Plane
It
is
makes you
2D,
look
but
terrible, Peter.
Yeah, it is. It
yeah.
is. Hey, so the surface is 2D because we only need 2 coordinates to describe any point on
Is
the
the surface a
Yeah.
plane, Peter?
No,
But you said it's 2D, and a plane
it's
is
2D.
2D.
Yeah. Well, planes are not the only things that are 2D.
Oh, like a plane, but different.
Yeah, exactly. That's a good way to describe it. Yeah, a plane but different.
That's contradictory, Peter.
Well,
Yeah.
you came up with it, so I'm crediting
One of
it.
those-
not
that. Yeah, a
It's one of
plane,
those,
but not that.
In reality, the surface of a sphere displaces water. In reality.
Yeah, that's nonsensical. But okay.
No, it's
Well,
you
just
disagree
says
with
that anytime
Archimedes.
he gets troubled.
No, it is nonsensical. Like you guys say,
He thinks it's nonsensical if it troubles his
I
when
get
his
it, I
PCB,
get
like
it.
it's a response.
Yeah.
Yeah. So
You guys say the Earth is nearly flat, so can we not just say nearly spherical?
Who says that?
Nearly flat.
Who says that?
No, we don't.
You do both.
So where were
Who
we?
says
Connor?
that? Who just said you guys?
I honestly don't
Who
remember.
was that?
Dragon. Dragon.
Almost, nearly.
Yui, where
Kind
were
of.
we?
that?
We were talking
Who
about.
says that?
Not
Hello?
You're in
anybody.
the wrong place. You've been hanging about
Yeah.
24/7.
Yeah, he's
Maybe over there they say that. Has he?
Yeah.
Good. He's a
See, that would
troll.
be that's cogniz because like he just like gone, like you
False
just like deny, like
He's back. Hello, turquoise.
oh, there we go. Okay.
I think it's because we're all talking over him, saying, "Who said that? Who says that?"
No, it was because
Well,
he
that's
said
all right when
you
Peter
guys.
does it, though.
He just blatantly lied.
It's all right when Peter talks over everyone, though.
Somebody else.
Constantly.
Whatever
Constantly.
he wants, he's the king.
That's another illusion he holds on to.
It's a nice one to hold on to.
So it's
Okay,
through D then, the
should we
surface.
continue? What are we doing here, guys?
It's through D.
I mean,
2D and
I wouldn't
3D at the
mind,
same time.
but I don't know if we can really.
No, I think the argument has there's some
Hold on,
broken
it's
minds,
asked.
let's say, right? Where
In what sense?
we need to edit a few words to make them happy, and then we'll
What
go
would
back.
that
Your
do?
mind's broken.
I thought you got
Trying
I
to
thought
do
you
it.
got it sussed and you sorted it.
It
Like, I
won't
don't know if
work.
Now
there's
you're
any
trying to put it
way-
onto us.
No,
I don't know
Trying
if
to put
there's
it
any.
onto us so we got it wrong.
We aren't the peers that you want to be reviewing. We're just helping you fix up your argument. You've
Yeah,
got
I
to
agree.
you've
Bev,
got to
I
sell
agree.
it to
I
the greater.
that's how I saw it, Bev. I don't see it
globe,
like
right?
you're going to
I can see
No
great
wonder
things
Blue
in your
Marble
future.
didn't want
the
to.
point. The
Definitely
point
see
is,
it.
I think it's important that we take into account your objections and say, okay, look, right, we'll change some words around, define terms clearer for you, and then maybe it'll be good enough to give to 24/7. So much so they
They'll suck it
wouldn't
because
know
they
what
haven't
to
got a
say
clue.
in response to it.
Here's the
That's
problem, though. Like, I'm not sure what the objection to P is that we could fix and have it remain accurate.
Nearly
Marble
isn't
into
One
the
thing, Mano,
weeds.
they are not giving any reasonable feedback in the sense of like contradictions. They're more emotional feedback. So they took issue with the word nearly. So I proposed to replace. They said it's not specific enough. So let's give them specific. It's an oblate spheroid with a difference between the radii of 0.003%. That's specific.
That'll make the surface definitely 3D.
See, that's, you can tell this person
right.
doesn't
Look,
know
this
what's
is
up.
the list of objections I've got.
Up and
Applied
down. It's going to have to go
assumptions.
up and down as the radius changes.
Hold
It's
on. These
already
are the
3D.
objections I've collected, and you can tell me if you think they're substantial. Implied
The
assumptions.
surface, you said, was
disclaimer. That is
2D.
to say that we need to mention beforehand that we know what a sphere is. Then change axiom to assumption.
How do you know?
Then spherical geometry is a loaded
How do you
term.
know what is
Then
a sphere?
set the terms of spherical geometry in the clarification of terms section. Quibbling over approaching Euclidean geometry, the word approaching. P1 clarification of nearly spherical object. Too much dense information. What's the difference and where it happens? That's not actually that bad of objections. I'd say the argument was successful if those are the objections.
No, there were good ones. Sure. This last one, I don't know how.
No, it was. Let's say it was nearly successful. Let's say that.
Nearly.
Well, Manu,
I don't mind employing Peter's solution to that, but I don't know if
I don't know on what
that was really
scale. Like nearly.
No, it won't, because they flip flop. If you do that, then they will say, "How do you know this?" Right? If you say nearly,
You
they will say
flip-flop,
you're not
Peter.
precise enough.
Because when anybody ever mentions it, you tell them to shut up.
The thing,
Just
about
stick to a
using the
sphere.
objections and taking them seriously is that if you include and you address them, then when the final version happens, they will not have anything to object to. Therefore, ergo, they will agree.
Yes, there is only one weak point in this ultimate
not
proof.
how
You
arguments
know.
work.
There's only one.
Not so
And
sure
the-
you
and that
guys
is-
have.
that is
got
used
If I have a
sorted.
deduction, if I have a deduction, Bevan, you have no.
It uses the
objection in
word
mind.
sphere. That's
Would
the
you
only
say
problem.
anything less than you agree?
All you're doing is reverse engineering your fantasy.
We need to remove the word sphere,
That's
and
all.
everything will be
Globe,
perfect.
right? This is
Yeah.
this is blue marble science in action. You're witnessing
but I
it.
think-
This is how it's done.
I think we're gonna fix these, come back, and then get stuck
How
on
they
Q.
make a model.
Yeah,
You
yeah.
could
I
do
can
this.
imagine.
A
To be fair,
documentary.
I will say.
Yeah.
Before we go and edit, since we're on this page, is 2, 3, and 4 Q, R, and S controversial?
Well, it'll take us 2 days to go through that.
you got Big E, which is the biggest controversy. Like, I mean, you obviously think you can know what Big E is. Obviously, that's like a
Are you talking about Earth?
Yeah, Big E, Earth.
What is that? Voldemort?
Big E, yeah.
Big E, like it's a noun. Like you've given it a physicality of what Big E is. Big Earth, Big E
We
noun.
monadicized it, right?
Yeah. Yeah.
What are you talking about?
Whose reality?
What is Big E? Is this from?
I
like,
think
the children's
you're
cartoon?
really gonna hate Q and R. I don't even know why Q, R, and S. I feel like E,
Wait.
E was just foreplay, really. Wasn't
Yeah,
it?
okay, that's fine. There's no problem with foreplay. Like that's great. But then you've got like what were the other ones? The 2 points of equal elevation on Big E's surface. Like that's your assumption of what that overall encompassing thing is. But it's your argument, you know. Look, yeah, it's
That's
nearly.
just a sort of steelman of
So nearly
Bob's,
level.
essentially.
Nearly
I mean,
horizontal.
Nearly at
distant.
the same elevation. Nearly.
It's indistinguishable from Euclidean, though. I think. Well, no, wait, that's small scales. It's indistinguishable at small scales, but then
nearly indistinguishable.
nearly indistinguishable. Well, that's kind
Nearly a
of that's
triangle.
adding words like where they don't belong. But
It's
I mean,
bulletproof, Bev.
I think they do belong.
Yeah.
It's the
I
law
think
of imperceptibility.
indistinguishable-
It comes
yeah,
down to that.
There's a consideration of distinguishing that
Law of
has to do with the
contradiction.
tools and apparatus, which I think was being maybe overlooked. But
that's what we do. That's what we've done. Like it's like the tools you use them. You distinguish. You do.
You don't
the
have to like
differential
it. Just
leveling.
it's a question.
yeah, that's what they're for.
Yeah.
But all
Hey,
tools
guys,
have
I
tolerances.
gotta drop off. Okay. Someone
All
can
right.
resume
Twitter
the
show, is
presentation.
it?
Awesome job, Manu and
Is
Yui.
it? Good luck on the Twitter thing, Peter.
Have a good
it's
one.
a big show this
Thank
weekend,
you.
isn't it?
See you guys later.
See you later.
Yep.
I think
Be
they've
straight
got
on it,
Caleb
isn't it?
on again.
Truth, Bev. What do you reckon?
Be going talking about mustache men.
What do you reckon, Bev? Ultimate globe proof.
Yeah,
Exciting,
you
isn't
see
it?
that? I've
Ultimate
already
Globe
got it.
Fail
Look.
Part 2.
Part 3.
what you need is laws of Globjic, right? You did use the law of the included middle, didn't you? Nearly.
The law of the included middle?
Yeah, the
What?
law of
Yeah.
the included middle. Nearly.
I definitely have to applaud the vacuous statements in it. That was great.
Can you describe the law of excluded middle?
The law of the included middle.
Yeah, but can you explain the original, the law of excluded middle?
It's either on or off, right? There's
Mhm.
no middle. You
So-
exclude the middle.
Right. So if I say in the world, lights are on and lights are off, does that violate that rule?
What?
In the world,
No,
in reality.
No. When you make a logical statement, that
Mhm.
statement can either be true or false. There's
Okay.
no middle ground. That's what the
Okay.
law of the excluded middle means. But
Right.
Globjic has the law of the included middle, where you can
Gotcha.
put
So
like
if
a
I say-
nearly
Yeah,
in
I
there
got
as
it.
well. You know.
Sure. So if I say lights are on in the world, right? We all know lights, like we have them in our house.
The lights
If I
are
say
either
light-
on or off.
What is that what that means?
What?
So if I say the lights are on,
Yeah.
that can be true or false, right?
Yes.
And let's say that's true. My lights are on, right?
Yep.
So lights are on in the world. If I then say lights are off in the world,
No,
that's
I
also
don't know
true.
why you'd need to say in the world. You'd say the light is on, and that could either be proved true or false.
But what if I want to make that more general and I just say lights?
You're
It's just a word. Like, I don't
you're
know. That's
dancing
definitely
on-
not a statement, is it? It's saying lights.
What I'm trying to get at, here's a better example. The sun is shining, right?
Mm-hmm.
So here where I'm at, I don't know where you guys are at. Here it's 2:40 in the morning. Right? So clearly here the sun is not shining.
Mm-hmm. So that could be
Right.
proved false.
Right.
Well, there you
But
go. Either true
somewhere the
or false.
Okay, so someone else says the sun is shining.
Yes.
It's 2:40 in the morning, and you're trying to falsify whether a light can be on or off. Think
No,
about that.
I'm trying to
I'm trying to understand
illustrate.
the law of the excluded
No,
middle.
I understand it. I'm trying to
And
illustrate
within
how
logic,
what
a
needs to be
statement
taken
either
into
has to
account.
be true or false.
Yes, and that statement needs to specify certain things where if you don't specify that thing,
Yeah.
you can make something sound like it's true and false, but it's because you haven't specified a
No, you
time
can
or
put
place.
a term in like nearly.
Exactly.
Yeah, so that's
So it
the law
doesn't-
of
so
the
it doesn't
included
violate-
middle, which
No,
is
it doesn't
Globjic. That's the
it doesn't
differentiation.
violate the law
You
of the included
guys
middle.
added the middle by including the nearly.
Yeah, it doesn't violate the law of excluded middle, Bev.
It does. It's
What are you
including
talking
the
about?
middle.
It does not violate it. I think if it was the case that all utterances that include the word nearly violate the law of excluded middle, you would never, ever see it in a philosophy paper. Fortunately for us, we do.
You basically nearly got there.
Can a
It's
building
vague.
be
It's
nearly
vague.
finished?
It's vague. It is vague. It isn't violating a law. It is vague.
Can I be nearly at my destination?
Vagueness.
Is that what we're dealing with here with the proof? Does a proof? Are you nearly making a proof?
It's vague.
So you're vaguely making a
including the
proof.
middle.
I think we
It's
can
just
agree that
vague.
nearly can be used in some
Right,
situations
you know,
and
like
not
how
others,
vague
right?
you can be between a true or false, right? Just vaguely true
Yeah, so
or
it's just,
vaguely false.
We've
I'm going to give
already
you guys the
relegated-
ultimate
already
proof, but it's nearly a
relegated-
proof.
We've relegated your critique from what you called an absolute violation of a logical law to just it's not specific enough. And I agree. Maybe it could be more specific.
You know you had this discussion. You know you did, don't you?
What discussion?
How long did you discuss this? How do we get round this?
No,
when
this
we
is
choose
what we're
near-
doing here. This is what
when
they're
we had
doing.
our-
They'll come
when we
back
had
with
our-
another one.
previously-
when we
Yeah,
had our
these
5
guys
minutes
aren't
wasn't an
bothered
issue.
about
when we had
you
our
know
5
blatantly
minutes
getting
alone,
falsehoods
right?
because they can keep coming
Yeah.
back.
When
They
we
could
had
do
our
it for
5 minutes
years.
alone, me, Manufacturer,
This is
and Peter,
literally
and
how they make
Turquoise,
the globe.
we said together, I think there might be some quibbling over that word, and we
Yeah, but it
agreed
wasn't for
upon
the
that.
nearly. It was for the spherical, I think.
Yeah,
Well, it's
nearly
nearly
spherical.
spherical.
The two words together. It wasn't just spherical on its own.
So it's not spherical. We knew it wasn't spherical.
'Cause
Why would we
thought
argue about that? Because you've said it's nearly spherical, so it's not spherical.
we thought we'd give it a punt and say, look,
You give it a punt
if
and hope it wasn't spotted.
if they can intuit that we're saying it's not specifically a sphere, but there's certain
It's not a sphere, then.
measurements. There's certain measurements that approximate
No, it's not a sphere,
close
then.
to a sphere that you would.
Is it a sphere
agree
or it's not a sphere?
that's
Which
our
is it?
claim.
It's not
Is
a
it a
sphere.
sphere?
Nobody
It's not a
contested
sphere.
that. It was said
Right.
explicitly
So
many, many
spherical
times. I
doesn't
don't know why
work
you
then.
keep going on about this.
Because you'll bring geometry that is that.
Yeah, it's
and
definitely
claim
not a
other
sphere
things.
because a sphere is
Geometry, which
spherical, and this
practically
isn't spherical.
approximates it very well.
The
we're
one thing
talking
that
about
we
in
know about
reality.
it in this
So,
statement is that
in
it's not
reality,
a sphere because a
deploy
sphere
Here's the
is
problem.
spherical.
Here's the problem. Geometry is not reality. We use geometry as a practical tool to approximate reality because it works.
like a water level, you mean?
For example,
Well, what about when one
Or that a
geometry
canal.
approaches another and it's indistinguishable? But at a larger
That's
scale,
fine.
you have to distinguish it, but you can't.
Whoa, wait a minute. What do you mean geometry isn't reality?
geometry can describe reality.
Geometry's pure
Geometry,
logic.
like all of mathematics,
Are you saying logic
is a language
isn't
we've
reality?
devised so as we can speak about the relational nature
Are you
of reality.
really saying that reasoning process of logic isn't reality?
Logic and geometry are not perfectly synonymous. First of all.
What? You're in reality. We're in reality right now, speaking, trying to make sense of what you're saying. You're saying that reality's not, logic isn't reality.
Let me
Let's talk about geometry.
Yeah, geometry is pure
Is-
logic. Pure logic.
Proof on proof
And
on
we're-
proof on
and
proof on
we're
proof.
saying that in reality, you transpose practical tools onto close to
We
nearly
use logic
almost
to reason.
quite geometric
Close to
shape,
nearly
and
almost,
it
you said.
produces results. That
You're
is
putting
a
you're putting it into
pragmatic
shapes and
assumption,
stuff.
right?
That's not what
It's a-
logic is.
It's a
I don't
We
think
use it to
anybody heard you,
reason,
Yui.
to go
A
through
straight
life.
line is
They're not
Fuck's
listening.
sake,
straight line
you
is
guys are messing
Is
around
it-
with people's minds.
It's just the case.
Is it safe to
Your
say
own
that
minds as well.
reality is
It's
not
just the case,
reality?
like, take for instance a water level, right? And I spoke to Jerry about this earlier. Now, when you say water's horizontal, that's assuming you use water level as a tool.
No,
but that's assuming
we
that's
assume that we use a water level to establish
Yeah.
a horizontal plane.
Correct.
We don't
Wait, hold
say
on, hold on.
water is horizontal.
Well, hold on. So,
Again, like when you
hold on,
say that
hold on.
we say that,
Bev,
that's a
Bev,
lie.
Bev. So when I
Don't
said to
don't just
Jerry-
keep saying my
when I said-
name. Say,
when I said
"Oh, I'm
Jerry-
sorry, Bev. I lied about you."
You said
Saying something that you don't say.
spoke to Jerry, right? I said I spoke to Jerry. Anyway, the point is that I said that out because he was talking about rivers and oceans and water at rest. He wasn't talking just about water levels. That's just a tool we use to establish a horizontal.
Talk to someone here,
Now,
not Jerry.
I said that when you consider the idea that there's no intervening thing in the world that could influence what water's doing, then fair enough, right? It will do exactly as you're describing. But and I've said this before to him: if you transpose a water level, what's going on with water in there, onto large bodies of water, you're probably going to have a mismatch.
and that's
Probably.
where you can approximate
Nearly.
things with geometry, but not
Almost.
exactly
Possibly.
reflect reality with them, right? They're not one-to-one reflections of each other.
They actually are, because with the surface of the sphere that Peter was saying was like, I think he said it was 2D, or maybe he said it was 3D and somebody else said it was 2D. But in reality, the surface of a sphere displaces water, which is physics. And then also in physics, you have law of communicating vessels, which also states that at every point along that same pressure state from point A to point B is a horizontal. It's horizontal at all points along that equal pressure state. It's a straight line from.
Well, you know, I mean,
Well,
I don't want to just repeat what I
haven't
just said
figured
like
that
2
in.
seconds ago,
Yeah.
but
You don't know, Yui. You don't know. You
Alright,
don't know.
okay.
You're the word man.
Shitty
You
rhetoric
don't know
anyway.
this.
So
You're
wasn't
just the
rhetoric?
word
That's
man.
physics.
Well, I'm just saying that
Well,
there's going to be
Inconvenient
rhetoric.
Correct rhetoric.
intervening effects on what other things do in the real world that aren't going to give you your exact perfect mind geometry.
Mind geometry.
And
now
you
you're going to
can't-
get.
And if you
Wow,
think that's impossible,
clever.
if you
Wow.
think that's impossible, that everything must be a one-to-one reflection of ideal geometry, then you're going. I mean, that's a knowledge claim where you'd say that nothing else could interfere with that, and you can't
I
have
think
a
you
regular
spent too long on the internet, Yui.
Wow.
How many years have you been doing
Spent
this?
over that over
Years?
24/7.
I've been doing this for about a week.
Yeah. No, years. You said.
Yeah, yeah. You
Years?
told you
Years.
you
You've
let
been
it
on.
slip the
You've
other
been
day.
on.
Yui.
You've been on
7
politics
years
and
you've been in this.
yeah, for years.
Remember when
Yeah,
you
debate,
started
yes,
talking
yes.
to Brenda? When you first started in here, you were 18. Remember? Young lad.
Politics.
Man and boy. When I met Brenda.
I've been debating politics for 7 years, but
There you
geometry
go.
has been about a week.
Just rhetoric and argument. You don't know anything about this stuff you're talking about. You just know how to craft words. That's
Yeah,
your
but
thing.
I don't see an objection.
And that's
to
what you try to use to squash people into small spaces where you can claim some victory. And you
But I don't see an
practice that for
objection.
years.
I'm just seeing like a critique.
You practice that for years. That's your entertainment. It's what gives you, your joy in life.
Yeah, but I don't see.
You
like,
don't
an
have any
actual
evidence. You don't have any proof, and you don't have any truth.
I've got a globe proof, an ultimate one, 3.0.
You have no proof. You haven't, because you've only got the words. You're relying on Manufactotum and Peter to back you up with the rest. And now you're
Yeah, I am.
bullshitting about water that you haven't got a clue about. You
I'd
haven't got a
say it's
clue. So stop
mutually
talking about it.
Ideal agreement where they inform me and I put it into
You
form.
crafted some words, and you like to try and get dominance over people with
You
your words.
nearly sound confident when you say you have a proof.
Yeah, nearly.
That's all you do.
Basically, nearly.
Proof. First of
You
its
just
kind.
try and beat
Yeah.
people with words and claim that
Do you not
you have
see your
some power.
bullshit,
Take it as a
everyone?
compliment.
Making something
move
up.
on.
Yui.
No,
Do you
not at
see it?
all.
It's a game to
You're clever with words, but yeah.
Yeah, I know
Yeah.
it is. I know, but I just want him to just to say that in front of all of us that he knows what he's doing, that he's actually manipulating words. He can see what we've said that's wrong with it, and you've got two other guys, working alongside.
He agreed with you. He took your criticism seriously.
I wrote them down. I put them in a chat, and I said
From a
these are the
fantasy.
corrections we're going to make. Right?
You've
So-
got no proof for this.
And you're talking to a load of guys that know what the water level is.
You have a model.
Proof.
You have a
just
model.
The accusations of dishonesty.
Yeah, it's dishonest. Exactly.
No,
You have a model. Reverse.
we took all of your objections to the debate and we wrote them so we can.
You haven't. You don't know what you're talking about, though.
You don't live on a.
You've just got a model.
Yeah,
You've got a
ignorance of
model.
geometry.
You
is what
reverse
helps you
engineer.
with
Worst
logic.
rhetoric I've ever heard.
You're reverse engineering a model.
Look,
and trying to explain it backwards. But you can't prove any of this.
Thought-provoking
It's all conceptual. It's all a model.
Oh, it's a model. All right, sure, whatever you want.
Well, just show me the 24 feet. That's all you got to do.
The 24 feet? Oh, now
24 feet. 24 feet over a body of water that's 6 miles long.
What's just happened?
That's reality.
You sound silent 24/7 now.
No, that's the reality. It's nothing to do with flat Earth. It's the reality.
It's something to do with it.
Now, if you can show that and prove it to me, I might think something different. But you can't. You can't. You've just got conceptual ideas that you've just wrung your heads around for days and days and days, and how you can win this argument. That's all you're here for.
There's real world examples in that argument, Erdebet. It's not conceptual purely.
What, like
nearly
like traveling in a straight line, and you think you're traveling on a great circle? That's common sense.
No. So, for instance, where's the PDF? Give me a second. We have pilots use spherical geometry for flight planning, deploying great circle routes for fuel efficiency. That, to me, does not sound conceptual. It sounds that it exists.
Sounds. You've got no proof, though, have you? You've got no proof. That's just words. You need somebody else to back.
Hey, does everybody remember that saying "Cool story, bro"?
Yeah.
Those are cool. I remember those.
I think I got another bingo.
You know, it's like going up with it. It's like the gas pressure, the gravity, the all that stuff. It's just a nutter.
Yeah. So this is where
and all this model of yours is a nutter.
This is no.
Because you got nothing.
Mine's an because right now I've just given you an example in the real world, and you're nuttering it.
You don't know anything about it, Yui. You don't know anything about it. You're just speaking words.
Aeroplanes traveling straight lines, mate.
It's weird.
Quickest
And I
route
think
is
this
from
is
point A to B.
Yui, do you remember that day? Do you remember that day when that guy came on? He said he was a pilot. Do you remember that guy who said he was a pilot and he flew in straight lines? Remember him telling you that?
Steele's not a pilot. He plays pilot flight simulator.
Not Clay. It wasn't Clay. It was that new guy, Noah, he said. Don't think he was new, but he said he flew planes and Bev spoke to him. So you fly your plane in a straight line, don't you? Yes, he said.
I don't know if you asked him how he defines a straight line. I'm sure if I told
seriously, you have to ask somebody how they define a straight line after they've told you they go in straight line.
I'm sure if I said to him
that can only happen from a globe believer, right? I don't think anybody else could ever be confused about what a straight line is.
I gave to him two
model affliction.
Two options.
Give to him two options. God, that rings a bell, doesn't it?
Yeah. And I said to him,
do you know how he navigates, Yui? Do you know how he navigates?
More correct when you're plotting flight paths. Do you do this with a straight
do you know how he navigates in that little plane he was flying?
Line, or do you do it with an arc?
No. He looks out of the window and follows the roads and the landmarks.
Like a private little, flies a little plane?
Straight?
That's what he was flying.
Yeah, well, I want to talk to commercial pilots who fly long.
So he was flying straight.
Yeah,
how does he know?
Flights, please. Not.
Oh God, how does he know? Seriously?
Yes, seriously. That's a serious question.
Go from point A to B. Yeah, it's a straight line. That's what you need. That's your perfection.
How does he know?
They're not going. Well, maybe the wind's blowing. Maybe it is. Maybe all these different things come into it. But the ideal is the straight line, which is on the map, which has been measured.
How would he know? How would he know if he were traveling in a perfectly straight line?
Got an altimeter that keeps his wings level.
It's not about traveling.
Horizontal.
How would he know?
Why. Because that's what
he's following a map.
Instrument shows him.
Because the map is straight.
So he doesn't
I would imagine.
Talk about your loaded questions.
I would imagine once he got to altitude, he wouldn't touch anything. He'd just leave it alone and it would go straight. That's what I would.
Moving.
Put it this way. When a pilot plots a flight to the United States from England, right? I've traveled that distance, and he has a flat map in front of him.
You sat on your ass and watched a bloody video. What are you talking about?
All right, I need to get to England, right? And
you don't know that, Louis. Stop it, Yui.
Erdebet.
Stop it. You were not in the cockpit.
You don't know he was trying to get to England, Yui.
You were not in the cockpit. You watched your in-flight video and drank some. That's it.
You climbed into a simulator.
For instance,
you can watch the picture on the back of the seat.
That I crossed over Greenland.
Stop fucking thinking you're something you're not.
Because I could look out the window and see.
And what does that prove?
Below me, right now, on a flat map, if I was going to draw
what flat map
from
what are you talking about? What flat map?
England, it will not.
What flat map, Yui? Yui, which flat map
all
are you looking
maps
at?
are flat.
So when he plotted it, he would have plotted an arc.
Oh God. Well done, Yui.
Yeah.
All that from sitting in your seat and looking at a picture on the back of the seat.
Yeah.
Yeah. Well, incredible. How do you
Yeah.
know it was Greenland below you?
Curve line.
How did you know that? How did you know that?
Curve
Looking out the
line,
window
dark.
at some land and some water. How did you know what you're
Because
flying?
the cartoon in front of
I
him
could
said it was
see
Greenland.
from the window.
Oh, it said it. It's written on the map on the ground, is it? Large white letters.
Oh, what reality are we in right now, Annabelle?
What the hell
do
are
think,
you
like,
doing
Do
anyway?
you think like it was
Talking
just a
about
coincidence I was flying over mountains,
aeroplane.
glaciers in Greenland?
things you don't
Coincidence.
understand. No
Pure
experience.
coincidence. Come on, Annabelle.
Come on, Yui's. This is ridiculous.
Are you
Talking
saying
about
it's hard to
things like that.
tell? What you can't put a 1-to-1 between being over Greenland and looking at the flight map and saying, "No, that looks like Greenland to me."
You know the difference
If he
between Greenland and Newfoundland when
if
you're
he
flying?
landed then, do you think he
didn't.
would have ended up in where?
He didn't land there.
If he did,
So you couldn't say
what's the
anything about
likely
it, could you?
What's the likely chance he would have actually landed in Greenland? Very likely, because there's no fucking other
No
place that
idea. I
looks like
wasn't
it.
there. How do
Right.
you know?
This is just
How many
just
times have
FE.
you flown
This
over
is
Greenland?
24/7 FE rhetoric right now. We've entered broken minds. That's what we've
You
entered.
went into an aeroplane, Yui.
Yeah, and he's saying that I can't know I was over Greenland. I could look at it and
You
not
jumped
know
in an
it's Greenland.
aeroplane to do geometry.
No.
Yes, you did.
Nothing to do with that. It's an example.
You were an example of a straight line.
Of when a
In
flat
an
map might look
aeroplane.
exactly
Greenland.
like the
Geometric.
direction of
In-flight
going.
movie.
It's an illustration that when you fly over the world
It's not
in
like
long
nearly.
distances, you can make an obvious assessment that you did not go in a straight line. If it was flat, that is, like a map.
But when the pilots talk about straight and level flight, they don't actually mean straight and level flight.
Not the way
Well,
you
I
mean
don't know what they define those terms to mean. I wouldn't.
Get out of
What do
the
you mean, not the way you
aeroplane.
What do you know? Manufacturer. What do you know? You're a pilot?
Joke.
Are you?
Why do you make such big claims when you haven't got any evidence or proof of it? You've never done
Same
it.
as what they do with all the other
Because
stuff.
that can only mean one
Because
thing.
somebody else described it. The
Mhm.
same as you're nearly spherical.
Yeah.
It's not that.
Let me put it this way,
So
right?
on a
There's
globe, that would make perfect sense what that pilot said.
You know, in your head it makes sense to you, but that doesn't mean that's
Also.
reality.
Sure.
Yeah.
Because you haven't got any proof of it. You can't see it. You've never seen it. You've never been to any extremities. You've never
Nor
been
does
high
the
enough.
pilot you talked to who said he went straight the whole time.
I didn't speak to the pilot. You did. The guy with the other day, he said he'd gone straight. That's all
I
I'm
didn't
saying.
speak to a pilot.
No, we
I
don't
think-
know.
I
if
think-
these
I
people
think
that
there's
claim
this-
they're- we used to have a-
block.
Hold on. We had a guy that claimed to be a pilot in here, come in here, FE pilot or something he was called. And it was just absolute bullshit. He was not a pilot.
If he's flying like from a village to a village, he's
What are
probably
you
not going
trying
to
to
be. He's
do
probably not
with
going to
an
have to think too
aeroplane?
hard about the direction he's
Wow.
going. Right.
Like, what's
but
the point?
The question of large distances is that I know that
That he
between
doesn't
England
go in a
and
straight
the
line.
United States, you don't go up. You go down. Lower latitude. United States is at a lower latitude than
Down.
England.
How do you know?
Down?
In an
Straight
aeroplane.
line.
like,
Oh, he's
I
on
mean,
about the straight line on the
obviously.
vertical.
Okay, you know what? I'll say you go southwest. Right there, you go. That's more clearer. You go southwest to
Is that
the
a straight
United
line?
States. Now,
Is that a
at
straight line,
no
Yui?
state
Hang on. You go from UK southwest.
on a flat map, you would go south.
What flat
west.
map? What's that? What flat map are you talking about?
Just any
the one
flat map
where,
you could think of.
What, a flat Earth model map are you
and
talking
Greenland
about?
does not
But
exist.
Greenland's not southwest.
Between England.
Greenland's not southwest from the
United
UK.
States.
All maps are flat. All of them.
And southwest is the same on all of them.
And southwest is not where Greenland is
That
from
was
the
his
UK.
point.
Wow.
Exactly.
So why were you going southwest and you went over Greenland?
If I was
Oh,
looking at a flat map, that would be the direction I'd go.
But because on a globe, the shortest distance to New York was not just going southwest, right, in a straight line. It was an arc to southwest, right? On a flat
Don't
map.
say
Are you
right at the end of
talking
it. Why
about
would you say
Map,
right
that
at
is.
the
It
end
would
of
look
it?
like an arc on a flat map.
sharp 90-degree turns? Is that what you're talking
It would
about?
look like it was going north.
That's amazing logic you
then
had there.
south on a.
And by the way, have you been hanging out with Nathan Oakley? You say flat a lot. You say flat plane, flat
I don't know
map.
if I'm
Sound like a
articulating
flat
it
earther.
very well, but the point is that if I was going to draw my route on
Stick
a
to the
flat
words
map,
and try
right,
and make that work.
if I
for
was
you,
going to draw
Yuri.
my
That's all
route
you
on a
got.
flat map, I went north, then southwest, right?
You didn't make a
Yeah,
sharp
you
turn in
think
that
you might
airplane?
did.
If you were
Come
going to go
on.
in the UK, right? let's imagine we're using the points on the grid in the UK. Please explain where you're going.
In the UK, I don't know. I mean, I'm talking about going to America.
No, we're in the UK, aren't we?
I've not been on
Yeah,
a plane UK to the UK flight, so I'm.
But you can
In
see
reality,
the
on the
UK
land.
map. It's all mapped. The land. It's so we can understand. So where are we going from? Let's say London to Glasgow. Let's say
Go
that.
north.
That's north, right? It's a straight line.
Straight line. Oof. Don't know about that, Bev.
North isn't a straight line. Are you kidding me?
Well, on a flight, if you're going from London to Glasgow,
no.
which is
Get
in
out
the
of the-
direction of north,
Not a flight, on the ground,
not a straight line.
on the surface of the earth.
Yes.
Right, now where are you going to go? We're not talking about flying. You're going north. It's not a straight line, eh?
Well, I was talking about flights. I don't know why we just talk about walking.
No,
What's
well,
the
we
what's the
just
difference between
changed. Bev
flying
asked something
north
else.
and fucking driving north?
Well,
Because he's trying to do
No, I
geometry
got you.
with
I mean-
an aeroplane. Come on,
I mean,
we've
Yeah,
seen
I
this
know.
I would
millions
say
of
the
times
difference is
before.
the difference
Just
is
put you
is
in
that
an imaginary
the
state.
difference-
Get up in an
difference-
Hey, Yui,
aeroplane, and he
the
can
difference
convince
is,
you
and I'm
it's
and I'm
curved.
thinking, I'm
If he
thinking
draws
about
a
Yui,
what
don't
curved
Bev
leave
line
the
on
ship.
a map,
Oh, okay. I'm thinking about
Yeah,
what
don't
Bev
leave the
might.
ships out of the
I'm thinking
conversation.
about
You
what
can
Bev
use a
might
ship
say,
too. You don't
right?
have to use an airplane.
No,
You know
right.
what I
I'm
mean?
thinking about what Bev might say, right? I'm thinking,
That's the
if
problem. You
I
always
said
say
I go
what about a hot
straight,
air balloon?
if I said,
Anyone
if
ever
I
thought
said
of
I,
a hot air
if
balloon?
I said, if I said
It's
I
a
was
little
going
bit
straight
more
to, if
peaceful,
I
isn't it?
said
Get a blimp.
I was going straight to Glasgow, then you would
Yui,
say, well, how did you get it? The M6 isn't straight, you know, like, or
you have a
something along
problem with
those lines.
honesty. That's your
So
problem.
it's a
How
question
about a
of
dirigible?
something that we can
That'd be
all
good.
agree goes in one direction, a plane. Perfect
North.
and
We only
simple.
said north. We said north.
Hey, also, why do you
That's
think
it.
they called it a plane, Yui?
A plane? Oh, that's because it's nothing to do with a flat Earth. But one second.
Flat.
I know it's
What's mean flat? Plane.
Flat,
It's
where
called a
you gonna
plane.
get?
See, I told you he's been hanging out there with Nathan Oakley. I
Huh?
knew
Here
it.
we go.
Fucking knew it.
You bring more flat than the flat earthers.
Isn't it like the hydroplaning of the not hydroplane, whatever it's called?
Yeah. 1 second, I'm looking.
Also, why do you think they call it a peanut?
Peanut.
Yeah.
What the
just,
fuck
just
has that
That's
got to
what
do
they
with
pay.
The Earth
plane?
is a peanut. Wait a
okay,
minute. They
so
start
yeah,
calling
here we
the
go.
Earth
Here
a
we go.
peanut?
Arrow meaning
Who
air.
does that?
I'm
Planos.
lost.
I've never heard
Planos.
anybody do that before.
It's a conjugation of two words. Aero
It's what-
meaning air in French, and planos meaning wandering in Greek. So that became aeroplane. Now, obviously, some guy here watched a
You don't
YouTube
think there's
video,
a reference to
watched a,
plane,
watched a
as in
YouTube video
the,
and
the
transposed the word
geometric term,
plane
a
onto a
plane?
Euclidean plane
You got your
somehow.
conspiracy YouTube video out again.
Yeah.
And
Yeah,
put that
someone's
on
doing
everybody that they get their information from
doing some
YouTube videos,
conspiratorial stuff
which is
on
the one
YouTube,
that
yeah.
you presented us today
I
was a
just want
YouTube
to be
video.
clear.
The
that
ultimate
first
glow
of all,
proof is a
even if it
YouTube
did
video.
mean Euclidean
Yui.
plane when it was coined, it doesn't matter. But it wasn't even
The
done that way.
ultimate glow
So
proof
you're
is a
making up your own
YouTube video.
The
knowledge.
It's obviously
etymology of that
conspiracy.
counts.
It doesn't matter because it's indistinguishable. It's okay.
The law of imperceptibility.
I mean,
So P-
unless you're talking about large scales, which you guys are, then it is distinguishable. But they
They don't
And
know
peanuts.
what scale that is. It's just big.
yeah,
Big.
just
I'm
yeah,
hungry for peanuts
small,
now. That's all I'm
big,
thinking about.
big,
Peanuts.
small.
Peanuts
Yeah.
is what they feed monkeys, and
Salted
maybe
peanuts.
that's what Peter's paid you with.
No, peanut is neither pea nor nut.
No, it's just what you've
Oh.
been paid.
It's
Peter's
what
monkeys.
they call it is all.
But a plane that, you know, flies on a straight path isn't nothing to do with the plane. Flies on a horizontal path.
I just
nothing to do with that.
Shut up, peanuts.
The two words
This globe
that came together to make aeroplane.
Oh yeah. Because you live on a
Going
globe, right?
About how somehow it means Euclidean plane. Somehow I don't get it.
Tis globe.
Yeah, well, look. I mean, let's pretend you're right.
You got so many excuses.
World. Let's enter
I've never heard so
YouTube
many
world where
fucking
we get our
excuses.
knowledge from YouTube and say, okay, it's true. It's referencing a Euclidean plane. Does that mean it is a Euclidean plane? No. There you go. Job done.
Oh yeah, no. But imagine if they called the thing you fly on a globe. That'd be good, wouldn't it? Maybe they should change the name to a globe. Flying on a globe.
Yeah. Why not?
What about if you watch the video? What about if you watch a video called Ultimate Globe Proof on YouTube? Doesn't prove it's true either. There you go.
I've got Ultimate Globe Proof.
I think we've got a better one, so look out for it, guys.
Yeah, but the real globe uses imaginometry.
And that's what we're being told to buy into.
Yeah.
Imagine this. And then Peter comes out and says, see, I told you that's where you live.
Yeah.
Well, I don't want any part of that.
I guess they kind of use nearly imaginometry. It's not true. It's nearly that.
Well, I'm
not that.
I'm the imaginometer here to tell you that all you given in terms of robust criticism was, I don't like that word.
Is that what you got?
It's not real.
That is the best you gave me.
No, there was one more thing, Yoey. One more thing. One more thing. They said spheres don't exist.
I didn't know. I didn't catch that, but you know, it's
well,
I missed that because I definitely know spheres exist. I've got one.
Yeah, but they reject spherical geometry, right? So if there is no spherical geometry, which is basically a mathematical description of the nature of spheres.
Peter,
if there is no spherical geometry, then there are no spheres.
Euclidean, admitted by you.
But it's not. But it's not.
I'm going to try
it's called non-Euclidean. It's a form of non-Euclidean geometry.
So I'm going to try a modus ponens here.
Because it treats a sphere as a two-dimensional.
Rob.
Yeah. Well,
they
I will try this.
They said spherical geometry was Euclidean.
If spheres exist,
don't be confusing them by saying it's something
geometry
different.
Describing them. Spherical geometry does not exist, therefore there are no spheres.
You said that?
No, that's what you said.
No, I never said that.
All of you.
I can Google spherical geometry right now.
Real. Yeah, I asked you earlier, do you recognize the existence of spherical geometry as a branch of mathematics? You said no. That implies that
it doesn't exist. Like where does it exist? Where?
In mathematics.
Okay, and where does mathematics exist?
In human brain.
On your piece of paper? Or in your head? Okay, so this is all existing within your mind.
Okay, let's take it to the next level. Do spheres exist in reality?
Yes.
Nearly spheres.
Okay.
Oh God.
Okay. So does spherical
geometry I'm with you spot on, but I'm playing along. I'm off work now. I'm playing along.
Do spheres exist in reality?
Yes, sir. I have a soccer ball in my backyard.
Good. Does spherical geometry have applications in reality?
I don't think so.
I can take that. The sphere that you have,
hang on.
In reality, it cannot be described using spherical geometry. Its properties.
If I only want to deal with points on the surface and treat it as a two-dimensional surface,
why so shy? Why so shy? Why not? Why not take your sphere that exists in reality and, for example,
because it's Euclidean. It's
the shortest distance on its surface.
Hang on. But the sphere itself is a Euclidean object.
If that makes you feel better, brother, then so be it. Yeah.
Well, no, I'm just telling you it is what it is.
Okay.
So if you want me to apply some non-Euclidean mathematics, no, stop. Let me finish. If you want me to apply some non-Euclidean geometry to the Euclidean sphere, that sounds ridiculous.
Okay, let's try this. Take a sphere in reality, not imaginary sphere, real sphere.
Yeah.
Mark 3 points on it.
Yeah.
And connect them with shortest distances on the surface of that sphere.
Yeah.
Not through the sphere, on the sphere.
Yeah.
And then please measure the angles between those arcs.
There will be no angles on arcs because an angle is let me answer. An angle is the inclination of one straight line to another.
Okay. Can there
so on those arcs that you want me to draw on the ball, they're not going to create a triangle. I'm sorry.
Okay, calm down and keep up with me, okay?
I'm calm.
Can angles exist
you just keep cutting in front of me.
Can angles exist between planes?
No, I'm going to leave you with these jokers. I'm going to bed.
See you later. Can angles do angles?
It's still early for me. I can go all night.
Yeah.
Do angles exist between
planes? Bev probably wants to go to bed.
Yeah,
so maybe we should let him round out his show.
Nobody's watching.
Yeah, nobody's
left. You just sound like you. I don't know.
So do angles?
You fizzled out. Your little fireworks. Plopped out.
Do angles exist between planes?
Well, hang on. Let's let Bev round out his show. And if you guys want to talk to me, I'll be here for a bit.
Yeah. Okay. Yeah, thanks for a lot for watching. Globe proofs. And the second one, not too sure about that. Still in the beginning stages. They normally take a few hours of working out.
Yeah, I'm going to try and work that out. Thanks, Bev.
No problem. Rob Key.
Nice one, Bev. Take care, Bev. Have a good night.
Yeah, thank you very much.
Okay. Do angles?
Let me wait a minute. Let me get the Buster song up.
Anybody
got any requests, Rob?
Machine Men.
What's that called?
I don't know.
There you go. Got it.
All right. The greatest.
Thank you very much.
I'll be back when it's over, guys.
See you
I'm just going on death.
Possibly, maybe Monday.
You have the love of humanity in your hearts. You don't hate, only the unloved hate. To those who can hear me, I say, do not despair. The misery that is now upon us is but the passing of greed, the bitterness of men who fear the way of human progress. The hate of men will pass, and dictators die, and the power they took from the people will return to the people. And so long as men die, liberty will never perish. Let us fight to free the world. Let us all unite. Don't give yourselves to these unnatural men, machine men with machine minds and machine hearts. Let us fight to free the world. Soldiers, don't give yourselves to brutes, men who despise you, enslave you, who regiment your lives, tell you what to do, what to think, or what to feel, who drill you, diet you, treat you like cattle, use you as cannon fodder. Don't give yourselves to these unnatural men with machine minds and machine hearts. You are not machines, you are not cattle, you are men. You are men. Let us fight to free the world. You have the love of humanity in your hearts. You don't hate, only the unloved hate, the unloved and the unnatural. Soldiers, don't fight for slavery, fight for liberty. In the 17th chapter of St. Luke it is written, the kingdom of God is within man, not one man nor a group of men, but in all men, in you. You, the people, have the power to create machines, the power to create happiness. You, the people, have the power to make this life free and beautiful, to make this life a wonderful adventure. Then in the name of democracy, let us use that power. Let us all unite. Let us fight for a new world. A decent world that will give men a chance to work, that will give youth a future and old age a security. By the promise of these things, brutes have risen to power, but they lie. They do not fulfill that promise. They never will. Dictators free themselves, but they enslave the people. Now let us fight to fulfill that promise. Let us fight to free the world. Let us fight to free the world. Let us fight for a world of reason. A world where science and progress will lead to all men's happiness. Soldiers, in the name of democracy, let us all unite. Let us fight to free the world. Let us all unite. Let us fight for a new world. You, the people, have the power. Let us all unite. Let us fight for a new world. In the 17th chapter of St. Luke it is written, the kingdom of God is within man, not one man nor a group of men, but in all men, in you. You, the people, have the power. You, the people, have the power to make this life free and beautiful, to make this life a wonderful adventure. By the promise of these things, brutes have risen to power, but they lie. They do not fulfill that promise. They never will. Let us fight to fulfill that promise. Let us fight to free the world. Let us fight to free the world. Let us fight for a world of reason, a world where science and progress will lead to all men's happiness. Soldiers, in the name of democracy, let us all unite.